software should be about. It's usually written, most of the time, it's written by non-technical people, product people, business people, you name it. And they usually explain their intent of what the software should be in text. This software should do such and such, introduction, system overview, design consideration, and what's not. Now, the problem with software design document is that they are write once and read maybe once. If they are boring, probably less than once. And the question is why? Why we as software developers are not really married to those software design documents and not like love them as much as the people who wrote them think that we should love them. There are a number of reasons. First of all, there is a lot of misunderstanding going on. And we think that we speak the same language, but not really. Now, bear with me here. I'm going to try a New Zealand joke. I'm not sure it will work, and we will see. Did you get what I wanted? No. Well, I tried. So what I tried to say, there is a saying, bring a plate, which basically in New Zealand, that means you should bring a dish. And then people who are not from New Zealand come with empty plates because they've been told to come with a plate. Well, sorry, I tried. Well, yeah, so what I try to say here, that even if we do nominally speak the same language, English, it's not really the same language. So that's might be part of the problem. The other really big problem is the curse of knowledge. So I don't know if you had this experience, but sometimes when I went to university and I get into the class and then the professor starts with some overview, like this is what we're going to talk about, and I'm kind of lose my concentration for a second because it's just an intro, and then like 30 seconds later I look at the blackboard and it looks like that. And I'm like, what happened? What did I miss? One of the problems that cause the curse of knowledge. The curse of knowledge is when we understand something, we think that it's very obvious because we understood it, it sits well in our head, it's pretty clear to us, and we assume that because it's clear to us, it's clear to everybody else. And that's a very large reason for people assuming that other people know stuff and understand stuff and can understand stuff. And really good teachers know the problem of curse of knowledge and know how to battle it, but other people who are not trained to spot it might miss it. And when we speak about our interaction with non-technical people in our organization, a lot of those people, most of those people, never think about stuff like curse of knowledge. So they have assumptions that they have in their head that they assume that you have them in your head, and you are not. So it's a specialized type of lack of context. So why they don't work? Human misunderstanding, including curse of knowledge and other context misunderstanding. Context is not shared enough. Stuff that they know, they assume that you know, but you don't. And vague responsibility boundaries. Software definition document speaks about what should happen in software, but not really who is in charge of make this thing happen. This is a very old picture that I hope is not relevant anymore in the world of IT in 2025. It used to be the thing when there was this animosity between the developer and the tester. Anyone thinks that it's still an issue now? No, because it's not. Because we as software developers want to write high quality code, and we understand that QA people and testers are here to help us and make our life easier. Next iteration of this war was between the developers and ops. If you remember, there was a thing before DevOps when there was developers who threw their work kind of over the fence and went home at 5 p.m., leaving the ops people to deploy the scrap during the night and sit on outages and what's not. This is also kind of not a thing anymore because DevOps kind of sort of solved it. But this is real. This is not going anywhere. The animosity between technical people and product and business people in general, it's still very, very in effect because of what we spoke about, and especially because of the vague boundaries on who decides on what and who does what. Right, so those software documents are landing in our lab, and we expect it to do whatever it's there when the context is not clear, and all the problems that we spoke about. So basically, we have a trust problem not only with AI. The whole idea of us not knowing what to do and the product people not trusting us to do the right thing brings exactly the same problem. We have a trust issue, but not only with AI. Next thing you know, this is how our software looks in 2025, and that's a Venn diagram. And I bet the majority of you agree. Think about software that you like and software that you know really, really well. It's probably different software. Except of Groovy, maybe. Right, okay. But we do have working software sometimes, like occasionally, on occasion, we have working software. How that happens? That happens because a lot of overpowering the gap that we spoke about, right? First of all, good intentions. Both business people, product people, and technical people want working software and want to have a good relationship. The animosity, the lack of trust is not something that anyone desires. So we can overcome that with good intentions. We will take responsibility, we will ask questions. The business and product people will also make an effort to make sure they overcome the curse of knowledge. So there is a lot of good intentions going on. Professionalism. We take pride of software that we produce. So when we know that there is a problem with quality, we will try to fix it because this is our job. Tests and QA help obviously a lot when it comes to quality. During the entire process, we have those guide rails that are built in to help us create software that eventually works. And end result observation, right? We'll look at the software that we produce and we can decide if it's not good enough, we need to work more on it, and what's not. Eventually, we do have common-ish context. So there is a lot of context that is going missing. But in the end of the day, we work in the same organization on the same product, and we all have more or less understanding of what we want to achieve in the end, how the end result should look like, what are the technical and non-technical considerations, and all this kind of stuff. Now, welcome to the era of code generated by AI. There is no such thing as intentions with AI-generated code. There is no such thing as professionalism because it's just like a neural model. Tests and QA are not existing or written after to fit the code that it's already there. There is no end result observation because it spills the code and says, well, this code should work, right? It doesn't check the end result. And there is obviously no context because it doesn't know anything about what it tries to achieve. So our software is not great, but we are trying. AI doesn't even try. And this is what I call the intent to prompt chasm. It looks like this. We ask something from AI, and the AI doesn't understand entirely what we are talking about because it's a stupid neural network. It doesn't know what we are asking. And of course, this is like a hyperbole and exaggeration. And obviously the model, especially the programming, know exactly what Spring Boot is. But you get the idea. It lacks context. It doesn't know what we are trying to achieve. And this is exactly the problem. Now, it gets worse. The problem with neural networks and AI and code in AI is that it's a stochastic system. It's non-deterministic by design. The whole idea of AI, of large language model is that it's by design should answer something different from what you asked. So just to give you a classic example in like when people explain how does it work, the idea is that you have similarity between stuff. So a king is like a queen because they are both royalty, but it's also not because they are of different genders. So there is a slider, which is like a temperature of the network, which adjusts how close we want to find things. So we adjust it to get an answer that the queen is like a king, but it's still different. Now, if we increase the temperature and we make it to find things that less similar, and we will ask, give me something like a king, we will not only get a result of a queen, we will also get a result of a princess, for example. It's farther away because it's a different level of royalty or whatever. If we adjust the temperature to be exactly the same thing, if we will ask for something like a king, we will only get the king because that's like the entire similar thing. So by definition, we want to get results which are different from exactly what we asked. We have to give it freedom to generate different stuff. So for the same problem, we can get slightly different results. Funny story about this particular illustration. No LLM model known to me is capable of drawing an upside down funnel. I don't know why. I've been trying for at least a year. Last attempt was last night, and it cannot. It will generate a file with the wide thing up and the narrow thing down and claim that it is like this. And no matter how many efforts I put into it, it is impossible. I don't know what it means about AI or neural networks.
You're in the Southern Hemisphere. You're in the Southern Hemisphere.
Well, yes, so it doesn't work in both. I hoped that once I'm in down under, it will naturally make it the other way around, but it did not. Yeah, I don't know what it means. It's an interesting question. Right, so anyway. Now, you know the infinite monkeys theory. I just did the curse of knowledge. I assumed that everybody knows it because I know it. Did you know this? So I'm going to explain it. What it actually means, the theorem is, an infinite number of monkeys given an infinite time and infinite number of typewriters will eventually write Shakespeare poems. Because randomness, eventually it will create Shakespeare. Now, the funny thing is, considering the stochastic systems of our AI, that it is exactly what we have with AI, right? It's screwed a little bit towards sense, and it will give the right answer faster than just random generation of text. It will produce the correct code more frequently than just randomness. But in the end of the day, the fact that we're talking about stochastic systems means that there is a lot of variability. Sometimes it will get it right, sometimes it will get it wrong, and that's the problem. We gave them GPUs instead of typewriters, but the idea is exactly the same. Now, what can possibly, right? What we can do with it? First of all, we have code reviews. Code reviews are there to ensure that the generated code, either by human monkeys or by AI monkeys, is verified by someone else, and then kind of we know for a fact that it's better. Now, the code reviews have what I call the looks good to me syndrome, and it's for various reasons. We're all busy. Doing code reviews requires context shift. We have context switch. We hate context switch. And another thing that we hate is reading other people's code. that includes our code, which is 6 months or older, we hate reading other people's code. And we obviously will hate reading generated code. Because generated code has no intrinsic value. Generated human code is a piece of creation. Someone put an effort into writing this code. And we, as our fellow developers, respect that and value that. AI-generated code has no intrinsic value. No one put an effort into writing it. It is valueless for us. It's worthless. And putting now our time, instead of doing our job, into reading machine-generated code is not going to happen. So next thing we know, looks good to me on any pull request. And this defeats the entire purpose of this guardrail. So not only we get garbage generated because monkeys, we also don't really read through it to begin with because it's garbage. And then it just goes to production as it is, which is a terrible idea. Yes?
Whether or not we're using an AI to do it, we have a professional responsibility to make sure the code is correct.
Yes, so that's a good observation. Regardless of who generates the code, we have the professional responsibility to review this code. This is our job, which is very, very true. Now, it all comes down to incentives and disciplines, right? So, hey, we need to review this code is important incentive, but hey, my colleague wrote this code and I respect them and they deserve my review is much more significant incentive. And since we have a conflict of what we are doing right now and our incentive to do our, like, writing our code, and the other incentive of, hey, we need to review someone else's code, the other incentive should be very, very heavy. And a professional courtesy to our colleague have much more chance of getting our attention than just a bunch of auto-generated code. Well, yes, in theory, we should review auto-generated code as well. In practice, it will get more looks good to me than not AI-generated code.
Isn't it the other way? Because like the implicit bias is you don't really trust the machine. And you go in going, it's going to give you a bunch of garbage.
Yes.
I need to be a lot more vigilant.
That's a very good observation that, hey, we assume the code to be worse, so we need to pay more attention to code that it's worse than to code of our colleague that we cannot trust and assume that its code is good. Yes, this is also true. But in the end of the day, the question is, what do you sacrifice? Yeah, I mean, the code reviews work. The problem is the percentage of, well, I think it looks okay versus I really read through it. And there is, it's a range. It's not that now code reviews are absolutely pointless and we never look at other people's code. It is. But in the end of the day, the question is, what is the quality of our reviews? And I think that's another interesting data point to add to my research chapter is how AI-generated code affects the quality of the code review. That's an interesting question to look into some research into it. It's a good point. Okay, yeah.
So you're also injecting sort of like value positions around code generated by AI versus human beings. So if you treat it both the same in terms of respecting it, then what you should be, my point is you should be changing. You shouldn't be judging it based on what's changed.
Yes, you shouldn't be judging the code by how it was created. But that's, again, and I mentioned it, that's not how our mind operates, right? So we assign intrinsic value for something that was created by humans. And we don't assign the same value to something that was generated by the machine. It's not only about code. You can see all the endless argument online about AI-created art, right? And there are a lot of people that will claim that AI-created art is absolutely worthless, not because how it looks or doesn't look, but because there is no artist behind it. It's the same idea. It's the idea of the end result. It's not only judged by itself, but it's, for us, it's also judged by what we know about the process that creates it. And it's true for art, it's true for code, which we all kind of say to ourselves that it's an art. No one else believes us, but we keep telling ourselves, yeah. So basically, right. So AI coding agents do this to software quality, and again, the research kind of proves it. And I think we all know it by trying it. We know that the software quality that generated by AI is not great. So what can we do about that? What if we could somehow verify that the end code that we have is exactly what we asked it to do to begin with? That would be nice. Let's see if it's possible. This is what I call the intent integrity chain. Let's see how can we build this chain of trust from intent all the way to the code. Now, if only there was a way to ensure that code does what it expects to do, it is tests. Thank you very much. Of course, right? So tests are our guardrails, and they can also be guardrails for markers. We write the test first, and then we let LLM implement the code, and then if the test passed, the intent is captured correctly. That's pretty obvious. We can then look at the quality of the code that was generated to pass the test. It might be great, it might be terrible. We might want code reviews to ensure that this code is better, but the intent is captured if the test passes, right? It's pretty obvious. This looks like test-driven development, which has its own like a comeback moment now with AI. There is a lot of talk about test-driven development with AI because of exactly this reason. Now, the question is who writes the tests? And obviously, I mean, developers should probably write the tests, but developers are not the ones who set up what the software should do, right? We started with that. There is product people and business people who decide what the product should do. Will they write tests? Probably not. Because they are not technical people, so they won't write tests. Now, if developers end up writing tests, we still have the chasm, right? So software definition documents written by non-technical people in plain English or whatever language, and then something, and then developers are expected to write the tests that described what in the software definition documents, and then LLM generates code to fulfill the tests. Now, this is still our chasm because the misunderstanding comes here. Now, there is also another problem, and the problem is developers don't really do test-driven development. And developers don't do test-driven development for various reasons. One of the reasons is we are based for action. When we think about a problem, most of us, I know I do, I think about the happy path to solve the problem. I have an algorithm in mind. What code should I write that will do the thing that I want it to do? What I don't think about is how the test will look like, how the exceptions will look like, and everything else. Because we already know how to solve the problem. What we want to do is not writing tests, is actually writing the solution to the problem. So this is, so this is one of the reasons why we don't write tests before code. Now, there is also another problem in TDD working writing the tests and not writing the code. I will get to it a little bit later because it's true for other stuff as well. So, okay, so here is the problem. TDD doesn't work without AI, and probably TDD won't take now, and we see that it's not, the world by storm now with AI as well. And we still have the chasm problem that we want the technical people to define what software does, and tests is not that. But what if it almost won't look like code? What if we're going to write specifications in English or other human language. And then people and product and business people can actually read and write it. That looks like,
Specification by design, BDD.
yep, that's BDD, right? Behavior-driven design or specification-driven design, or someone mentioned Cucumber. That's exactly that. Now, how is this going in the observable universe? Not great. And that's because business and product people are creative natures. They want to write the software definition documents in their own language. They have some structure, but in the end of the day, what goes inside is, let's describe the software and what's not. The structured spec is a little bit too structured. So we end up with developers writing the specs. And that means that we still have the cosmos. Are like a very abstract software definition documents that are read by our business people, and then something, and then the developers write the specs, and then the tests are generated from specs in Cucumber and what's not, and then LLM generates the code to the spec. We still have the chasm that people who write the software definition documents and the people who understand them and then write specs are different people with the prompt to intent to prompt chasm. And developers don't like BDD, even less than they like test-driven development. If developers say to write test code, you can only imagine how much they hate to write specs, which is not code. So yeah, we still have the same problem. What we can do, we have a great tool of generating text. It's called GPT and LLMs in general. So how about let's do the LLMs to do the work? We have the software definition documents, which are now written by product and business, but they are now our prompt. And then LLM creates the spec in the structured language of Cucumber and what's not. And then, this is very important, since everybody can read the spec, as it is almost plainly English, the people who wrote software definition documents can actually read, understand, and agree on the spec. Now, once everybody agreed on the spec, we can let LLM generate the tests from the specs, and then let LLM implement the tests until they pass. That sounds like a good idea, right? Well, yes, but no, because monkeys, right? We cannot trust monkeys in doing the chain because they will skew the chain for whatever end result they create. So once we let them generate the tests from the spec, test can be completely off. And once we let them implement the code to pass the tests, they can change the tests to match the code and not the other way around. We cannot trust the monkeys, and that's exactly the problem. Let's see how we can solve that. Now, here is the list of our chain in terms of artifacts produced. So we have the prompt, it's created by humans, and that means it cannot be trusted because humans are also monkeys, we cannot trust them as well. And then we have the spec, that it's generated by LLMs by the monkeys, which means that we cannot trust it. And then we have the test, which generates by the monkeys, which means that we cannot be trusted. And then we have the code that generated by the monkeys, which means that we cannot trust it. It's not a great intent integrity chain if we cannot trust any of the steps, is it? Let's see what we can do with it. Yeah, not great. How can we solve it? We can replace monkeys with algorithms wherever possible. So, for example, test generation. Test generation, as I mentioned, is something that in our first idea is generated by monkeys, which means we cannot trust it. The tests can be completely different from what the spec actually said that it should be. So how about we remove the monkey and we actually trust an algorithmic run of executable specifications. Cucumber, as someone mentioned, is a great example of exactly that. With Cucumber, the specs are expressed in an executable language. And then we don't need the monkeys to generate the code, the tests, because we can just run the specs to verify it, and then this is solved. No monkeys in the picture anymore. Another problem is prevent monkeys from messing with validation. Now, if you ever asked AI to write tests for a certain code, there is a very good chance that it made the tests to match a code which have bugs. Now, TDD in the naive form of AI doesn't really help, because if you write the tests or ask AI generate the tests and then ask AI to implement those tests, it will change the tests as much as it changes the code. So it doesn't really verify anything if it can match the test to the code and the code to the test. So generated code by the monkeys is also a problem because it will change the tests. What we can do, we can lock the tests away. So once we have spec or tests which we know for sure that express our intent, we just make them read-only. And it can be as easy as making the files actually read-only on the operating system. There are IDEs that can prevent AI from touching certain folders or like a certain directory structure or file types, and we can do it with those IDEs as well, or those AI tools. But the simplest way is just changing the files to be read-only, and then we protect them. So now the code is protected, the test is protected, which we are making progress. Now, for everything else, this is Ronald Reagan, this is Mikhail Gorbachev, and the year is 1988. They meet in Reykjavik to discover nuclear disarmament, and Reagan says, "Doveraj, no proveraj." My Bulgarian friends are smiling because they probably understood it. For everybody else, what he said in Russian was trust by verify. And that was about, yes, we trust you, dear Soviet Union, in nuclear disarmament. Sure, of course, because why not? But we will send some people to look, to watch over you. And that's exactly what we need to do. We need to trust by verify for everything else. So how do we do that? We have a prompt that is created by humans. It definitely should be verified by other humans. We have a lot of stakeholders that need to look at this prompt, at the software definition documents as we defined it, and agree that this captured our intent. This is the software that we want to give. And then the specs are generated by monkeys, but they are human readable. Once the specs are generated, everybody go back, the same people who are all the stakeholders, and check that what we have there is what the original intent was. There are two types of things that can be discovered. First, human misunderstanding. We wrote the prompt in a way that when even directly understood, the spec is not what we actually intended. Just because English language or other language is not perfect to express software requirements. And then we can go back to the prompt and edit it, or just edit the specs directly and do the adjustment that we want. Another problem, monkeys screw up. They understand something from the prompt and generated something in the spec that was clearly not what we wanted. And then again, we do the same process. Now, there is no difference in those two. Whether we didn't express ourselves correctly or the model didn't understand us, it doesn't really matter. This is the intent to prompt chasm that we are bridging with this review. And then the test, there is no problem. It's generated by algorithm, or we just run the specs, so there is no need to verify additionally, and the code is generated by monkeys. But again, because the tests or the spec are protected, we can trust the process to actually generate what we want. So now we don't have any problem in business people needing to read the tests and the codes, because there are no monkeys involved, and we can trust the problem because it's verified by the machine as well. So here we go, intent integrity chain. Software definition documents are prompts. Now, because we can run them multiple times, they are actually living documentation. They are exactly what we get in the end of the day, because they are the part of the process and not just some documents lying somewhere in Google Drive that no one will ever read again. LLM creates the specs. Everybody read the specs and approve and go back to the prompt if it's not what they actually meant it to be. And then from there, no more human reading necessary. Algorithm generate the tests, or we can just run the spec, and then LLMs read implement the read-only tests until it passes. And this is how you make sure that whatever there is in the end is exactly what we asked to begin with. And that's the nice thing about it. So everybody write text, specs are reviewed by all, because that's still other human language, and then software definition documents, now we know that they are the specs and they are living documents. And everything else is derived from the specs automatically, and we don't need to read the test or write the test or do any of that. And all code is verified by machines without trusting monkeys or humans for that purpose. And I think that intent integrity chain is what BDD was supposed to be, right? It meant to be. We define and agree on intent, and then we verified everything that AI does, either human review or automatic, and then we don't trust AI we don't verify, because it's all written from there. And the question is, okay, I mentioned Gherkin and Cucumber. They are done 2 more minutes. And you're late, so yeah, I'm almost done. Yeah. Gherkin and Cucumber are old, like 20 years old. Are they fit for this AI-centric process? Maybe yes, maybe no, right? It's good for defining behavior. It is human understandable and machine parsable. That's exactly what I want from the specs. And it's proven and it works. BDD is a thing, although not very popular, but there are a lot of adepts that believe in that and do it, and it works. There are downsides. For example, non-behavioral constraints are hard to describe in the format of given when then. It's doable, it's not very hard. Now, the good news are that the better specking for writing the spec tools emerge right now. The spec-driven AI is all the rage. Every month, there is new framework that is coming that sits exactly in this part of how do we define the spec from the prompt and then run it automatically by AI. So for example, the GitHub spec kit. GitHub spec-driven development, flip the script of traditional software development. You don't say. And then they do exactly what we just spoke. So we can install it, and this is very much like Gherkin and Cucumber spec-driven implementation, which is exactly sits in this part that we're talking about. Hero. Hero is an IDE created by Amazon to do exactly that. They generate the specs from the prompt, and then you can generate the tests from the spec and do exactly that. So there is another part here that might potentially replace Gherkin and Cucumber combination. Tessel. Tessel is a startup that started with exactly the same idea. How do we make the spec and the AI code and maintains it? And then they changed a little bit to providing specs for third-party libraries. How do AI understands what Spring Boot really is? the question that we kind of started with, and this is something that Tesla does now, but it's still very, very related. So by the words of Andrej Karpathy, the hardest new programming language is English, and this is what the intent integrity check is about. We define what software should do in English. We read the generated specs in English or any other language, and this is our programming language. Everything else derived from there automatically, and the code is now interim language. It's like the Java class, what's called? I forgot the term. The code that we compile into. The bytecode, thank you. Yeah. So now the code is bytecode. It's an interim language that is going to be translated to even lower and lower layers, but our coding language is now English. So intended integrity chain generates consensus. Features are verifiable back to the requirements. We can start trusting AI more, and there is still work to be done. With that, Ej Baruch, talk to me about tax care and about end-of-life maintenance of your libraries. This is ChurConf. Use the hashtag. We're going to take social media by storm with so much of us speaking about that. And intended integrity chain is the hash code that I invented. Let's see where this goes. Shownotes.taxcare.com. This is where I go for the slides, the video, all the links. And now I can tell you there is a raffle that you can win like a vintage, very nice vintage keyboard for when you write your software definition documents. No one is going to write code after this. And you can scan this QR code, go there, fill the form for the raffle. And as I mentioned, I have tons of t-shirts. We'll be happy to hand them over to you. With that, thank you very much.
Thank you, Baruch, for the very interesting talk. So now we'll have a few minutes break. There is still coffee, water. Feel free to network, and we can start in, let's say, 9 minutes, 10:20, with the next talk. So let's have a break now.
T-shirts.
תודה.
שלום, שלום.
I just checked LinkedIn.
Yes.
Actually, self-description.
Ivan, you should get a t-shirt. You gave me a t-shirt now. I give you a t-shirt.
Okay, take one.
Yep. So you go.
And there's another. Trying to get YouTube, which is a lot more narrative. It just regular English books it, you can figure to say, hey, this becomes a fixture set or something else. That was the closest that we got to that.
Hey, you should have a t-shirt. Yes. So go to tax.com, type in this code.
Yeah, using it for
Thank you.
Because you don't need to use two shirts.
You know what? Let me think about it. So, how do we generate something that's soft? There are two questions. The first is
I'll show you my tool.
how to generate something that is immutable for like non-technical people. We apply spec, and then how can we generate tests on the spec without calculation? Those are the two questions.
And how can we get the biggest language from English?
This is impossible, but it's
Probably write it in Chinese.
I don't think they're any better. But the thing is,
The German is not bad.
yeah, but even it doesn't really matter because once the specs are written, they are your kind of source of truth, and they are less ambiguous than.
But even yeah, definitely. So just that's, because the prompts can be, even a simple sentence when I say something.
Yeah. No, but that's why after right, exactly.
It's like you chop a tree down and then chop it up.
Yeah, hang on. The alarm goes off. What does that mean? Yeah, no, but the whole idea is that once you have to review the spec, and this is kind of gives you the source of truth. But yeah, I mean, English, a lot of service and a lot of this service in centuries.
Yeah, so I just and yeah, this is so like I was the task is yes, please. It's open source for me. Yeah, and this is my GitHub homepage. Yes, let's conduct.
Hey, great to see the networking is going on. I feel guilty to make you go back to your seats. Because in the beginning I told you we need to network more, and now I need to break it, but you can continue after the session. Our next speaker also came all the way from Europe, but this time from Sweden, which is almost on the North Pole, and we're now here almost on the South Pole. So Ivar is from Jakarta, and he will have also very interesting talk about enterprise Java, because as I told you, we're now in the cloud native Java, but enterprise will always be enterprise. So let me give the word to our dearest Ivar.
Thank you. All right, so I titled this talk the past, present, and future of enterprise Java, and we'll go through some history here. But first, my name is Ivar Grimstad. I'm the Jakarta developer advocate at Eclipse Foundation. And if you want to follow me on social media, you can just pick your poison here, and I'm pretty much active on all of them. I'm a Java champion, an Oracle Ace Pro. I'm active in various open source communities like the Java Community Process, the executive committee there. I represent the Eclipse Foundation. That's the governing body of Java, if you didn't know that. I'm also an Apache committer for NetBeans, and I work for the Eclipse Foundation. I run a Java user group in Malmö. I'm from Norway, by the way, but I live in Sweden. So let's dive into this. 50 minutes of history, past, present, and future, and we will start with the past. So how many of you were not born in 1995? I'm going to do demos, so I can't do that now. So in 1995, so some of you there.
Not equal.
You mean right about Noriko, right?
Sorry?
Right about Noriko to 95.
Yeah. So Java was born in 95, and that's 30 years ago. And Java was created for set-top boxes and devices. It was literally for tablets in 1995, and it soon turned out to be very useful on the server. So it conquered the server side very quickly, and Sun came up with J2EE in 1999. So who were using J2EE back then, or have been using? So yeah, so a lot of you have been hurt by this. And J2EE is a tremendous success. J2EE is the reason why we are here at the Java conference. If it hadn't been for J2EE, we would have been at the C# conference today.
There'd be no C# without that.
Yeah, so J2EE or Java Enterprise J2EE, Enterprise Java is what powers the world. Everything runs on Java, more or less. If you go to finance or anywhere else at the bank, every transaction, that's Enterprise Java is J2EE all the way.
Or COBOL.
Or COBOL, yeah, but J2EE integrates very well with COBOL. So this is kind of the reason why we're here, but it was also a bit over-engineered. And
A bit.
I'll go through it.
A tiny bit.
A tiny bit over-engineered. And back in '99, if you wanted to write a hello world using enterprise Java beans or EJBs, you would start by doing the business logic like this. It's pretty simple. And then you would take this in a class, and you would, well, if you were alive then back then, you may have some scars, but it will get better.
Some certified business component developer is
Yes,
here.
there you go. So you would take this enterprise Java bean class of yours. You would have to implement a couple of interfaces. So it was the session bean this time, which is an enterprise bean, which is a serializable, and then you would also have to create some interfaces, the local interfaces, the remote, these were again extending some interfaces, the EJB home, EJB object, local home, etc., which are all remote objects, even the local ones.
Mm-hmm.
And also the infrastructure would generate some classes for you, generate the stubs for these home object, local object, and all of these. So this is what you would end up with if you were creating one simple
Wait,
hello
where are
world.
the XMLs?
We're getting to it. So it didn't stop there, because you would take this is the blue ones are not very visible, but it was the one hello, the interfaces, the four interfaces, and the hello class. That was what you as a developer would have to create. And then you would take this entire thing and package it in with a couple of XML descriptors. You would have to have the standard XML descriptor that was specified by the specification, and depending on which runtime you're using, you would also have a vendor-specific XML descriptor, possibly for WebLogic or WebSphere or JBoss or whatever you were using. And these everything you would package in an EJB jar, and you need to have one jar per EJB. So if you had multiple EJBs in your system, you would have multiple EJB jars, and all of these you can pack together in an enterprise archive or an EAR. So it wasn't only simple. So in 2004, we got Spring to address some of these issues, and anybody using Spring? It used it back in 2004, maybe also. So Spring came along and made it a little bit simpler. So you still have your business logic class, your bean class. You wouldn't need all these interfaces any longer, but you may need to expose some internals of your class by getters and setters in order to get dependency injection to work, because that was something that Spring introduced, to have a dependency injection in our class. And this wasn't annotation based. This was XML based. So you would have to have a couple of XML files, and the bigger your application were, the more XML files you would have. And this could be nested and referenced in all kinds of ways. So it wasn't easy at the time to figure out where did this particular bean come from. So debugging Spring applications back in 2004 was not easy, but it was a little bit easier packaging. You can package it in a WAR file and drop it in an application server. So it's kind of easier. But still, Java EE came along in 2006 and picked up some of the stuff from Spring, among other things, the dependency injection. We also got annotation-based dependency injection with Java 5. We got JSR 330, which is add, inject, and auto-wire, can be used interchangeably. So we got we took this good stuff from Spring, brought it into J2E, renamed it to Java EE, but still you probably get LinkedIn messages from recruiters looking for J2E developers today. And this is 20 years ago that it was renamed to Java EE, but that name kind of never stuck. But it got better. So at this time, around Java EE 6 or 7, I would say that Spring and Java EE probably were dancing a little bit together, but Java EE was probably a little bit ahead of Spring at the time. And while Spring was still on the XML dependency injection kind of thing, this is how an EJB looked in 2006. And this is how an EJB looks today. There are no interfaces, there are no XML files. It's one annotation. That's all you need to get all the stuff that EJB gives you. So the bad reputation that EJB has is from 1999, 30 years ago. We still remember that, even though 20 years ago we got this, and that's how EJBs are today. It's not harder than this. You package in EJB in a jar or a WAR file, and that's it. No XML needed whatsoever. So all of this, that's ancient history and goes up in flames. Which brings us to the present, or a little bit up to the present. So Spring Boot came along in 2014 and changed the landscape a little bit again. So this is the dominant player in the market today. Jakarta E came around in 2017, when Oracle decided to move Java E out of the JCP and over to an open source foundation, which was Eclipse Foundation. And we started the work around 2016 and 2017. We got the Jakarta E name. So now it's the second renaming of J2E. And it has been like that for almost 10 years. In 2020, we did Jakarta E9. And Jakarta E9 introduced the namespace change from Java X to Jakarta. And most of you have probably done this conversion. Even if you were in Spring ecosystem, you had to change your code to get on the newer version from Java X to Jakarta. We're not doing that again. So this was a one-time thing, and it kind of cleaned up the ecosystem. Because if you think about it, if you still are using a dependency, some kind of library or tool that is on the Java X namespace, that actually means it hasn't been touched for 5 years. And would you really like to have some 5-year-old code running in your system when you create something new? There's probably a lot of security vulnerabilities in it. So you want to make sure you're on the newer stuff. So don't use any Java X based. Currently, we're on Jakarta E11, and I'll get into a little bit details about Jakarta E11 as well. So in 2020, we did the namespace change in Jakarta E9. This was the only thing we did on that version, and that was with good reason, because we wanted that migration to be as easy as possible. And if we had changed the APIs back then as well, this would have been much harder task to do, even for Spring developers, to get from Spring Boot 2 to Spring Boot 3. If the IPAs had changed as well as the namespace, this would have been an almost impossible task. So we limited it to the namespace change. That meant we had a lot of changes coming up in 10, which we released in 2022. And we also introduced the new Jakarta E core profile then. And now last year and this year we did the Jakarta 11, and I know on Java 21 or higher. We are modernizing the platform, embracing records, and getting more CDI centric around it. So I'll go into a little bit the details of Jakarta 11, and then I'll get to the demos. But first, Jakarta E is a specification, and it's all about specifications. And this is different from Spring, which is a framework. And what we mean by specifications here is that we have some human readable document, a specification document, that describes the technology. Then we have an API artifact also that is something we as developers are using, pulling in from Maybe Central or similar. And we have the technology compatibility kit, or TCK, that tests and verifies that an implementation implements a specification. So this is a test suite. And when an implementation implements and passes the TCK, it is a compatible implementation. And all the specifications had at least one open source compatible implementation. This is in order for us to ratify it as a final specification. From there on, there can be closed source or any license associated with the implementations. Most of them are open source though. And Jakarta E 10, since we didn't do any updates in 9, we had a lot of specifications updated. So this is an overview of Jakarta E 10. And as you can see, the blue ones were updated. The orange is a new one, and the gray ones were not updated from 9 to 10. And if we compare this to 11, because it's about the same amount of specifications updated between these releases. So we're continuing on this path of updating about half of the specifications in each major release of the platform. And I'll go into 11 a little bit in detail. So the combination of all specifications are the Jakarta E platform, which is a specification on its own. So with the platform, we also have a API in Maven Central. We have a specification document, and we have a test suite, and we have implementations. And compatible implementation of the platform are what we know as application servers. So that would be our WebLogic, WebSphere, Pyaras, Glassfish, etc. And in addition to this, all of the specifications also have their own compatible implementations. And one of them, the more used one, is probably Hibernate, which is one of the implementations of Jakarta Persistence. So I'll go into some of these later. A subset of the platform is the Jakarta web profile, and this is more of the traditional web applications where you have everything you need to create a UI, to create you have security around it, some persistence and transactions and handling all of that kind of stuff. And then there is the core profile, which will be introduced in Jakarta 10. And core profile is a set of specifications targeting microservices or more smaller services and more suitable for the cloud native stuff. And the key specification here is actually CDI Lite. And CDI Lite is a subset of CDI. And CDI is the context and dependency injection, is kind of the glue that glues everything together. And the traditional CDI does a lot of things dynamically when this application starts. So what we've done with CDI Lite is to resolve all these dynamic properties at compile time rather than at runtime. So we can do GraalVM and compile to native images if we want to with applications from this one. Jakarta 11 is compiled with Java 17. And this is something we decided because that's where the next step of the industry, that's where the industry is today. Usually we say you go from Java 8 to 11 and 17 probably, and then you jump further. But at the time of Jakarta 11, when you started defining that, 17 was the target platform. This is also the current version of Spring there is in 17. So we chose to do that to follow the industry. We actually wanted to jump to 21, but that's probably a little bit premature. What we did though is to make sure that it runs on 21. So we test everything on 17 and 21. So you can use newer features in your applications, even though the APIs are compiled to an older version, which is fine. We also, with this release, established a release cadence of about 2 years. And we are stating that about 6 to 9 months after an LTS of Java, we want to release a new version of Jakarta E. And Jakarta 11 was planned to come around June last year. And that was about 9 months after Java 21. Now, you know that Java 25 came out a couple of months ago. So June next year is when we plan to get Jakarta 12 out. And the reason why we were a little bit delayed with Jakarta 11, or 1 year delayed, is that we did a major refactoring of the TCK for the platform. And that TCK was written in technologies back in 1999. And this is a tool set nobody uses anymore. And younger developers like us, we don't know these technologies, and we want to have the younger developers to be able to use it. So now we moved it over to Maven, Archillion, and JUnit 5. So it's a little bit newer technologies at least. As I said, we started a release of doing this, and this was the first time we did independent releases of the profiles and the platform. So we did core profile in December, web profile in January, and the platform itself in June. And Jakarta 11 has all of these specifications. I'll go through a couple of them and show some demos. And I'll start with concurrency. So these are the key things that were added in concurrency, and maybe the most important of them is virtual thread support. which was introduced in Java 21. And let's look at virtual threads. So in Jakarta and Java in general, we've always had this love-hate relationship with threads. Everything is threaded, we run on threads, but we don't want the application developer to mess too much with the threads, because the application server wants to control this. And if you are, as a developer, are creating just doing a new thread or something, the application server may discover, hey, this is something I didn't create, I'll kill it. So we have all these managed services to handle threading. And we were thinking, we can do the same thing with virtual threads. And that's what we did. But then you may remember that we are based on 17. And virtual threads came in 21. So how can we do this? Well, what we did was to add something to not touch the APIs, because these are composited to 17. So we where applicable, we added this flag for virtual. So you indicate to the runtime that, hey, this is where I want to have a virtual thread. So this is the managed thread factory definition annotation. And we added this virtual flag, which is default to false. So if you want to have a virtual thread, you'd set the flag to true. And how does this work? Well, we have this we call Java SE runtime aware support for virtual threads. So if you're in your application, set the flag to true, and you're running on 21 or higher, you will get a virtual thread from the runtime. And if you're running on a different version, or are running in a application server that doesn't support virtual threads, you will get a platform thread. So this is how we can do it, and still we support 17, but using 21 features. So let's look at the demo there. So I have a application here. This is the same application I'll be using in more or less all the demos here. So this one, I'm compiling to 17. And I'm using Jakarta 11 web API. And apart from that, I only have some runtimes defined here. And I'll use OpenLiberty from IBM as the runtime in this demo. But you can use any of these. The application itself is a Jakarta RESTful application. So and the way you create that is just to extend the application from Jakarta RESTful and give it an application path. And then I have a RESTful resource that has a HTTP GET endpoint that I'll be just returning some stuff. So if I want to configure to use virtual threads here, what I can do is let me see, virtual config. I got it. 2 minute template. So I will have the managed thread factory definition. I will give it a name. This time, my managed thread factory. And if I wanted to set the virtual equals true flag, I can do that like this. So now I've indicated that this thread factory should supply virtual threads to it. And if I want to use this, I can, in my application, I can do the, let's see, virtual. So I'll do a lookup on this thread factory, the same one I created here. And I'll just start it. And then I'll return some text started on and just print out the thread. This is a very simple application that doesn't do anything. It just creates a virtual thread. So I'm on Java 17 here. So if I do a maven clean package, I'll just do it in steps. I'll compile it on 17, and then I'll run it in OpenLiberty. On 17. Liberty run. So this one starts in a second or two, and then I can do a get on the threads endpoint, and you can see here it gives me a thread, which is expected. I'm on 17, even though I asked for a virtual thread. So if I now just do the, I'll stop this one again, and I'll do use Java 25 even. So I'll switch to Java 25, and I don't compile it again. I'll just run it. So I'll just do the run. So it's compiled on 17, but it's running on 25. And if I now do the same request, I get a version script. Magic. So this is how we did it, and whether it's a good idea or not, to have this managed thing of version thread, that's for you to decide and to give feedback on the concurrency project. Persistence is another aspect that got some important updates in this release. We're adding Java records as embeddable classes, and since we all hate XML, we also made it possible to do a Java programmatic configuration of the persistent XML. So you don't need a persistent XML anymore. You can do it in Java code if you want. This doesn't make sense really in an application server environment, but if you're doing a Java SE application, this may be a way to go. Another things we did in this release is that we deprecated the so-called old calendar and date time API and replaced it with the newer Java time API. Anybody remember when Java time came around? It was in Java 8, and we still call it new, and we still use the old stuff. And the old stuff will be possible to use for all foreseeable future with Jakarta persistent as well, but it is deprecated, and at some point it may be removed. So you may want to do the newer things like the local daytime and etc. All right. Continuing with persistence, we also added a new specification, the Jakarta data specification. And Jakarta data is standardizing the repository pattern for data access. And if anybody are using Spring and Spring data, so this looks familiar, right? But this isn't Spring data. This is Jakarta data. So we didn't steal anything from Spring or anything. We were very much we took the it's very much used there, and saw that it's popular. It's a good piece of technology, and we want to provide the same thing to Jakarta E. So it's very much inspired by Spring data, and also some people on the Spring team has helped with this as well. With this, we also introduced a new query language, the Jakarta data query language. And this is a subset of the Jakarta persistence query language. And so now you can write pretty powerful queries in annotations rather than relying on method names and stuff that you would need in the simple versions. So let's look at a demo. So we have the data. It's the same kind of application that I had. Now I'm on Java 25, but everything else is the same. The application itself is a RESTful application. It has a RESTful endpoint, greetings with a HTTP GET and a HTTP POST. This doesn't do anything. And it has a greeting entity in Jakarta persistence with a ID name and message. And it also runs with a Postgres database underneath. So if I wanted here to use Jakarta data, what I would do is create an interface, the greeting repository. And I can also here, I'll just stop this and I'll just start this one maybe in Liberty Dev. So the Liberty. It's a time difference. The ace becomes yeah, it's the accent. So we have the greeting repository. So now I can in my resource here I can inject this one. Greeting repository like this. And I know rather than returning an empty list, I can now return greeting repository and why isn't it give me? Of course. The green repository, we have to do something with it and extend the CRUD repository greeting to long and give it a repository annotation. And you can see it's the Jakarta data. And I now have this all the CRUD methods available for me, like the find all, insert, update, etc. So I'll just do the find all and return the list. So if I now run this one to there, and I'll just do the, or is this one on 98? No, wait a minute, I have a smarter way of doing this. I have the REST lines. So if I do the query the greetings, it will return me an empty list because I don't have anything in the database yet. So if I want to insert something in the database, I can here in the post method, I can do the greeting save, greeting repository save, and then I can print something maybe saved with ID, saved greeting. Get ID like this. And if I now do a post on this one, do the hello world and put it in, and I now do a get. You can see I now have a hello world from in the database. And if I want to add something more, call it the New Zealand Duke hello world from ChurConf. Right. So if I add another one, I now have 2 in my database. And what if I now only was interested in one of them? Then I can, as I would do in Spring Data, I can do a optional greeting, find by name. I can even add ignore case. So I'll just add a method, find by name, ignore case, and in my resource I can do the find by name ignore case. Taking the name on the path as a path param, and do the finder on it, get the message out, and print not found if I don't find it. So if I now do the find here and call it NZ Duke lowercase, it will now do the hello world from ChurConf. So it finds the one even though it's lowercase. If I do something that isn't there, it will write the not found. So it works pretty fine. Stop this one again. That's pretty cool. It's a very easy way of doing persistence in Jakarta. And there's an opportunity there if you want to help out at the path, for example, and add this to the OpenJPA. This is a good place to start. You can just look at the annotation processor for Hibernate and see if you can just fiddle with it and make it work for OpenJPA. It should be fairly easy. Or I don't know if it's easy, but it should be a way of doing it. And we also have a couple of implementations already, but they always need help.
A few monkeys.
Yeah.
Yep. Just put monkeys on it.
Put monkeys on it and do it. So let's look at some future. So we have Jakarta 11 out today. We will get 12 out next summer. And let's look at what we're having plans for 12. So we're raising the Java levels to 21. This is where the industry goes. But we will obviously also support 25, which come out in September this year. So we are going to run make sure it passes on 21, 25. Now, if it happens that none of the specifications really need any 21 features in their APIs, we may still compile them to 17, because there are no reason to raise the Java level unless we actually have to. Java is backwards compatible. So, and these are just compiled API classes, and it doesn't really matter. as long as we, as in our applications, can use the newer features of the newer versions and run on the newer runtimes. We will update a lot of the specifications. These are the ones that have put forward plans in their planning reviews. You can see one new specifications query up there. I'll get into a little bit detail about query. We also have updates we're starting to discuss now, like the NoSQL specification and the MVC specification. And if we're being honest about it, I guess NoSQL is the one that is closest to be part of Jakarta 12. So, but this is all subject to change. But I hope we can start discussing the inclusion of those in NoSQL fairly quickly. So there will be 2 new specifications, about half of them updated, and some of them aren't receiving updates this time. They will probably be updated in the next version. Okay? So query. Query defines a new object-oriented query language for Java. And this is taking whatever is common between the Jakarta data query language and the Jakarta persistence query language. It also looks at NoSQL to see what's common here and create a common query language for Java. It's actually so flexible, it's not even limited to Java. You can use it in any language. It's a common object-oriented query language for data access. So it's a standalone specification, but it's included in the platform, and these others will inherit from it. NoSQL will probably be enough with what's defining queries, so they won't introduce a language on their own. Data and persistence have some specializations they're using in there, but there is a common language to use all these kind of different data sources. And talking about NoSQL, it standardizes the integration with NoSQL databases exactly the same way as Jakarta persistence are standardizing access to SQL. And a fun fact there is that Eclipse JNoSQL, which is one of the implementations of Jakarta data, of Jakarta NoSQL, implements Jakarta data as well. So you can use Jakarta data, the demo code I used there, just swap the data store from Postgres to MongoDB or something else, and it should run without any changes. You may have to install a driver or something to use that particular NoSQL database, but if you're using just the simplest things, it should work across different stores. MVC is standardizing the action-based MVC pattern. It builds on Jakarta REST, and it adds a couple of annotations there, like the controller and view and stuff. And since the world is React is going server-side and are starting with server-side components, these things that when the JavaScript world discovers that server-side rendering is cool again, and we have this 20-year-old technology that works, we're here ready when the industry is looking at server-side rendering again. We're also looking at replacing EJPs. And this is just an idea. It won't happen in 12. There may be some precursors to it. But if you remember this one, and this is, it looks like this is too complex for the industry to do. To add this stateless annotation, that's way too much. So we're going to make it much simpler for you. We're going to change the stateless to at service. So as characters right, your AI will be happy. And this is how we see as a replacement to EJBs in the future. And this service will not be an EJB as stateless is today. It will be a CDI stereotype that does exactly the same thing as stateless does. So it's a CDI version of EJBs. This is just on a kind of proposal and thinking stage, but this is one way of modernizing EJBs or phasing out EJBs, providing the same powerful technology, but in a simpler way, because at service is much simpler. An idea is also to look at CRAC and see what do we have to do in Jakarta EE to support CRAC. And CRAC is coordinated restart at checkpoint, which is a technology to restart your application faster. It's like when you close the lid on your laptop and open it again, it's in the same state. And this is the same thing for Java applications. You shut it down, you shut the container down, and you start it up again, and it starts much faster because it doesn't have to do the warm up. It's already warm. Of course, we have to talk about AI. And there is a specification out for creation review right now. It's a Jakarta Agentic Artificial Intelligence. specification, it looks like it will pass. It has enough votes. And it will not be a part of Jakarta 12, but it will be developed and maybe included in the platform in the future. So how can we, if we are using a Jakarta application today and I want to integrate with some LLM or AI, how can I do that?
You need Quarkus.
You can do Quarkus, but Quarkus is sort of they have a good API. It's not, they're not certified as compatible with Jakarta, but it is there. You can use Halidon, which is a compatible implementation of core profile and also supports AI. You can use LangChain4j, like a library. You can use LangChain4j CDI, which is a CDI version of LangChain4j. And I'll show how easy that can be done with Jakarta. So I have this application here. It's the same application as I have showed you previously. It's on Jakarta 11 using Java 24. We can use 25, and it's not this one even. Let's try to use the right one. So yeah, on Java 25. So if I wanted to call an AI here, it's a RESTful application like this, and it has an AI resource just a getter, which I'm going to implement. So what I have to do is to add the LangChain4j dependencies for the CDI version. So I have these here. So what I do is to add the CDI extension for LangChain4j. I have to add the configuration for CDI, and add the LangChain4j core, and then a dependency for which version, which LLM I'm using, and I'm using OpenAI for these. If you're using something else, you can just add whatever LLM you're using. So this is the dependency you would have to change there. So if I want to use this, it's very simple. I can just create a simple interface. Let's call it AI service. And what I can do is just add the register AI service annotation, and then I'll add a method chat message. So this is all I have to do to create an interface like this. And now I can start using it in my resource there. So I'll just inject this one, inject AI service, and do a call to this one with I'll pull in the message as a query param and just send it straight to the AI. So I have the AI service chat with the message like this. And if I now start this one, and package liberty run. So we'll start on Liberty. You can see this is on any Jakarta runtime. I'm just using Liberty for convenience. So it starts up, and if I wanted to ask the AI, the joke that Baruch showed, so why is saying, why did you bring an empty plate funny in New Zealand? So let's see if the AI has a system for this. So it's probably, it looks like it's a hard thing to figure out.
Yeah, definitely.
So,
I was so creative, the AI cannot manage.
Yeah, exactly. So it should hopefully provide an answer in a while. So yeah, there we go. So I don't know, it doesn't make sense because
it's
bringing food to share, and that's why it's funny. So now we know. So this is a way of using integrating AI in your Jakarta application. And so it's add one simple interface and just start using it. Of course, you can configure it in all kinds of different ways, but this is all you need to do. So AI with Enterprise Java is actually very easy to do. You don't have to learn Python or go to any place else. If you want to integrate AI, your manager said, we want AI in our enterprise banking application. Then, yeah, just LangChain4j CDI, and you're good to go. You don't have to change to any other frameworks or tooling or anything. You can use it directly in your Jakarta application. If you want to know more about EU12, you can go to our GitHub issue tracker. We have labeled the issues with EU12. So, to sum up, Jakarta 9 was all about the namespace change. We did only that. We didn't want to do anything else since we wanted that migration to be as easy as possible. If you're still working on this and migrating from particular Spring Boot 2 to Spring Boot 3, and you have some transitive dependencies that you don't have the source code for, or you're using some open source libraries that are not maintained, that are not available for you to change the code and update the namespace, you can use the transformation tools we created around this time. And two of them are the Eclipse Transformer and the Apache Tomcat migration tool. And these tools are very good. They take your transitive dependencies and fix the bytecode for you. So you don't need to touch the source code to move from the JavaX to Jakarta namespace. You just run them through the transformer, the jar or war file or whatever, and it just fixes it for you. It even does the XML namespaces and changes everything for you. And of course, if you're doing the source code change, you can use the IDE, the tools, or Open Rewrite or something else. But this is for the bytecode transformation. And it can also transform bytecode for other namespaces. You just configure it. If your company is acquired by another one and you have to change the namespace of all your libraries for some reason, then you can do it. Sorry?
Does it update manifest entries?
Manifest entries, I think it does everything. So it will fix it for you. All right, so Jakarta 10, a lot of changes. Jakarta 11 is out there now on 21 or higher. All the demos are around here was on 25. Jakarta 11, lots of changes there as well, and data was the new specification we introduced. So now we have a simple way of doing Jakarta repository for persistence in Jakarta E. 12 is coming, and 12 will update the Java versions, so it will support 25 and newer. We'll verify it on 21 and 25, but it will probably run on 17 and 27 or 26 as well. We are adding query, that's a done deal. We are considering to add others. NoSQL are probably the closest to be added. Jakarta AE and AI works perfectly well together. You don't have to go anywhere else. If you want to know more about Jakarta EE, you go to the jakarta.ee website. And if you want to get started with Jakarta EE, we have a starter at startjakarta.ee where you can generate a project and get started from there. If you want to look at the code I've done, these are the three demos I was showing. They have some, the AI has some other integration stuff and other versions of Jakarta EE integration as well. And if you want to read my blog, you're welcome to do that. I publish it every Sunday and after every conference. So I'll probably write something about this conference tomorrow. So that was what I had. Thank you very much for listening. And I'm here the entire day. Don't be shy. I have stickers. So everybody who approaches me will get a sticker. And you don't have to have any other question than, can I get a sticker? And you don't even have to say hello. Thank you.
Thank you very much, Shiver, for the very interesting session and the update on Jakarta EE and what's coming next. So I think now we can have a 12-minute break, and 11:20 we start with the next session. Grab some coffee, some tea, talk to each other, and yeah, the next session starts in slightly more than 10 minutes. It's just for the presentation right now.
Nice presentation.
like command line.
So you made
Command line, say line.
yeah. I've been thinking about it, talking about it. I want to create a CLI starter so we can generate the project. Currently, we don't have that, but there is a channel for it that I created on, but it is a main market to do. But for starting stuff and talking about it, these vendors, but they don't want to go into the runtime thing. Because it would be cool to just say, about something, whatever. But we have to have some translation from that. Likewise. I am and just have the vendors provide translation of their
Pretty much one market.
Now, for us, it's IBM is good. When you choose one of the factors, but yeah, something generic. So if we created a some kind of project, it doesn't have to be out and I was using Airtable. Yeah, it's much faster. And there are fast use one line and then you're starting.
And then you start, and that's easy to get rid of. And then you start adding stuff. So it's about configuration. Yeah, and if you want to, so if you have a long running project based on One hour at the time, we modernize it. That's
Cool, thank you very much.
I was late, so I did wonder if I missed like
So everything is, the video is already uploaded, so you can go ahead and rewatch. Yeah, so you go to show notes, the ChurConf, and no, it's not like it's 10 minutes now, so you can watch it. And that's for you for the comments. You go to ChurConf.java, type in this code, and they will ship a t-shirt.
That's all good.
Have a good picture.
I've been in that space for years, kind of push the whole stuff, for example, BDD, all that kind of get other people in. I always fail, right?
Because I don't want to write.
Exactly, as he said, like, you really want to get their art makers, right? I had an experience years ago where I had a VA, and we worked with them properly, we kept writing these fucking massive docs, and I was trying to get her to work with people. We did a bit of BDD there, we did lots of position, but the line she gave me was, you know how you're proud of, like, when you write complicated, or when you write code, you're proud of it, like, yeah. She's like, well, I feel the same when I write spec. Yeah, but that's not what it's for.
That's what they want to do. And this actually solves it without them to compromise, which is perfect.
It's like you're a reviewer, you have a look at it, you can distill it into something
And
narrative.
then the spec will review it, and you can say, you know what, this spec missed it entirely. And we're like, well, that's on you. Describe it better, do your thing, and then you're from
You know, you said the thing about you get garbage in, garbage out, which I agree. 90% of the time, actually 100% of the time, that's true. And even like our code is garbage because it's damaged, it has bugs, it has everything. But I had an experience a few weeks ago where I'm trying to get some QAs, which I apologize for generally having QAs in this day and age. That's some QAs. And I use Cursor to generate some scenarios. We were pointing, right? So we have all these complex rules around. You go in the shop, you get points, you do something, you get points that expire. And there are lots of complex scenarios where you seem to get a lot of bugs every time there's an edge cases. So I tried to use it to add some BDD in the code, essentially. And I went through a whole bunch of pain of like forcing it to add the right dependencies. We've got scenarios with adding SVT tests, speaking to the end, and also with scenarios, like sometimes use examples because you're duplicating blocks, right? So use example blocks, and this scenario is bullshit. And 90% of it, this is bullshit, frankly. Which is another side observation.
No, but the thing is you can automate it. Like, that's the beautiful. Like, the cycle, this is bullshit, right? The game should be automated. You shouldn't say it. If it doesn't fulfill the spec, this is bullshit, right again. And then just let it spin.
That's a fair point, but that's if you see I think the challenge I had was that that's not the shit itself.
No,
And
this is
the
exactly
behavior
what
is so complex. Yeah.
this is exactly how I'm fixing it.
The side effect is I learned over the years what the time benefits in sexual and I am so heartless to my
No, but obviously, I mean, we joke about should be nice to them because that's not what.
No, you shouldn't be. The thing that worries me is that how am I going to treat the person next to me
That's
after I've rebuilt the muscle of not being involved?
There are also research that proves that when you move to AI, it actually gets better. Gives you better results.
I have one that, yeah. I watched this. I'm not.
Nice to meet you. Yeah. Yeah, both. Yeah.
Where we travel from?
Tennessee.
Our office. Our head office is in Nashville.
Oh,
Yeah.
Oregon. Yeah.
I'm still waiting for it's
Yeah.
Yeah.
Well, it's a nice city. You don't have to.
What the heck?
Thank you.
Okay, I think we can start. Are you ready?
Oh, you want to start? Okay.
Yeah? You ready?
Pretty much.
Yeah. Okay. All right. So I think we can start with the next session. Let's wait for everybody to. Okay, so let's start with the next session. It's a great pleasure to welcome Rob. Rob, in fact, is the first speaker that we invited for ChurConf. He's one of the leads of the local Java community in Auckland. So, Rob, without further introduction, I'll give you the word.
Should we do a duet?
Was that?
A duet?
Yes.
These people do not want a duet from me, that's for sure.
Carry on. So,
Yeah. Okay, so let's start. Ahead of time, I'm Robin Bygrave, or Rob Bygrave, and basically we're talking about moving work from runtime to build. Okay, so about me, Java developer for quite a long time. Although Ben beats me. Was it 96 Java 1? So well done, Ben.
Oh, it's free Java 1.
Pre-Java 1. Was that Paul? Right. Very good. Open source libraries. So I'm also known as the ORM guy for local people, E being ORM, and that's going to come into our presentation today as well. And also a creator and maintainer of Apache libraries, which are also going to come into our presentation today. So you won't really find me on anything apart from LinkedIn or in my Git projects, etc. So if you're looking for me, probably that's the way to go. Most of the agenda, what we're going to talk about is in the top 3, which is the motivation, why we're trying to do this ahead of time stuff. The impact on Java libraries and techniques. So we right now have Micronaut, which you've heard of, Quarkus, and they're obviously coming into the old JEE world, and of course Spring as well. Everyone is trying to do more ahead of time. What's actually happening with those libraries? What are they actually doing? We're going to talk about dynamic proxies, class scanning, and reflection. Then we're going to talk about GrailVM native image, and that's basically doing compilation to full native binary. So that's where the meat and potatoes is, in those three parts. And then we've basically got a hand wavy one slider for the bottom three. Project Laden, which is JVM ahead of time. We've got Crack, and we've got JIT servers. So let's hop into it. So the motivation, why are we doing this? So but money, and you can basically summarize the slide as money. So back in the day, a long time ago, you might have been deploying into a box that was around the corner or in the data center. We're deploying onto a cloud, a lot of us. And when we do, we're paying for every megabyte of RAM and every CPU core. So we're directly seeing the monthly bill on our cloud and going, okay, can we make that smaller? The other thing that's happened over time is that we've come into a world of CI/CD and autoscaling. So if you go back far enough, you're going to deploy once a month, and your autoscaling would be, oh, let's go get another machine, maybe from the shop or add it to the data center. So our scale up was very slow. And then these days, you might be deploying to Kubernetes, and your scale up is real time. And so we've got more frequent deployments. And so there's a few things there that startup and warm up are basically more important. One of the things about warm up is that it's approximately the same as time to peak performance. How fast we start the application, and then the time to peak performance. And the guts here is, can we go lighter and faster? So we're going to talk about startup and warm up first. And this is this fancy chart here. It's got CPU and time. So as we get to the end, we hit peak performance, and we've optimized our application. But when we start up, we've got some startup activity and we've got some warm up activity. We're basically saying, what are those things? How do we improve those areas? So what happens at startup is the application will start. It will read some configuration. Some of it will be local. Some of it will be remote. Then the application will do some dependency injection wiring, basically constructing our application. It'll create loggers. And if you've seen a few of these presentations, it's like it'll create loggers and more loggers and more loggers. We have a tendency to create a shitload of loggers. And so just as a side note, it's one of the things I do these days is create less loggers. And a lot of libraries also read reflection. So they're going to look at classes that they're going to process. They look at the methods that they have, etc. So what constructors they have, what methods they have. The JVM's also doing stuff. It's going to class load, verify, link, and initialize classes. And it's also going to start JIT profiling. So JVM, in terms of JIT profiling, we have two compilers. So C1 and C2. C1 is the interpreter, and then C2 is the JIT that does profiling and optimization of those profiles. During warm-up, the profiles read, make things faster and faster and faster, based on what the application is doing. Now, we've also got some other stuff that was happening in warm-up that is application related. And here's an example of prepared statements. So if you're talking to a database and you're doing JDBC, then you're going to have JDBC prepared statements. And so one of the things that you'll have is a near cache on the prepared statement cache. So there are things that will happen in warm-up that are related to the app as well. I guess I'll throw it out there. In order to speed that up, you might look at things like RDS proxies. Okay, so we basically wanted to try and trim down startup, trim down warm-up, so make that smaller, nicer graph. Okay, so here we've got CPU, and those are 1 minute intervals for those little bars. And we're seeing CPU consumption of a service that's deployed into Kubernetes over time. And what we can see here is that when we've got our Kubernetes service, it's got 4 pods, and we're doing a rollout. You can see a nice wave, and the graph up the top there is showing us that we've got our 4 pods. First one rolls out, and we're paying startup, warm-up costs. Then the second one rolls out, and we pay startup and warm-up costs. Third one, fourth one. So we actually get this wave shape. And so you can see that here. Now, what you'll also notice is that those are 1-minute bars, and we're really seeing a higher CPU load for probably about 8 minutes. So 5, 7, and then we're starting to get into peak, and CPU load's coming back down. So the JVM is doing some awesome stuff for us, but it's costing us. Now, do we care? So honestly, if we were deploying once a month, we don't care about this, right? We don't care at all. But if we're deploying very frequently, we might start to care. We also care about a few other things. So our deployment time to peak. So you probably look at this and go, we're actually not necessarily running at peak performance for a number of minutes here. Now, we have services, not all of them are equally important. We have core services, and then we have services all around the edges and stuff. So there's a bunch of services we don't care about, maybe some core services where actually time to peak is a thing, and we're actually going, okay, we really want that to be better. Scale up. So probably the other argument I have here is that if you scale up as slow, you'll tend to over-provision. So if you go back into the extreme case of like say Kubernetes, and okay, we've got a data center and we've got 2 servers there, it's going to take us a long time to scale up to 3 servers because we're going to have to talk to the data center and connect, get the resource, purchase it, So we're going to tend to over-provision. We're going to have more memory and more CPU on that. There's a pain in the ass to scale that up. So if our scale up is fast, we're prepared to go a bit tighter. So if our scale up is actually, let's say seconds, we're prepared to go tighter on the resourcing. If you think about Kubernetes versus, say, auto-scaling group or something like that, auto-scaling group might be slower. You need to bring up a node. Your scale up is now minutes potentially. So you're going, okay, if our scale up is slower, we're going to over-provision. We're going to tend to that because we want the thing to stay running. Third one is scale to 0. I honestly don't really see, personally, a lot of use cases for scale to 0, but that's probably just my experience. Obviously, if you talk to SREs and ops people, they love scaling to 0 because they do things that are one-offs, not run very frequently. Most of the stuff that I'm involved in, running all the time, scale to 0 isn't so much a thing. Last one there I'm going to chuck in there is recovery time. Shit happens, and we can lose entire nodes in a cluster, etc., and how fast does it take to actually get back up into recovery mode? So, do we think about this much? I'm not sure. There's certain cases where you'll have core things, and actually you will be interested in recovery time as well. So, what if we lose a node, etc., etc.? So I guess these are the good things about Kubernetes. It spreads the risk. We maybe care less about recovery time. So doing a lot of yarning here, but it's all really orientated around CPU. And there is the elephant in the room, which is memory. So when we're paying money in our cloud, we're also interested in memory, and not just CPU. So we've done a lot of talking about CPU, and I'm going to sort of, I guess, leave the hand-waving stuff here. We're going to talk about memory. We're going to talk about it later. All right. Oh, that was my how am I going for time slide. Didn't bother. We'll just carry on. Okay, so now we're going to talk about the impact of Java libraries and the techniques that Java libraries have adopted over time. And then we're going to get into Growl. This is the meat and potatoes. So the first part we're going to talk about is dynamic proxies, class path scanning, and reflection. So my journey on this sort of probably started about 7 years ago, and I was deploying my first services into Kubernetes and doing a comparison of how we were performing versus some other things. And so you start looking, so why are we slow? Why are we a bit fat? Why are we a bit hungry for resources? And so the first thing is dynamic proxies. Dynamic proxies is when a class is defined at runtime. So what happens there is the class needs to be defined and defined into the class loader, and that's all happening at runtime. Second one is class path scanning, looking into the class path, finding things. And the third one there, reflection. So dynamic proxies, as developers, we might not create them, but libraries are creating them. And so historically, dependency injection is a classic one. So I guess I will say Spring. When we find every Spring component, that's a dynamic proxy. The things are we can do AOP with them, but nonetheless, at runtime, we are defining a class, and that class has to be loaded by the class loader. JAX-OS controllers, so if you're using JAX-OS Jersey, REST-EZ, or Spring MVC, similar sort of thing. If you're defining that, dynamic proxy, class being defined at runtime. ORM entities. So not all ORMs are going to use dynamic proxies, and some ORMs have the ability to not use them. But ORMs, again, dynamic proxies. Class path scanning. So the classic one here on the dependency injection framework, find all of the classes that I want to wire, find all of my components, wire them. ORMs, find all of the entities, and read the metadata, and then I've bootstrapped my ORM. The third one there, database migrations, a little bit different. Find all of flyway. Find all of the SQL scripts that I want to run for my database migration, and also do checksums against them. And then we're allowed to start. So we've got to do those things. Find them all, check the checksums. Okay, now your applications can start. Reflection, I'm just going to chuck in here an example of Jackson, but you probably are aware of quite a few libraries that are using reflection. So, how can we move all of this from runtime to build time? So this has been happening, and it's been happening for a while, probably about more than 7 years. This is what created Micronaut. This is what's motivated Quarkus. This is what's motivated myself as well. There's two big dogs in this one. One is annotation processing, and the other one is build time enhancement. And there's other things, right? We can think about things like maybe less loggers. In terms of database migrations, well, maybe we could do the checksums ahead of time. So what we're going to do next is we're going to look at these two things: build time enhancement, annotation processing. Okay, so how many people have written a Java agent? Yeah, a couple. Oh, yeah, good. We've got like a few people. That's great. Start on the left here. This is interface Java lang instrument class file transformer. The guts of this is that it takes a byte array and it produces a byte array. So that transform method takes a bunch of things, including a byte array of the class that's been transformed, outputs a byte array. Okay? So classic transformation, typically how it's used. If we look at the command line, you'll see Java agent in the command line. Now, what this means is that when Java starts, it's going to know the agents. When it gets a class, it says, oh, any of these agents can transform this class before I load the class. So at runtime, each class is going through this, potentially being transformed before it's defined, and that's all happening at runtime. Now part of the guts here, we don't really want to do it at runtime, we want to do it at build time. So how do we do it at build time? Well, so we'll just carry on. Quite clearly, the classes can be just files in your file system. If you've got Maven, you've got target classes, they're files there. So all you need to do is take those classes and enhance them in place on the file system after the compilation step. So after compilation, after test compilation, you enhance those classes. So you can enhance the main classes and the test classes as part of your build. Probably only two tricks here if you own a Java agent. One is when you use a Java agent, you need to know the class path. And two, once you start doing this, the Java agent needs to be able to handle the fact that the class might already be enhanced. So it might be enhanced at build time and or at runtime. So that's typical when you're doing a development. You're going to want to do either or, but maybe at deployment time and production, it's always just enhanced at build time. So this can happen for things like transactional times, entity. We just do the enhancement at build time, and that means that we have already done that work and we don't need to do it at runtime. There is one other thing I guess I could say here, which is that this is also simplifying our world in the sense that now we only have one class. Actually, the motivation why I turned some of my, all of my agents into supporting build time enhancement is because it can simplify your world. When you have dynamic proxies, you've now got two classes. You've got the original one, and you've created this new one on the fly, which is actually subtly different. And this actually, if you do this, it simplifies your world. So, timed and entity, those types of cases are all good cases for build time enhancement. This could be super simple. So this is a Maven build plugin. There's a magic source here, which is the extension is true. That just says I know which lifecycle I need to register for, which is after compilation, I will enhance the classes that are in main. After test compile lifecycle, I'll enhance the test code. So it can be as simple as that. There is a problem depending on your observability. So Java agents, so what we had there is Java agents, and if they're compiling everything that your application wrote and compiled, that's in your target classes directory. But agents can also enhance things that are not in target classes, but are in jars. There are dependencies and libraries. So the classic one here is I've got some sort of observability Java agent, and it's going to enhance, say, the JDBC drivers. So if your application is using this technique, you've got a problem, because the technique I told you before was about things that are in target classes, target test classes. But enhancement observability can also happen in library code. So if this is your path and this is your going to native, then you've got to deal with this. Now for myself and for the applications I tend towards, then this has not been a problem. I realise, and I guess I'm going to say why. So in my world of observability, which is very opinionated, so this is all opinionated stuff here, there's core metrics that I care about. So the first one is controllers. So you basically all of your entry points and how good they are, or how bad they are, or what if there's any changes. So it's really obvious. That's your sort of your top level metric. How good are all your endpoints on the REST API? The key, I guess, in what I've experienced in terms of measuring or looking for observability metrics is these 1 minute stacked bars. So this is a stacked bar, 1 minute aggregations of the total time for every controller endpoint. And then you can see, oh, there's something happened here, there's a little bit of spike in the middle here, there's light blue, but you can kind of trimmed it off to save the, protect the innocent. But if you hovered over each of these, you would know exactly which endpoint each endpoint is a particular color, and you know, oh, something happened in this particular endpoint. Oh, what is it? And I've only got one chart here, but effectively you want three. One for total time consumed per minute, one for average, and one for max. And average is, generally speaking, not a static bar. Can be, but average can typically be some sort of heat map. So you want that on your endpoints, and you want that also on your components. So the classic one here, all Spring components, all public methods of Spring components, enhance them so that you know where all the timing goes. So you've got your top level one, oh, this controller is a bit sucky, and then you dig in and go, what's the internal time, where the internal time is going. Now those two things there are all in your target classes, so you can enhance them at build time, you're all good. I guess the other one is timing on database queries. So if you're relying on an agent that's enhancing JVC drivers and stuff like that, you're going to have to address that. I guess I don't do that. So I'm ORM guy. I tend to use EB and ORM because I'm totally biased. So this is an ORM query. It's actually a strongly typed query. Query for application metrics, where two qualities, find one, it's going to find all of the properties. But you can have a fetch group or something like that to optimize that query. But the key here is that I've got a class and a method name, so I can actually give this a label. So in other words, when I'm looking at metrics, you actually have to relate the metric to your application. You say, oh, this metric sucks, but where is that code that called that query? So the key one there is to identify where those queries are in your code and understand why, where they are to address them, why they're like that in terms of performance. Of course, once you do that, you can actually include that into the SQL. And so if you're looking at observability from the database perspective, you can go, well, this query sucks. Oh, that's the class and the method that is the source of that query. So, and those two things, if you're looking at PG stat statements, the equivalent from a database perspective, you can also go back in. So I guess those are all the reasons why, from an observability perspective, going into not having a problem there for ground native image. But if you are into that, then you've got to look at those agents, see what they're doing, come up with a plan for observability. Okay, so now we're going to talk about annotation processing. But it's a quick coffee break for me. Okay, so how many people have written an annotation processor? Yeah, okay, good. Lots of you. Okay, so this slide is about, to some extent, top level of annotation processors code generation. And I'm kind of trying to say, hey, it's cooler than just code generation. So, hey, what's just code generation? Something like, hey, take a WSDL, generate your code for your SOAP service, or take a Swagger or Open API, generate some code. Those are like one-off generations, but annotation processors are a bit cooler. So what are they? You register them with Java compiler, JavaC. At compile time, you get a model of the classes that are being compiled, and then you can generate new source code or bytecode. Okay, so that's what you're supposed to do. For your famous annotation processor that does other things, but we won't mention it, I think. Okay, first cool thing, they're reentrant. So when you generate, you take a application and you're compiling it, and it generates a new class. That class can then go feed into another compilation round, and then that class can have annotations, and that can generate new code. And so you can go into this reentrant recycle of compiling until you've got to a point where there's no more new code being generated, and then the compiler knows it's done. So in that sense, this is very cool. You can use this from a very generic perspective to generate code that then generates other code. Second other cool thing, this is cool, but it used to also be a pain in the ass, right? So this is cool. Generated types can be in source code, but they don't exist yet. So, okay, what does that mean? You go git clone, you've got the code, in your source code, you'll actually reference types that actually don't exist. They don't exist yet because they haven't been built yet. So as soon as you Maven compile code, that will then generate them and then they exist. So in other words, the Java compiler is smart enough to know that actually some of the things that I'm compiling don't exist yet, and I'll wait until other rounds of the compilation to then know, oh, they exist, and I can compile and I'm all good. So that's very cool. It's also potentially was a problem back in the day in terms of tooling. And this is all about moving work from runtime to build time. We're trying to reduce our runtime costs. Okay, so I've got an example here, and this is a JSON processing. So I've got a class, it's got an annotation at JSON, and it's got 3 attributes, ID, first name, last name. We're using Maven in this case, so we've got Maven compiler, and we've registered a Apache JSON generator with as an annotation processor to the compiler. So it's the same. Hey, when you compile, use this. I guess I will say. This is probably more the path that we're doing with integrity by default. You can also, if you're aware, you can just basically take a generator and put it into the class path as a provided scope, and that will work today. But I guess integrity by default is where we should be thinking, and we should be explicitly registering our annotation processes. If I'm, reading the tea leaves correctly.
Did they change it to put the annotation processes by default?
Yeah, so there was a little bit of a foobar there where they did do that. So the question was, did they change it so that it wasn't going to include it by default? And yes, they did, and then they changed it back. So there was a little bit of a glip in the matrix, if you like, little problem pain there. Okay, so we've taken our code, we've compiled it, and we've generated some source code. Crikey, what does that mean? So let's just have a quick look. What are we doing here? Okay, so we've got 3 properties. The guts of that is that we've got a toJSON and a fromJSON method. It knows exactly what the code is, this is what the types are, and it's just generated as code. Probably don't need to say too much about that. There's some interesting things about that in terms of performance. We won't go into that because, Yeah, there was a bunch of things I was going to say, and I'll probably add up that. Okay, so a few things. JSON, so you'll note that it's taking properties and then it's using numbers. So when we're doing the toJSON, 0, blah, blah, blah. So JSON can actually use pre-encoded keys. You can use pre-encoded keys for writing JSON and pre-encoded keys for deserialization. So if you want to go really fast with JSON, that's kind of what you need to do. If you're into the fastest JSON processing stuff, you're into that sort of thing. So that means that you've basically got these keys as just raw bytes, and you fire them raw byte arrays into the input or output. The other thing is that when we're doing this, we actually explicitly annotating what we can convert into JSON. So from a security perspective, I can only now JSON serialize or deserialize what I've explicitly marked with JSON. So so we're talking about whitelist versus blacklisting in terms of security. And when you talk about ahead of time, one of the things that people will talk about is a security aspect. We're going to remove some dynamic aspects. So we aren't going to go class for name, dynamically create, whatever the hell we like. We're moving away from that to saying, you know what? We're only going to do what we explicitly say we're going to do in terms of creating classes and things like that. Okay. So now we've got another example, controller, standard stuff, controller, path, get, ID, blah, blah, blah. Okay, so do the same thing. And in this case, this is going to generate code. If you're looking for that question, what the code is targeting, this code is targeting Helene 4. Helene 4 was built for virtual threads. So it's a very cool lightweight web server. The guts of it, you can see the routing. We're going to add in a routing path. So routing.get, fine, and then it's got an automatic reference to the method, find by ID, setting request response, pulling out the path, and then I'm calling out code and getting a response back. So what are we doing here? We're turning JAX-RS into generated code. So you think JAX-RS Jersey, rest easy, Spring MVC. These things are all not doing this. They're actually going to use dynamic proxies, and they're going to do stuff using dynamics proxies and reflection effectively to do our controllers. We can turn those things into generated code. Okay, this is the last example, and it's the classic dependency injection one. So, see how we go. So this is controller, but it could be singleton or any of those stereotypes. And we know that we want to, from dependency injection, wire it, and we can see this constructor, so this is going to use constructor injection. If you know dependency injection, you kind of break it into 4 problems. How do I wire a component? Like, how do I create UI controller? Wiring order. How do I control the wiring order? What's going on there? AOP and component testing. So these are kind of the 4 major things that you're looking about in terms of dependency injection. So this is turning, this first part here is the first part. How do I wire a component? How do I wire UI controller? So that's constructor, and the highlighted code there is new UI controller, and it's taking in the 2 things that it needs. It needs a UI service and a message service. Yep. And then it's registering it. So you kind of think of Micronaut, Arc, Jet, which is this, and then before that, Dagger as well. They're all using annotation processing to do parts of this work as compiled code ahead of time. There is the second part here, which is wiring order, which I was trying to explain. See how I go with this explanation, which is when we wire UI controller, it has dependencies based on the constructor, and so we need to know that those things exist first. So actually there's a wiring, big flash ordering here, going on, I'm building a UI controller, that needs to be after you build the other things that it depends on. So if you are writing an annotation processor that's doing dependency injection, you're solving these 2 problems. Or you're not. Some of the DI frameworks are not doing the ordering thing at build time. They're doing it later. They're doing it at runtime. And that's why they're still kind of less cool for me. So for myself, one of the motivations for creating this thing was I wanted to solve more of this problem at build time. Yeah, that's it. There's probably another trap. So if you're doing an annotation processor, I've now got 2 things. I've got the simple part. I'm compiling UI controller, and how do I wire that? That's the easy part. The second part is ordering, which is now dependent on all of the other things that I'm wiring. So to some extent, if I'm doing partial compiles, then I need to know some other stuff. So I need to know some metadata. And so when we're generating, we're also going to generate some additional metadata, which controls the ordering for partial compiles. Maybe I've not explained that very well, but I'll maybe have another crack at that later. Okay, so what can we do with annotation processes? So yes, we can do dependency injection. I guess I'll say this. So we're not the first people to have wanted to go faster and lighter. Maybe Android was more the first team or first group of developers that wanted to go faster and lighter. So Dagger, if you're in dependency injection, Dagger is probably like, ooh, okay, that was like really extreme in terms of going faster and lighter. JXRS style HTTP servers and clients. So yeah, we can turn that into generated code ahead of time. JSON serialization, yes, we can turn that into code ahead of time again. Bean validation, so yeah, if you're bean validation spec, yeah, you can turn that into generated code. Those first top four, that's basically a REST server. So yeah, you can use annotation processing to create a REST API. That next one, then templating, HTMX. So yeah, you can use JStashio to do mustache templates, and now you've got a UI, web UI. So you can do that all with you using annotation processes. When you do this, they will end up to be quite small. So I'm not sure if I'm allowed to say this, but I'm going to say it anyway. So micro, how small is micro, right? So micro profile came out, and it was like, oh, micro profile, nice, light, small. It's all relative to how aggressive you are, how small is small, how aggressive you want to take this. So first one, the dependency injection, yeah, 82 kilobytes for Varge inject. Dagger is even lighter, and of course, what's even lighter is, of course, manually writing it yourself. 3,000 kilobytes, that's kind of like a bit of a marketing thing. If you're Juice, you're more like in the 1 megabyte space. If you're Spring, you're kind of higher than that. JXRS style generated code, 31 kilobytes, compared to, say, hey, JXRS Jersey. It's quite big. I've chucked in there 1 megabyte, but to be honest, I think JXRS Jersey is slightly more than that. JSON serialization, 260 kilobytes. Versus, say, Jackson, when you combine Jackson core, Jackson data bind. Bean validation, yep, order of magnitude smaller from Hibernate Validator. So when you see these numbers, you go, okay, well, how small is small? Well, if you start using these libraries, small is a lot smaller. Okay, so have we done some magic hand waving stuff? What have we lost? We're moving complexity into the generator. So our generator is now more complex. We're trying to do that and making our runtime library smaller. So these sizes here are the size of the runtime library. We've also got the generator complexity, and to some extent, we've also got the actual code that's generated as addition. Sort of how do we start? So if you were writing Android, right, you would have started with, say, Dagger. So Dagger, I mentioned here, Tiny does all of that dependency injection as generated source code, and to some extent, the reason why I'm not using it is because dependency injection also includes component testing. Because I'm from another world, I'm from kind of the Spring world, where component testing is probably the most important thing that dependency injection is about for me. Okay, so, and then we've got Micronaut sitting in there, Meg, Juice, and Arc, which is the dependency injection for the CDI Lite. Arc, I haven't got on this chart. So yeah, we need to add it, I guess. The other thing that's, of course, that some people do, which is not here, is manual injection, which is even lighter, right? It's no dependency. If you're going to write your dependency injection code by hand, and that's maybe fine. The thing that I'm not so keen on there, in terms of handwriting and Dagger, is component testing. I want to do component testing. So, what are we doing? We're trying to avoid reflection, avoid creating dynamic proxies. We're going to try and use avoid class path scanning, do this all at build time. We end up with smaller libraries, and in some cases a lot smaller. There's a couple of other extras that I never really thought about until after. So how it works is source code. So obviously a lot of annotation processes don't generate source code, they generate bytecode. And I'm kind of like, I actually prefer generating source code. One of the reasons why is because I got lucky, I think, because I didn't think about this, but once you generate source code, it's going to reduce your learning curve. somebody says, how does this work? How does this thing get wired? How does this controller get called? It's actually just source code, and IDE can actually link through to it, and you can put breakpoints in it, and it's just like you wrote it. So if you're doing that and you're explaining it to newer developers, then how it works is actually source code. It's kind of cool. The other thing that I really didn't know about or think about anywhere in the early days was security from a perspective of when you start doing things explicitly, then you're not going to create a whitelist, blacklist, you're not going to use a blacklist scenario. So actually everything that you can create is going to be explicitly defined. I'm going to have an explicit annotation at JSON. Those are the only things that I'm going to deserialize. If you try and attack this API and say deserialize, GenD service or something like that, that's not going to be possible. To some extent, ground native image, taking this to the extreme, we're going to remove some dynamic aspect of what we do. Okay, downsides, there's got to be some downsides. Okay, tooling and maturity. So, wasn't always so cool. When we're using annotation processing, we're basically taking our build, like Maven and Gradle, we've got an IDE, like IntelliJ, and they don't always agree on life. And so sometimes that kind of sucked. So today it's a lot bigger. There's also complexity around partial compilers and full compilers. So what does that mean? When we're building everything, that's usually the happy path, everything's good because everything has been compiled. When you're writing an annotation processor, you're kind of aware that you can actually get partial compilers. When you compile, uncompile these two things. So you have to deal with that complexity if you're running an annotation processor. From a user perspective, things like refactoring and renaming and deleting are all basically things where things will break and you need to do a build. So, and the last one there, increased build time. So I've got people who have like a really, really big application, and actually they can't really use the annotation processor, potentially in some cases, because it's just too big, too much. So it slows down the compilation too bad. So these days, good tooling. Okay, so now we're getting into Grail native image, and I'm not sure how I'm going on time. How am I going on time? Hey?
You don't have much time. It's still fine.
All right. Okay, so they're being very generous. I'm going to crank it up a little bit. Well, that was a bit tricky. Okay, ground native image. No, that's not good.
So everything is against the time.
Oh, you know what?
It's fine. There you go.
Okay, cool. I'll waffle less, crank onto it more. Ground native image. We're into the cool stuff now. So we're going to talk about compilation to native. We're going to talk about reducing startup and warm up. And memory. Okay. So annotation processing can help us with the app. Depends injection wiring, reflection, class bus scanning. But the yellow bits here, there's the JVM. JVM is class loading, validating, linking, initializing, JIT profiling, more JIT profiling, compilation. All of those yellow bits are what we can basically deal with compiling to native ahead of time. Good and bad, right? We're going to lose our JIT profiling. Okay, then what's the catch? And probably this is a slide that if you're going, oh yeah, cool, let's get into Grail native image. This is where all the little mini dragons are. So I guess, just watch out for these little mini dragons. Explicit metadata. So you need explicit metadata for things like reflection, JNDI, resources, etc. And this is kind of where the little mini dragon is. I've said it in a couple of other ways, using non-dynamic subset of Java. This is how some people are projecting, hey, we're using Grail. We're going to use not the dynamic parts of Java. We're going to try and move away from reflection, etc. You need to know your dependencies. It's got no yellow bits or anything like that, but that's probably the tricky one. If your application has got 100 dependencies and none of them know about Grail, then you've got a maintenance issue and you're at some point going to get hurt by that. A dependency is going to bump. It's going to break your application. If you've got not many dependencies, then you're in a happier place. If you've got truckloads of dependencies, or you don't care about your dependency tree, much more risky. Okay, peak performance. We'll probably talk about this more later on, but effectively, we're kind of losing the JIT profiling. If you see what's awesome about Java, right? Fantastic garbage collectors and fantastic performance we get, and we get that from C2 profiling and optimizing our code. Doing it all for us magically, which is awesome. And we're going to take that guy and we're going to lose him and we're going to replace him with ahead of time compilation. So there's the PGO, profile guide optimization, and the ML-based optimizer, machine learning based one. So it's, and we've kind of limited garbage collectors. If you're on a Mac, you don't have G1. Epsilon is the no GC, no op. So basically, if you're using a CLI application, you might use Epsilon. Maybe Shenandoah, that was just recently announced. Red Hat's going to look to provide that. So Shenandoah is one of the zero pauseless garbage collectors. So ZGC and Shenandoah. Okay, long build times. So the application I'll demonstrate, hopefully, quickly, if I'm not running out of time. It takes 1 minute to build on my machine, 4 minutes to build on a GitHub worker. Other apps, a Quarkus one that we've got to work, takes 13 minutes to build. Okay, so things are going to take longer to build depending on how big they are. Build platform, you're now also targeting a specific platform. Now, to some extent, if you're like, oh, we're always going to target Linux and deployment to Kubernetes, then you're pretty good. But you just got to be aware of what you're building. Oh yeah. So basically, it won't work for everything. You need discipline. You can't just think that this is some sort of magic bullet that's going to solve all problems. Okay, if we get killed off, this is probably like the big motivation slide here. This is not my slide. I've borrowed it from the internet, and basically we're projecting the motivation here. Why do we care? So we'll quickly go through it. Memory usage. Basically, we're dropping 400 megabytes of RAM. That's 39% lower. Peak throughput, basically the same. Throughput per memory. And they're interesting that this metric even exists on the slide. And the reason why is because I think that this equates to server density, which is basically money. 49% better server density. Is that what's possible? That's what's possible. That's what the slide says. Tail latency, we don't want it to be worse. Startup time, yeah, it's cool to start up fast. But what do we care about? So if I'm writing a service, and I'm typically writing services, and I'm I/O bound, basically always I/O bound. I'm not CPU bound, I'm I/O bound. And oh, by the way, I'm using virtual threads. Memory becomes more important than CPU. So CPU is important, maybe memory is more important. I'm kind of thinking that's the case. Could be wrong.
Well, probably depends on how many services do you run on a single machine.
How many, yes, so if you're, I guess we'll come to the next slide. See if I'll answer it and then maybe not. Improvement in server density. So what are we talking about server density? So if you're in a new world of deploying things into Kubernetes, you're saying, here's my service, here's the amount of CPU I want to give it, here's the amount of RAM I'm going to give it. Now, if I make those smaller, I can put more services into that same cluster. I can improve my server density. I can save money. So how much money, right? It depends on how dense I can make that. So
the CPU bound will be still the same.
If you're CPU bound, yeah, so it's, okay, I'm going to say that this is a lot more complex than what my slides are sort of really rattling around, because to some extent, you can get different ratios of memory to CPU, right? So it's not always clear. This is not an easy, this is the answer. So, but if you're CPU bound, then you'll care more about your memory, your your throughput per memory is less, you don't care about so much. Now, the reason why I say, we're running out of time. Crap, because I've got a few slides. If you compile to native, you're going to produce a native executable. The thing to note here is there's still a runtime. Substrate VM is the runtime, and you've got some garbage collectors there. So that's cool. Can I have 4 minutes? One, shoot. Okay, the guts, the orange bits there, metadata. Profile guide optimization, optional. The orange bits are reachability metadata. That's the little red dragon, right? It won't work with the dynamic stuff, reflection, etc., without the reachability metadata. What does that look like? That looks like JSON files, either in meta native image or in the global repository. And the net is that these things need to be explicitly defined. That means that if you have libraries that you depend on that don't know anything about this, you might fall apart a bit when you upgrade those libraries. So what does metadata look like? It's pretty straightforward stuff. A JSON file in a particular path, or it's in the global repository. You can get Native to automatically determine it. Build options, this is the other little dragon. When you're building, you've got two choices. You can use the muscle tool chain, and then you can go with the default, which is mostly static. If you do that, glibc is not part of your native executable. This is the little mini dragon you need to know about. Short version is if you use the Red Hat Universal Base Image Micro 10, it's going to come with glibc 239. You've got to link that up with what you need. Obviously, if you're building locally, you can do what the hell you like. So when you build it with native, you've got typically maybe a profile, and then you've got some options there. Some of these options are platform specific. So for example, G1 doesn't exist on Mac. So that's why you're going to end up with profiles. If you're building on a plain vanilla GitHub worker or something like that, you've got to link these versions. So your glibc version and your build platform have got to match. And if you don't, they won't work. If you're losing Jim. Okay. Build report. Essentially, when you build it, this takes 1 minute locally, and you get an interesting report. And I might show people that later during the break if anyone's interested, because I think I've completely run out of time. I was going to do a demonstration, and they're probably, if you're going, well, is this cool or is this bollocks? Memory, RSS, that's total memory. That's total memory consumed, 50 megabytes. So yeah, it runs fast, but it only uses 50 megabytes of RAM. Effectively, the Docker image size, 57 megs. 7 megs of that is the base image, 50 megs is the application. And yeah, it's a web application that talks to the database. So this is like full stack application, if you like. I'll show the demo for anyone who wants to after lunch or something. I think we're completely gone over time. Okay, so I guess I'm pushing the boundaries here. Motivation, we want to save money. We potentially want to improve our server density. If we're IO bound, we're really into it. There's lots of catches, I guess. Well, sorry, there's two main catches here. One is your metadata, right? And so the key thing here is that you just can't build, you can't have this massive application with hundreds of dependencies, and you don't know what that dependency tree is, you have no idea, you probably created a risk factor. Needs discipline. And so, poof, I'm not going to talk about project laden, and I'm not going to talk about crack or JIT servers. Yeah, I think I'm going to flash through these things just so you know. Project laden has got two-phase workflow. This is the JVM. So one, it's now got a two-phase workflow. You've actually got to build it, run a training run, and then run it again. That's a potential problem. Second problem is it's probably not going to reduce your memory consumption. JIT as a service is an interesting one. If you've never come across it before, OpenJ9 and Azul both have JIT as a completely separate service. So if you're like, I want to run the JIT, remove the JIT compilation over here to somewhere else completely, that's an option. And crap. So the guts of this is it's two-phase process again. And to some extent, we've got two problems. One is we typically want to create our image in test and then deploy into production. But now you've got like stuff in memory from test being deployed into production. So how do you deal with that? And two sides of the file, it's really just big. So that's the end. Woo! And I've only run over heaps of times. Yeah, that's me. Thank you very much.
You should blame me for the delay because I'm very interested in notation processing Java agents and compiler plugins, and I needed to listen to the talk so we can reduce the big coffee break to a little smaller one. You can still network. Yeah, around 5 minutes. Then we will give the word to Philip, and then we'll have lunch. If we have a larger networking session now, we'll be late for lunch, and I guess you're probably hungry. And so let's start after 5 minutes.
Sorry, mate.
Yeah, no worries, but maybe we can have a whole day of this one. It was like 100 slides or something like that.
It was
in the demo.
Yeah.
But it's a very interesting topic. Pretty much people care about what they should. Especially in our space. Realizing what it was. They don't replace any other So compiling the library, starting the build agents, compiling the games,
So profile coded, we use run it as a training run on technical profiling, we compile and make it in. Yeah, so the idea there is that yes, it will work totally. If you're considered building it, basically everyone trying to automate that, I'm trying to do it manually. My probably initial thing is if my performance, if I'm on 90%, so if I'm close enough to performance, I'm going to go with the simple build plus library, and then I can if I go, I really want this. Yeah, but then you've got to basically create some sort of harness to solve. So you have to build, not like you first build the profile, bring it up, run reasonably production equivalent loading, produce a good profile, and then feed that back into the combination. So it's that test harness that does the reasonable production load.
Parents understand all can be
yeah, so I don't know enough about how much of an impact profile code is and how good the first compilation is. So first compilation is good. Then you might go, I'm kind of looking at just the memory part here. That's good. If you go to the
Don't get too strict, don't worry.
Sorry. I was also very interested in the topic.
But nobody's understands it. Yeah. After Java 1, she was like 2 hours sitting on a table explaining things. It's very related also to the next session. Part of the 7 is known as real-time No, I don't believe so. Spring roll up. I hope for Spring 4.
The other end, which is if our target
But I think already it is before that 2.7 when they made it possible to migrate to fast they target small applications with the fast So it could decade. Yeah.
but on bias
Yeah, you're curious to no exceptions.
well, I think there's so much I'm not 100% sure how many this thing here.
We ended that time with 02. Mine. So, as I said, I'm the bad guy to interrupt you once again, but we need to finish relatively on time for lunch. You're probably hungry, I'm probably hungry. A little bit of an announcement. The slides in the video from Baruch's talk are already uploaded in the URL that we provided, so you can already access it. And now, last talk before lunch, so let's give the word to Philip.
Thank you. Can you hear me if I just speak without the
But
mic?
it would be better if you can speak.
Because I want to do demos, which is going to be difficult.
Then you can switch off
Okay.
the mic.
And before I start, some news. The final score for the Ireland game was 26-13 All Blacks. I don't know if you guys saw that. I'm going to dive right into it. And before I start, I want to give some context just so that we are all on the same page. I hope everybody knows Quarkus. Is there any? No? Okay. So is there any Quarkus users? Okay, we at least have a few hands. So I'll quickly run over what Quarkus is. And a lot of what Quarkus is what the previous talk was all about, right? It just makes it much easier to do because you wouldn't do anything. It's all been done for you. But basically, it's all open source. It's even governed in an open foundation, and it makes it easier to build cloud applications and serverless applications. It is really, really fast. And if I say really, really fast, let me just do this quickly. I have a demo application running to show some stuff, and it started up in 0.029 seconds. So that's what I say, really, really
Don't
fast.
compare it to Spring.
Say again?
Don't compare it to Spring.
And then obviously a very low memory footprint, both when you go to Graal or if you run in the JVM. And the reason for that is not just because of all the things that we do, the IoT type stuff, things that we do. We can, because of the things that we do at build time, we can throw away a lot of stuff that is needed typically on runtime from a framework's point of view. And then the other thing that this is what you will see today is what we call developer joy. So that's things like you can just code, and as you code, you can see the result immediately. You don't have to kill your jar file and restart it again. You've got hot reload. You've got something called dev services, which we might see, I think. So if you need something like a database or authentication server like Keycloak, you really just add the dependency and that's it. We will spin it up for you. We will configure it. We will take that configuration, inject it into your application. You don't have to do anything. We also have continuous testing because we have hot reload and because you don't rebuild every time, your test doesn't run. So now you run your test continuously. As you code, we will tell you when your tests break. And then we have a dev UI, which is a UI that you'll see today that you only get when you're in dev mode, but it assists you as the developer. I'm just going to do this because that's not working. Then as I said, we target cloud and Kubernetes, but you can still build an application that just runs on bare metal. And yeah, I'll show you that today. Or the one that I've just showed you is just running on my machine. You can decide whether or not you want to run imperative or reactive, or a combination of the two. We try and make that easy for you as well. The core engine of Quarkus is all reactive. So even if you code blocking code, when it executes, it will execute much more efficient. And then, it's got a massive ecosystem of extensions. So everything in Quarkus is an extension, and every feature that you use is an extension that you add. And we'll see some of that today. The other thing before I start to set up some context is this library called LangChain4j, which has been mentioned already. That's an open source library that simplifies integration into LLMs. On a very, very high level, the way in which I think of it is it's like a database driver for your database. This is a driver for your LLM. It just contains all the drivers for all the types that you need. And that includes drivers for vector databases if you do embeddings. And then the last thing on context is then, as I said, Quarkus works with a extension framework. So we have a Quarkus LangChain4j extension, obviously, that pulls in this library, but makes it easier to use. So you will have declarative AI services, which you will just have an annotation, and then it supports everything that you need. And then it has Dev UI integration, Dev services integration, and hopefully all of that we'll see today. So I'm gonna, let's see if I can do it this way. Can you hear me if I speak like this?
Yes.
I'm gonna show you, so what I have is, I have 7 or 6 applications already running on my machine because I don't have enough time to live code. So I've made versions of the app as I'm gonna show you things. And they are all running on different ports on my machine. So as I show you things, I'll show it in the slide, the code, and then I'll just do the demo. And the first one is this one here. It runs on 8086. So this is a vanilla application. It doesn't have any AI in it yet, but just to show you what our starting point is. So this is a basic application that does to-dos. So I can add a to-do, and yeah, I can mark it as read and delete it and so on. This is how your Dev UI would look like. You can get to your Dev UI by just going to QDev or QDev UI. And depending on the extensions that you've added, you will have cards there, and some of the cards you can interact with. So let's start with Dev services. Like I've mentioned, we will start up a Dev service for you. So in this case, I wanted to store my to-dos in a database. I added the Postgres. In fact, I added Hibernate. Hibernate you will need a driver for it. You'll add Postgres. And because you didn't configure it, we will start it up for you in a test container. And this is the configuration that we will inject in your application. Obviously, when you move to your production or test environment, you will need to set this up yourself. So you will just copy it and then modify it for your application. So that database has been started up for me and it's running. I've got an insert script just to populate it with a few to-dos, which is the ones that you've seen here. But if you're a developer and you just want to look at the data in the database, you can also go and see it here. You can inspect the data. You can even draw a ER diagram. So the Dev UI is really just there to assist you as a developer. Right. So now I'm actually starting. So this is our agenda for the talk. We're going to talk about Gen AI, and then we will talk about RAG, and then we'll talk about MCP. And those first 3 things is the how you can build AI-infused applications with Quarkus. And then the next 2 is how we've used those 3 things to make your life as a developer easier, and that's called Dev MCP and Chappy. So we'll start off with Gen AI, and I assume everybody knows what Gen AI is. But just quickly, it's basically a subset of AI that use generative models to produce text or images or software or whatever. So ChatGPT. In our application, we have our to-dos application, and it has some stuff in there. It's very high level that I'm going to talk about today. But basically, we want to have a service that can talk to a LLM, right, and come back. To do this, I can add a dependency, and this is the LangChain4j extension, and specifically the OpenAI one, because I will use OpenAI as a backend. But as I said, you can pull in whichever backend you want, whatever is supported, and you can. The only change you won't have to change code if you switch between models, but you will have to change configuration. And if you've played enough with these LLMs, you will learn that you will probably have to fine-tune your prompt depending on the backend model. Right, so in my case, to do what I've shown there is I'll have an interface. If you've ever used REST client, microprofile REST client, it's follow the same kind of idea that I only have an interface. and I have my service. So what we want to do is we want to add a service to the to-do that suggests a new to-do. So we will just say register AI service. And then we can optionally provide a system message if we want. And we should provide a user message. So in my case, I'll say I'm busy learning something. And then I've deleted some stuff in there. My prompt is much bigger in my code, but you will add your prompt in there. And then this subject here will be replaced by that variable there. So I can say, call this method with Quarkus, and it should come back with something to learn about Quarkus. What you also get when you use Quarkus and the LangChain4j extension is you have access to all the other things that you get with Quarkus. So for instance, timeout comes from the fault tolerance library. You can have a fallback method in there. You can have your metrics in there. That's all integrated with this LangChain4j extension. Oh, yeah, and then the other thing that's important is that I return an object. So under the covers, what we do is we will take that object, create a JSON schema from it, and include it in the context so that the LLM knows it should be returning. Right? So as a developer, you don't have to care about that. You will get an object back. So let's demo that. That runs on A85. So I've got my same application, but I now have this button. And if I press that button, I'm going out to OpenAI and asking for a suggestion. It said I should explore a recurring task feature. Right, so that's what the LLM came back with when I said suggested to do, which is not really something that I want to do because I want to learn about Quarkus. And that's where the next part comes in. Before I get to that, the dev UI. So if I go to 8085, you'll see that when you add LangChain, you get this card. Here you can see all your services. We only have the one. You can see your tools, which we don't have. You can test straight in here. So the idea is that you can chat to your model before you write your code, get your prompt fine-tuned, and then you just copy your prompt into your code once you're happy. Right, so let's get on. So a RAG is a way in which we can give more information to the LLM, right, basically, at a very high level. So if we go back to our diagram here, there's two parts to RAG. There's the first part where we want to take some documents and ingest it in some storage. In our case, let's say a vector database. And this can happen as a separate process. And then to enhance the context, as the question gets asked, that question will be sent to the document store. A vector search will happen. Some context will come back, and we will augment the context that you sent to the LLM. This is just so that we can get better answers. So the goal about this is get better answers. To do that, you just add whichever storage you're going to use. In my case, I'm using PG Vector, so Postgres Vector Database. But we have support for all the others. So depending on what your backend is, you can just add that. In our code, the only thing that we want to add here is we just want to let this service know that we are going to augment. So this is just on the augment side. Your ingestion has happened already, right? And I'm not going to get into the ingestion code. That's a talk on its own. In our case, we're going to cheat a little bit because I didn't do any ingestion. So all that I'm doing in my retriever is I'm getting all the current to-dos out of my normal database, and I enhance the context with that, which is a valid use case, but typically not what you do. So in our case, we will basically now say, suggest something to do. Here's my current list. Right. So that runs on port 8084. And hopefully we'll get a better answer now because we've given some more context. So Quarkus extensions overview. At least Quarkus related. Create RESTful API, right? So now we are starting to get closer to what we want in terms of the response. If we look here on the dev UI, and I try and do this just to show you what's happening in the background. If I test it out now, you can see that part there, answering using the following information, current to-dos, that's what the RAG has added automatically. And that's typically, in a later example, I'll show how we search ingested documents and find correct context in there to add to the prompt. So far, so good. Any questions? Okay.
So if you have one question,
Yep.
the dev UI for the Quarkus chain for the extension, we had a special screen where you can write prompts.
Yeah.
It's the dev UI page for the extension.
Yes.
Yeah.
Yes.
Yep. It's very cool.
Yeah. So how dev UI works is kind of how Quarkus works, is it's pluggable. So every time that you write an extension, part of what you can inject or add in this extension is a little piece of front end that you own as the extension developer. And that's what we'll show if that extension is added. Later I'll talk about MCP and it follows the same pattern there. Okay, MCP. So one of the things that you can do is you can provide a tool, and a tool can either get data or perform an action. And what happened with these tools is if I want to write a tool that, I don't know, go and read the blog entries or something, everybody that wants to write that functionality had to write it themselves. So then we came up with a standard called Model Context Protocol, so that as a provider, I can create an MCP server that you could just use, right? So that's just making it easier for you to pull in existing data into your flow. So we've got two sides to this. We've got the client and the server side. We'll start off with the client, which means I want to go and either do something or fetch some more data with this MCP client. In our case, what we will do is we will just go out and say, I want to go, as part of this flow, let's go to the Quarkus blog, find the latest articles that's been talked about, include that in my prompt so that when it suggests something to do, I know that it is something that's currently being talked about on the blog to make it a bit more relevant. So now I'm adding MCP, LangChain MCP. So you can see up until now, we've only done LangChain dependencies that we've added. If I add MCP, I get a MCP functionality. The only thing that I have to do is configure it. If you've looked into MCP, there's already a few specs out, and there's already one that's old. So the previous older one was a SSE's server-side eventing type HTTP protocol. The new one is called streamable HTTP, but we support either of those. You just tell us which one you want to use. You can also do system input-output if you stay local. In our case, we're going to go remote. And then depending on which transport you choose, you will add some more configuration, in our case, a URL. The other important part is obviously you can add multiple MCP servers. And in our case, we're going to say we want to call this one Quarkus blog, so that when we hook it in here, we will say in this flow, also use this tool. This can be multiple tools. Right. So that runs on port 8083. 8083. And we can actually open the Quarkus blog in the meantime. And we'll see what the Quarkus blog has got on. some A to A thing. So now it's stuff that's on the Caucus block, at least, right? Because that MCP flow client came in. From the dev UI's point of view, I will have an extra card now for MCP. So I can see my clients, I can see the methods that's on there. So this already went and fetched the tool list on the remote MCP server. That is the one that provides the Caucus block. What I didn't mention is that that server is the one that I actually shown you that starts up so quickly. So this is just an app that I wrote that's a MCP server that fetches Caucus blocks, right? And then I hooked in here. And then I can test it straight here. So again, the dev UI just gives you the ability to play with this before you actually start using it. I think that's it. Questions? No? The other side of it is the server side. So let's say in my to-dos, I want to be able to provide my to-dos as data for somebody else's flow. Right, so now what we're going to do is we want somebody to call us and we will provide to-dos as part of their LLM journey. So in our case, what we will do is, first of all, this is now not a LangChain extension. This is a MCP server extension. And again, you can either use the HTTP protocols, streamable HTTP or SSE, or local system output if you want to. Or we've added one that's not part of the MCP spec, which is WebSockets. And then your code is fairly simple. It's just normal code with some annotations. This could have been a REST endpoint. With the differences, I'm returning a tool response and not a REST response, right? But the important things here is your description. The description is what the LLM will decide whether or not this is the appropriate tool to call, depending on the question. And this includes descriptions for your parameters as well, so that the LLM knows what to provide when it calls this. And then I can return a text response, but it could also be an image response or something else. So I might have to put this down now. Just let me know if you can't hear me. This is running on next port, which will be 8082. So in this version of the app, I now also have an MCP server, which means something like Cursor or Claude or whatever your tool of flavor is can now talk to this. In my case, I've set it up here, so you can see it already fetched so the tool already hit my server with the tools list. It came back with there's two methods you can call: complete to-dos and get to-dos. So I should be able to ask something like what to-dos is outstanding. This will figure out that I'm asking about to-dos, and it should fetch. So I've set it up so that it pauses, right, so that I can talk through this. But you can obviously set it up so that it doesn't pause. But now you can see what it wants to do. It wants to call include completed the get to-dos with include completed false. So I can say, yeah, you can run that tool. And now it came back with my to-dos, which is those two. And we can validate that by going to our server. And those are the two to-dos that we want to finish, right? I can also do something like this. Let's copy that.
Is this screen zoomable?
Maybe. Let's see. I don't know.
Okay.
I don't really use AI tools, to be honest.
I think you meant like Control Plus, so we can see what it says.
Yeah. Oh, there we go.
Yeah.
So we can probably close this one. Is this better?
Yeah.
So what I can do now is I can say, please mark as done. And this should now again figure out that it should call complete to-dos and with that title. And yeah, if I go back here, it should be marked as done. Right, so a very easy way for your application to take part in MCP. From a dev UI point of view, on the MCP server, you can again see your tools. Is this the one? No? This one. You can see all the tools that your server exposed. You can test them right in here if you want to. Yeah, and now you can actually see the raw response. So MCP is built underneath. It uses JSON RPC as a transport protocol. So you can see the raw response there. What we didn't speak about, because I'm really just going very high level, is prompts, prompt completion, resources, resource completion, and resource templates. And these are all things that's in the MCP spec that we support, right? So if you get into MCP, we support all this, the whole specification, and you can build your Java apps using this. Is there any questions on MCP, client, server?
How does authentication work for ACLs? Like if you're saying you don't have roles to complete these things.
Yeah, I don't know, but I know that there was a blog entry about how to do security around MCP. I would assume, I haven't looked at it to myself, and I'll show you a bit later why I haven't really looked at it yet. But it would follow the normal Quarkus path, right? So you would probably just be able to annotate your method with some role. I don't know how the initial handshake happens from your cursor or whatever, but yeah, it will be something like that. From a code point of view, it should be at authorized or at roles allowed or something like that. So that was really quick. The first three parts where I wanted to, yeah.
Just ask quickly, what I understood was when you were doing the MCP, it sort of looked for the string that you had in the description.
Yeah.
And then I saw the queries you were giving didn't have that string, as that string in your code had been sort of appended to what you were querying. Or...
I missed the second part. So we're talking about MCP server?
Yeah. So like there's the description where it sort of looks to see if it matches, and then it uses your MCP server.
Yes.
Now, in the queries that you were doing, I didn't see that particular string.
Yes, because the LLM will figure it out. And you will hope that it figures it out. That's the nice thing about AI, it's non-deterministic. So the better your description, the better your chance of hitting the correct tool, but you're not guaranteed. And if you change models, you might get a different answer.
Right.
OpenAI is actually pretty good. If you go to a local model, yeah, results vary. One of the demos that I want to do with the next section, Dev MCP, I sometimes have to ask the question and then it didn't get the result that I want, and then I follow up with something so that it kind of get to where I want.
Okay.
But that's the problem with AI. It's not deterministic. You can't.
Yeah, sure.
So yeah, the first three parts was then, how can you use AI in your Quarkus application? It was very high level, but the point is that you can use plain Gen AI. You can add RAG. RAG is a topic on its own that we can talk about for an hour. You can use MCP, both clients and server. So the next two, I want to talk about how did we use this inside the dev mode of Quarkus to make your life easier. The first one is called Dev MCP. It's very similar to Dev UI, right? The only difference is that there's no UI. There's just an LLM that can now talk to your application. You don't need to add anything to get this, same as Dev UI. If you have Quarkus, you have Dev MCP. No. So this can be any application, doesn't have to be the one that I'm demoing now. Any application that runs in dev mode, what you get out of the box is your tools can talk to that application, right? You have to enable it. So we are running on 8081. By default, it will look something like this. It will be disabled, right? Because you might not want the tools to just talk to your application. But if you want, you can go and enable it. And what you'll get is the URL that you can copy, and that's the URL that you will add to your tool that's going to talk to your running application. Then, depending on the extensions that you've added, you will have certain tools and the resources available. So it works exactly like Dev UI. An extension provides that function calling, right? So if you add the extension, you might get some new methods to be called. You can see all the tools that's available to be called. Some is disabled by default, some is enabled by default, and you can change that behavior depending on what you want to do. The reason for this is if you have too many tools, you confuse your LLM. And then you might not get the results that you want. What I'll also share at the end is a URL to a video that myself and a colleague did where we spoke about exactly this feature, DevMCP, where we went and did a full example of how you can generate code and then start talking to this. It created a Kafka endpoint, it failed the test, it fixed itself, and all that we did is we spoke to this thing. Because what the LLM now have access to is it can start continuous testing. It can see the output of the continuous testing. So it can see when a test fails. In Kafka's example, if you add the Kafka extension, you can add something to a topic, you can get the values. So this thing is clever enough that you can just talk to it and it will do whatever you want it to do. You also have some resources. Again, the extensions provide these. And then, the other thing is you can test your tool execution right here if you want to, right? What I'll show is, I'm going to put this down. So what I'll show is I will just need to get into this. And so inside my MCPs, I will disable this one and then we'll enable the local quarkus. So this is now doing a fetch of all the tools that's available by your running application. Right, and as an example, what we can do is I can do something like, can you change the log level for io.quarkus.sample, which is my application, to, I actually have the wrong app open here. This might not work. I had to do a demo of something else. Let's go here. Yeah, sorry. So I'm connected to my local quarkus, and let's just close those all. I'll open one. Can you change the log level for io.quarkus.sample to debug? So again, it should come back and tell me what tool it's going to use. Typically, you will just make this run every time, right? Or maybe not every time, but use some allow list so that you don't have to stop the flow every time. Because then you get into a more kind of a vibe coding idea where this thing just call tools and then get to an end result, and you can either undo it or not. Okay, so this one said, it actually ran the one that I wanted, which is this tool called update log level. So my log level should have updated 8081. Did it? Let me just find the correct log. Or have it? Oh, it hasn't done it yet. It says it's done it, but I don't think it did.
It might already be the bug.
Anyway, it can call these levels, and this is similar to doing something like in Dev UI, I can go and find my logger io.caucus and change the log level. Right? It's exactly the same thing. It's just that your LLM has done it now for you. And that's DevMCP, right? So, and each extension will add whatever their extension points is. And we've only just added this feature, so not all the extensions support this. But we are adding as we go. And then the last thing I want to talk about is called Chappy. Is this the right mic? Yeah, so I've shown that. So, who's watched the movie Chappie? Awesome movie. If you haven't seen it, go and watch it. But that's where the name came from, because when I started this, I had to name it something. And this movie is set in South Africa, where if you've figured it out from my accent, I'm from South Africa originally. And that's a movie that's directed by a South African. It sits in South Africa, and it's about this robot that becomes self-aware. So Chappie is, to add it, you just add the Chappie extension. And Chappie is the AI assistant in Caucus. So I'm going to quickly demo Chappie. That runs on 80. So the first thing that you'll see when you add Chappie is you will have a new tab here where you can set up your assistant. It will look like this when you initially get this, and then you'll set it up. You can choose whatever backend again, it doesn't matter. In my case, my machine can't really do local models. So I'll go with OpenAI. You can put your key in. You can fiddle with the temperature. That was mentioned earlier in your talk, right? What we do is we have RAG enabled, or RAG by default. So when you add Chappie, you get all the Caucus documentation for the version of Caucus that you're running as a vector database, which means every time that you interact with your assistant, the assistant has all the documentation. And that's important because models are just a snapshot in time. And the pace in which Caucus moves is much quicker than the pace in which the new models get released, which means you don't always have the up-to-date information if you just use the model. So adding RAG just gives you that. And then you can also add MCP. I'll add that a bit later. We'll get to that. So the first thing that you have when you have Chappie is, again, because of how Caucus works, the extension will add the feature, right? So it's up to the extension and the extension maintainers to add an assistant feature. There's a few already. For instance, this database one that we spoke about earlier. And this is not right. Oh. It looks like, did I not enable Chappie? Oh, sorry. I had a small panic attack here. I never clicked save. Okay. So once you add Chappie, the first thing that you'll see is you'll have a Chappie log. And this is the Chappie server that started. And this is also the one that now has access to RAG, right? You can see all of that in the log. And now, my extensions has more features, right? Because if this extension supports the assistant, it will be there. As an example, I can speak English now here. So rather than doing a select, I will do what to do's is outstanding. And it will take that, it will include in it the table structure of the table that you're currently talking to. It will create SQL. It will execute the SQL, and it will give you the result. It allows you to very easily create SQL, and this takes forever.
Select will be probably faster.
Yeah, if you know SQL, it will be faster. Or
And cheaper.
And cheaper. Yeah. And if you you might be able to play with local models that is specifically trained for a scenario that might also be quicker. This should have come back by now. So I'm just going to quickly do this. Something happened here.
Apart from the documentation, is it also indexing the current Quarkus application you have?
Not yet.
Apart from the documentation of Quarkus, is it also indexing the source code of the current Quarkus?
No, not yet. So again, this is all very new features that we've added. So at the moment, the RAG only does the Quarkus documentation. What we will do next is the underlying libraries will be ingested as well, like documentation for Hibernate. If you add something that pulls in Hibernate, we want to add the Hibernate documentation, or the small array, or the microprofile, or the Jakarta E, or whatever is in the extended dependency tree. We want to pull, well, first index those and then pull it in. And then, yeah, lastly, the actual source code. The reason why we didn't focus on that is most of the IDE tools like Cursor or they already have access to that, right? So we don't really need to add that. But if you want to use it in Dev UI, yes, then we need to still do that. Let's see if this works now. What to do is outstanding.
I'm thinking there's like lots of click ops here. Like there's lots of click ops and like setting up options. Like, do you have like config?
Yes, if you want to set it up in config, yeah, you can edit the config file directly. Yeah. So inside your home, there's a .quarkus, because this is not config for your application. This is config for your desktop, right? You don't want to version control your setup and your mate that codes with you gets that same setup, right? So this doesn't exist in your source folder. It exists in a .quarkus folder on your desktop where we will set up this.
Well, I'm just thinking like if you've got a dev team, you might want some standard, hey, you've got the MCP, these MCP servers in April. Yeah. Like almost like a standard setup. That...
Yeah, you can share that. It's just a config file.
Right.
Yeah. Did I do this now? Oh, it already came back. So it came back with the result. So that is the correct answer. And then I can obviously get the SQL if I want to copy and paste it. I guess what I wanted to show is that what we do is somewhere here we will do the RAG. I can't find it now. Let me clear the log and then I'll show you another one. Another example of this where extensions started adding support for this is the scheduler. So if you want to build a cron, for instance, you can just say, let's say, last Sunday of the month at 9 in the morning. And this will create a cron plus an example of how to use this in your Quarkus scheduler. Right, so some Quarkus code. But you can should already know. Let's just wait for this, right? So it came back with the correct cron and some example code. And I just want to double check if my RAG is maybe off. Okay, so the reason I can't find the RAG is because I never switched it on. Right, so if you add RAG, you will see in the context the piece of RAG that we found in the documentation that is relevant to the question that was sent up in your context. I don't want to waste time, and then I'll show you some screenshots on the slide. There's some other extensions that's starting to use this tool. this feature. Again, it's fairly new, so not all the extensions has added stuff for it yet. This one is also pretty cool. You can also speak a natural language in the Hibernate, and it will give you HQL and not SQL. There's a few others. You can generate clients for, let's say, GraphQL or REST, and you can just choose the language and it will generate a client for you. Again, this is as good as the model that you provide, right? But at least it has RAG, so it will send up, in this case, it should send up some documentation on how to create a GraphQL client. And then I'll just skip this one. We also have this workspace in DevUI, and we've specifically built this workspace so that we can do things like allowing you to manipulate this content with AI, right? So add Javadoc, explain this, create a test, complete the to-dos. And again, this is pluggable, so an extension developer can add code to add to this action dropdown. And so again, this is a new feature, but the extensions will start adding things here that might make your life easier. And then because we now have, this is the last thing, because we now have RAG, we can now allow you to just talk to the documentation, and everything that we've done up until now has been added to your history. So you will see we've generated a GraphQL client, we've created a cron, and we've done some SQL. So I can initiate the chat basically from my extension, but if I want to follow up, I can just come and find it here. I can also just do a new chat here and ask anything, right? What we do when it's initiated out of an extension, we narrow the RAG down to the documentation for that extension. If we do it from here, we can't do that because we wouldn't know what extension we are talking about. So now it will RAG over all the documentation. And then the last thing I want to show is you can then obviously enable MCP. You can add your own MCP service if you want to. And by default, we will hook into the Dev MCP server that is, if it's running on your machine, if you've enabled it. So it does mean that if I do this, I should also be able to go here and do the same thing. So let's do this. And can you change the log level for io.orcus? So this is basically exactly the same as what we've done out of Cursor. It's just you now have the same ability out of here. And as I said, you can look in other MCP servers if you want to. So it came back and it did what I didn't want it to do. So it suggested that I change my applicational properties, which will persist this change, this log change. And if I build a production, then I will have debug on a production. So I will have to do something like, no, I want to change this for the session only. So the tool that it suggested to use is update properties, which it can also do. It can update your properties. It's got full access to your workspace, so it can create stuff in your workspace. And now it came back with what I wanted. So now it says, yes, log stream update, and then I can say, yeah, that's what I wanted to do. And we should see it in the server log down here once it's done. Now this is probably a really bad example because it's much easier just to change the log level in DevUI itself. But the point is that your chat has got access to MCP. So to finish off, I think we're out of time. It's lunchtime. Oh, I forgot to show this. I'll just talk through this quickly. When you get an exception in Quarkus, if you are in dev mode, you get a very nice screen. In production, you don't get this screen. And in this screen, we will not only show you like exactly where your exception is, you can also click This is clickable and it will open your IDE at the correct spot. And then if you add Chappy, you get this button here, and it will go directly to Dev UI, send your exception with the relevant class to the LLM, comes back with a suggestion and a fix that you can save, and it will be on your local machine immediately. And then I didn't show this as well, but like I said, if you have RAG enabled, if you ask a question that RAG could find the relevant documentation, we will add it to the context that's been sent up. And I think I've shown everything, the MCP tools. So what we have with Chappy is basically everything that I've spoken about up until now. We can talk to LLM. We have all the caucus documentation ingested in a database, which we do on caucus release. So every time a new caucus version release, we run this process. We generate an image, Docker image using Jib with all the SQL in it. We publish that to a registry. Once it's in the registry, the Chappy documentation can use dev services to pull down that image, start it up for you, and have access to RAG. You can call out to an MCP server from our Chappy, and Chappy will automatically call your own running dev MCP server. So we have our own dog food with Chappy. This is the last slide. So this is just a bunch of links. This is the one that we went into detail of dev MCP, if you're interested. And I think that's it. That should go to the code, that QR code, to my demo app that I showed today. And that's me. Is there any questions?
Go back to the earlier slide.
Yep. I know it was very high level, but I wanted to give a high level idea of what is possible with AI in Quarkus, and then how we've used it. No questions, no comments.
It's cool. Can you summarize what are your next plans for what you're developing in Java?
So part of the team is heavy into the agentic stuff, and there's a whole agentic flow inside LangChain, not even Quarkus, LangChain itself, the LangChain library. So that's a lot of focus is on that, and then pulling that into Quarkus, obviously. I don't know if that's something that we will use inside Quarkus itself. I can't find a use case for it yet. So that's mostly on the when you want to use AI, it's mostly agentic. For the dev tool side, what we're working on is, like I said, pulling in other RAG, so from other sources. That's a big focus. And just adding more extensions to contribute to the MCP methods, or even to Chappy, the assistant methods. Is there any suggestions? What do you want to see?
We will keep. Not now.
Maybe over lunch? Yeah.
Some, let's say, I don't know, code generation capabilities from this based on Quarkus documentation to make some kind of an improvements.
Yeah.
Based on what we already have in Quarkus, but maybe it's not the optimal.
I mean, we kind of have that a little bit, but again, I don't know how well it necessarily works. So if you have code that has to-dos in, you can go and say complete the to-dos, and the AI will have the context with the documentation. So if you coded a Panache or Kafka or something, the RAG will find Kafka documentation, pass it on to the LLM, and it should complete your code. You're going to have different results depending on your LLM.
Yeah, the problem I see here is that we're still relying on the LLM to parse the code as a text. And what would be the suggestion is to parse the code freehand as an abstract syntax or something like that, and feed the AI with the vectorized syntax tree.
Yeah.
Then receive suggestions because it will cost less tokens, probably.
Yeah.
And maybe it will give more accurate results.
Yeah, and at the moment, our RAG is very basic. We just read the ASCII doc and we vector store that. But you can get clever with RAG. So one of the things that we are looking at is finding, for instance, in the documentation code snippets and add that metadata that this is a code snippet. So that when you do the search, it does it better. We think it will do it better. We need to play with this and see what the result is. Yeah.
Quick question. Is the dev UI, is the logic for that part of the build product disabled, or is it stripped as part of the?
I want to repeat the question just to make sure.
Yeah, there's dev UI functionality.
Yeah.
Obviously, the logic's in the running Farkas application.
Yeah.
That you're running on your laptop.
Yeah.
Is the logic for this part of the build product of the Farkas application, or is it stripped out?
You mean the build part, like when you buy a subscription from Reddit?
No,
when you build a production, then it's out. Yeah, then there's nothing there.
It's stripped. Even the logic is stripped.
Everything. Yeah. The JavaScript, the backend logic, the dev UI works also with JSON RPC. So all the connection to the backend is JSON RPC. All of that code exists in a specific module. I can probably show you, but if you open the Quarkus documentation, you will have a runtime module that will always be included in your final artifact. So if you build a production, that will be there. But there's one called runtime dev, which is a special module that only loads in the runtime when you start it in dev mode. So as an extension developer, you will, when you create an extension, you add the stuff that's, because it's not only dev UI. We have a CLI, same story there. We have some features where we provide data to IDEs to be able to pull data from your running app. That all lives in the runtime dev or in the deployment module. So a lot of the dev UI actually lives as part of build time. So all the JavaScript is build time only. But yeah, once you build production, there's nothing. That error page that I showed, it will show a blank screen with just a response code. Yeah.
Just building on that, the thought when you were saying, ideas and whatnot, that could be useful.
Yeah.
Is I was thinking actually, absolutely, you don't want this enabled in production.
Yeah.
I was thinking in an incident, in a situation where you've got like one pod or something doing some weird stuff, right? There was a thought, if you could turn this on, and also you had telemetry from like the running application, you could combine with like the SD.
So you're not the first one that asked for that.
Yeah.
I probably on this laptop might have some code where I start playing with something I call prod UI. Prod UI will be a subset of dev UI, but you can't put everything in there for various reasons. One, security, but also two, a lot of the stuff that we do in dev UI is only available in the deployment class path. So for instance, one of the things that you can do is you can build your Kubernetes manifest. But that happens against the deployment class path, not the runtime class path. And I don't have the deployment class path when I run in runtime. So there's certain things that you can't do. So there's some footwork that it's not difficult. It's to find a way to make it easy for extension developers to distinguish between which is where and when is. And sometimes, like for instance, configuration, you might want to show the configuration in prod UI, but not allowing to change the configuration, because the changing of configuration will restart your pod or something, right? So yeah, it's not a high.
Let's continue the discussion, maybe downstairs at lunch.
Thank you.
So everybody is welcome down. Have for lunch and probably continue the discussion. Thank you very much, Peter.
And just to mention, so because we're a bit late in time, so we continue after 50 minutes. So let's make a shorter lunch break. So I think 2:20 would the next session start after lunch. Yes. Oh, yeah, sure. Okay, yeah. We'll
That's very good. So you're a Plasma user as well?
Yeah, been years.
What's your OS?
It's Fedora. Have to.
Oh, yeah. I'm a Nexus user. I did start with Red Hat at like 3.2, like back in the 90s.
I used to, before I joined Red Hat, I used Arc. I love Arc, but yeah, it's just easier, now VPNs and stuff, and to set it up on Fedora, it's just easier.
Yeah, I see Arc and then Nginx struggles. That's really cool. I've never played about this, but the whole dance of like what you presented looks beautiful.
And that's only one part of Quarkus. The main selling point of Quarkus is actually how well it production, how much money you save. So the previous speaker that spoke about the IoT, you get all of that without having to do all the stuff that we discussed, because that's what we do under the covers.
It just works out. I sent a message actually to Starfinch as UK Starfinch on the start times.
Yeah.
I was like, shit, let's check out Quarkus.
Yeah.
Wow.
And
Quarkus?
Yeah, I think the real one is Quarkus.
Okay.
But different people. Yeah. But I'll
Where do you work? It's we're about to Marathon. It's a US global so I'm New Zealand based. US. You don't?
No, I haven't.
एक घंटा लगेगा तो खाने में 2:30 बज जाएंगे प्लीज कटलरीज करने हैं
Oh.
We were thinking about, yeah, the nicest place we've seen so far is the Mount Eden summit. It's like a volcano.
Yes,
It's
I
very-
want that. But try to go to Capital next time.
You think it's worth it? Yeah, maybe we not tomorrow.
But you need a car.
It's four of us. You're renting a car?
Oh, I rented a car for this.
Oh, nice. So,
There are buses, but I think it's cheaper by car.
okay. Is your laptop charged well or not?
Hopefully, yes, but let's see.
I'll just play it just to keep the stream running.
Oops. 1 hour should be enough, I guess.
I can make it in 15 minutes.
Maybe we can charge it a bit in the meantime. In the lunchtime, I mean.
When did you write?
Wednesday.
Wednesday.
Yeah. And we're leaving Sunday. No, next Sunday.
Okay.
We did. I had a session at New Zealand. They wanted me to present, speaking with them about potential sponsorship for next year. We had an event with Paul from Groovy at the AWS office. So, and Sunday there is also a GDG conference. How long are you staying here?
I'm leaving tomorrow.
Tomorrow? Oh, wow. Are you going back directly to? Wow.
I have 7 flights. Auckland, Singapore, Frankfurt, Christ.
For us is as well, but we fly to Auckland, Hong Kong, Doha.
And you want something?
No, it's like 2-3 hours between the flights.
Can I change it?
Yes. Do you need a mouse as well? Because I brought a mouse if you want it. I'll just play it in any.
I don't use a mouse, and that's why I don't play.
No, I'll just.
How is the battery life? Hopefully, yeah.
Okay, yeah, mouse is fine. So.
Ще уходната на сесията. За малко да стане добре.
You should be also on this laptop comments.
Yeah, I changed it. Can I fix or continue?
Yeah, continue. Yeah, yeah. Yeah, we also completed that. Yeah, I think it should be fine.
And I will just change it to be on, not to be duplicate, to be extended.
To duplicate.
Not to duplicate, extended.
To extend it, it should be. Okay. Yeah.
And I guess it should be.
Yes. Yeah. Perfect. Ти имаш ли батерия за един?
Да го пуснем само с. Служи го малко да погледнем преко вече. Ще има една половина, не знам колко остава. Не сме го зарезали 4 дена.
Thank you.
Yeah, you're welcome. Let's go for lunch. trying to catch up on the agenda?
I'll try. I can try.
Well, it'll only work when everyone else is coming upstairs.
I think I can make it.
I'll stop the time.
But it will need to come. And this laptop needs to be opened again. Maybe I'm thinking that I can make it in 4 minutes. Thank you.
Right now. No.
I'll just stay here.
Oh, from here?
From there.
This way. Let me just take everything.
Thank you.
Not a very good photographer, but I can try again if you don't like.
It's perfect. Thank you.
I was talking to and the answer was kind of no.
I spoke there in 2018, I think.
Yes.
Then they were active.
Yeah, sorry.
Then they were running it.
Yes. Yes.
Let's wait for 2 more minutes.
Just let me know.
Yeah, okay.
Yeah, and it's great to keep it steady. It's working, right? But it's
Okay, I think we can continue now. It's a great pleasure to welcome Michaela on stage. So she's coming a long way, like us, from Romania. She's an architect at Systematic and also university teacher at Bucharest University,
Yes.
correct? Yes. So without further ado, Michaela, you have the word.
Thank you, Martin. Hello, everyone. Can you hear me if I speak loud like that? Okay, I'll use the microphone. All right, so I'm Mihaela. As Martin already presented me, I'm a software architect at Systematic. This is a Danish company, actually, even though I'm from Romania. And we are specialized in building software for the army, at least my department. I'm also a university teacher assistant. I'm mostly teaching programming languages, and probably you'll see that my presentation, it's a little bit atypical, I guess, because I'm not going to just talk and present you something, especially because we are right after lunch. So I would like to energize you, and I will, we are not doing sports, even though we can try fun. But I would like you to actually participate because I have a quiz. And depending on how fast we answer everything and we go along with the answers, the correct ones, the incorrect ones, and the discussions, maybe I can try to catch up a bit on the agenda and finish a little bit before the time. I'll try, but I won't do that promise. So, it's an interesting title, I guess, Unlocking Java's Code Maze. So I would like to think of Java programming as navigating through a vast, intricate maze, which is filled with both obstacles and hidden treasure at the same time. And today we are just going to discover some of these little pieces of the maze together. And among the examples that I will showcase for those exercises I will tell you about, we will deal with streams. I have plenty of them, but it's not specifically in this order, not just streams and everything else. It's combined so that we won't get bored of a certain chapter. We'll also deal with some concurrency exercises, with generics, with lambdas exercises, records, collections, and virtual threads. No, I also have some silk classes. I try to choose something old, something new, so that we see a little bit of everything. So, how we are going to proceed? First of all, bring your phones, because we have a QR here that you can scan to join the QR, to join the quiz. In case it doesn't work, even if I just tested it, I came earlier from the lunch break to test it, you can use slido.com and enter that number. I'll read it to you, 1695628. And while you're scanning this to actually participate, I will have a certain disclaimer. First of all, I know that it will be easier to get the right answer directly through AI, ChatGPT, Claude, and everything else, but let's put that aside. And let's try to remember the basic and see how much we still know of the concepts of the theory and so on. That's the first one. Secondly, in terms of the format of the exercises, I try to be consistent so that we can have a smooth experience along the way. Each of the exercises will consist as follows. We have a piece of code, we will look at it, and there are two options. Some of the exercises, some of the code snippets will address something like what will be the displayed output, so those are easy. If we have an IntelliJ or something else installed on the laptop, you can even try them if you don't trust me. Obviously, we will need to figure it out what will be the correct answer for those type of exercises. But the other ones, those are subjectives, because the second category consists in optimizations. And I added a couple of examples, a couple of options. One is better than the others, but there are obviously a lot way more ways to refactor a certain piece of code. And if you have other ideas, we can surely discuss, and maybe I can even change the options for the upcoming event that I have with these topics. Because as mentioned, as a disclaimer, I was subjective. I thought of some aspects that I can improve there, but there are plenty more, and we can even rewrite the whole code in a different way. So, is everyone ready? And scan the QR code. Perfect. Then, let's start with the warming up exercise. And I think that from time to time I will sit down to see the code better on the laptop. So let's see what we have here in this first exercise. Here we are dealing with static variable initialization, where the order of the initialization actually matters, because sometimes it can lead to unexpected results. Let's see if this is the case. So we have there that value initialized at the beginning with 10, then I set it to 20. If we were to run this piece of code now, what would be the expected result? And let me give you the possibility of you to actually submit the response now. So let's see, what do you think? We will get a value of 10, the first one, 20, or maybe a compilation or error, or an unpredictable output. What do you think? It's just a warming up exercise so that we can get used with the format. Okay, almost all of the answers are being selected. There is only one correct option, only one that you can select. Let's see. All right, time's up. Ready to see the response? I will enable it for you to see it on the phone and also here. So the right answer is B, 20. And the majority of you answered B. I see some of you decided that there will be a compilation error and others selected a value of 10. Nobody with that unpredictable output. I couldn't trick you. Okay. Let's see what we have here. So static blocks, first of all, are executed in the order they appear in the code. So first of all, in this example, the static block initialized the value with 10, but the subsequent static declaration sets it to 20 on that line that we have there, hence making the correct output 20. There won't be any compilation error. It is allowed to override the value in Java. All right, this was just a warning. Let's continue with strings, because I did mention we have a couple of exercises. Hope you can see the code well. All right, let's see what we have here. We have a simple list of strings, and I wasn't too inspired when I put those strings, so it's just a list of fruits. And we are performing some operations over there based on the string obtained from that list. In this example, I'm partitioning that list of strings based on a condition where there is a small twist with the method being called, that method that you see there called check vowel. So what do you think is the displayed output in this case? If we run this code, what we will get? And I hope you had enough time to check the code, and you can now submit your answer. You will see the options on the phone as well. So let's see. You can select any option once you read out the answer. Okay, the balance is primed to another option. So far, it was a 50-50 between A and D from your point of view. And let's see. The right answer is indeed D, and most of you selected it correctly. Only a few A and B. And in this example, at least that twist I was telling you about is within that partitioning Y that we have used there. It's been in the Stream API though for a very long time. I think that even from Java 8, if I remember correctly. And the custom method that checks the vowel has that regular expression. That was the twist I was telling you about. And the correct output shows the word that starts with vowels and those that doesn't start with a vowel. Okay, let's move to something more serious. And here I have a first exercise, a first example of those optimization that I was telling you about, the subjectives exercises. We are still using a list of strings, so I haven't changed much here. Only that I have randomly generated them, sort of a large number of them. And the purpose will be in this case to group words by the first letter. This is the main goal. But as this code is being written, how would you change to improve it? Because I have used as an example, as a hint, I have used a traditional for loop. Would you optimize it in any way? Would you change something, or you keep it like this? Maybe it's optimal enough. So among the answers that you have there, at least those that I have provided, first of all, to replace the traditional for loop with a parallel stream for better performance, or to use a custom collector instead of that grouping by collector that I have used. And option C mentions to encapsulate the logic within a lambda expression. And D, as mentioned, not to change anything. So what would you choose in this particular example? And we can after see if you have other suggestions. So this being said, you can now submit one of these 4 answers that I have provided. How would you change this to get to the same result? Okay, the results are a bit tight. Not anymore. But then some. And the opinion differs in the room. Most of you selected option A, but also B and C were selected as options. Nobody thinks that the code is optimal, so I'm happy for that. Now, in terms of my opinion on the correct answer, that is option A, to replace that for loop with a parallel stream for better performance. Because if we were to change with parallel stream, this means that we will utilize multiple threads to process the elements concurrently, hence improving the performance. On the other hand, and I will switch a bit back so that I can also see the other options, B and C. Well, I think that those suggest alternative approaches. I see a couple of you also selected them, but they are not necessarily improve the performance and neither the readability. Option D, as mentioned, is no way, we won't select that. But option A, to use parallel streams and process by using multiple threads, that's the best approach.
Guess you don't care about memory.
Sorry?
Guess you don't care about memory. Like, which version of Java are you running if you're not running virtual threads, man?
We can also use virtual threads. I have an
You're
upcoming exercise.
Every thread.
Yeah, totally agree with you. We can start using virtual threads. And I will have an upcoming exercise for that. Let's take them slowly.
I didn't pick this option, but B seems reasonable if there's 10,000 words coming in. And we start with new array list, which will default to something like 16. So that's going to grow quite a lot.
Yeah.
So you can start with bigger array lists.
Yeah, I can do that. Thanks for the suggestions. All right. Let's see what is coming next. Okay, and this exercise, I'm trying to demonstrate a bit the use of generics in Java. How long time have you used them? Okay, a while. Well, let's look what we have here. We have a box class, which is a generic class with a type T parameter. And I added there some methods to set and get the content of that box. So nothing too fancy on the left side of this slide. Let's look at the main method though. Here, first of all, I set I box variable, which I have declared there, and I set the content to hello, which is a string. Then I'm declaring a row box. I initialize it with that string box, and I'm setting the content to 123, so an integer. What will happen when we were to run this piece of code? because there I'm trying to simply print the content of the string box. What will I get? What do you think we will get? And among the options, either the hello, which was the string that I have first used initially. Secondly, maybe we will get the 123 version of the second initialization I made there, or we will get an exception. And if we were to get an exception, where? When we were to run the set content on the raw box and set it to 123, or when we try to get the content of that string box. So what do you think will happen in this case? And you can now submit your answer. No, I enable it now. So let's see. We will get a string, an integer, or an exception. You said that it's tricky. A bit. I try to.
Make it tricky.
I can try to make it even trickier. Less than 10 seconds. If anyone else wants to submit.
It's not into reading bad cards.
All right, everyone submitted.
If you're using Groovy, it will just work.
I like your comments. But let's see what you have selected here. So all of them were selected. We do have almost a majority for option C, B on the second place, A and D equal percentages. So ready to see the result that may surprise some of you? That is option B, which has a few votes. I reviewed the answer on the phones as well.
Oh,
Give me 1 second. And now let me explain why. Well, we won't get hello, the first initialization, that's for sure. What we should know is that type erasure in Java leads to row types that bypass compile time checking. It means that we can assign that row type to a generic variable, and it will allow setting the content to different types. It won't complain about anything at that stage. But afterwards, when we try to set the content to 123, also nothing will happen. There is no compile time error. But when we try to retrieve the content, well, this will cause a class cast exception. And that's because it was expecting a string and it gets an integer. So only then is when the problem appears. Okay, was that a surprise? All right, all right.
Well, 123 gets auto-boxed into an integer, which is an object. So the raw type T is essentially box of object. In the bytecode, there'll be
You want to run it?
a sequence L object.
I think I can provide the slides afterwards in the pieces of code, so you can run it directly, for sure. All right, let's move further. I have a couple of what I do hope to be interesting exercises, and this is a fun quiz, I would say. And here we will play with some string concatenation. Okay, just one line of code. The result is +1 +2 multiplied by 3. What we will get? It's that simple. We have just one line and we print the result. That's the result, the actual the result object that I have used there. Maybe I should change the name. So what we will get? We will get the result is, I didn't try to trick it there. We will get that for sure. But what's coming afterwards? It is a 7, 16, 9, or 1, 2, 3. And you can submit your answer. Let's see. How the string concatenation works in this case. How does the order of the operators work in this scenario? It's a very simple and basic exercise, I know. But I thought it was fun. less than 50 seconds now. Okay, time's up. And let's see. Most of you got it right. That is 16. And let's see why. As you know, the plus operator works both in multiplication, in addition, the addition operation for the integers, but also acts as a concatenation in case of strings. So if the left operand is a string, it will convert what is following to a string as well. But in this case, that multiplication, to multiply by 3, takes precedence. That's the first one being done there. So that's a 6. And afterwards, from left to right, how we evaluate the expressions in Java, it will be the result is which is a string, plus 1 is a string. We'll have the result is plus 1 for so far. And then the 6 that resulted from the multiplication. Hence, we will get option B. The result is 16. Okay, was it fun? Yes, I heard them, yes. I'm happy. Then let's move further. And further, we have streams. Did you miss them? I still have a few more exercises. Here, I'm applying a mapping operation to transform that nested collection that I have defined there, but I also have a subtle condition within that mapping logic. I will give you a few seconds to look at the code. It's just a list made of 2 nested collection, A, B, C, X, Y, Z, so 6 letters. What will be the resulted output? And you can submit your answer now. That should be easy.
Is there a reason you don't use list of and you keep on using the arrays to make lists? But,
But I didn't quite understood.
Oh,
I didn't understand.
You use the arrays class so to go as list rather than using list of.
Okay.
List of is just a shorthand. If you want an immutable list, and you're in one Java 9 above or something like that.
Mm-hmm. Yeah, that's a good suggestion.
Makes more sense, like using a list to create a list rather than an array to create a list.
That's a suggestion. I'll keep it in mind. Thanks. Oh, the time's up. And you are waiting for me to... But everyone answered option C, almost everyone. And that is the correct answer. So this was way too easy for you, and we will move soon to something more complicated. And the condition that I was mentioning here was the use of flat map, because I use flat map to flatten the nested collection that transforms everything to uppercase. But this is too easy for you. So let's see how interesting you will find the next exercise. And let's consider this Java puzzle, which uses concurrency and the specific map, or more precisely, I have a concurrent hash map over there. So within that concurrent hash map, besides the concurrent hash map, I also have 2 threads that are attempting to update that hash map concurrently. Each thread is incrementing the value associated with every key in the map, so from 0 to 999, by 1. I think it is incrementing by 1 using the merge method. The twist is how the merge method is working. Now, what do you think is the resulting sum of all the values that I have in the map after both threads will have completed their execution? So, I pretty much read the code for you. Let's see, what do you think the correct answer is? And among the options, we have that sum will be 1,000, 2,000, 10,000, or 20,000. Let's see. You can submit your answer now. So what do you think the correct answer will be in this case? Almost all of the answers are selected. Once again. And time's up. Okay. Most of you selected 2,000s, but also 20,000s on the second place, and a couple of you 10,000. So nobody went with 1,000. Let's reveal the answer, and that is option B. So those of you that selected option B, that is the correct answer. Now, let's reflect carefully on the atomicity of the merge operation and its behavior, because it takes three arguments. The first one is the key, the second one is the new value to set for that key, and the third one is a function to apply if the key already exists. So in this case, what I have there, I have the first four. Both threads will be submitted. They will be submitted to the executor service. They will finalize correctly. The first iteration will set the keys to 1. The second one will apply the function from the third parameters of the merge. Hence, summing up, we'll get a value of 2,000 in this case. The trick here was what the third argument was with that merge method, what it actually does. And let's stay in the same area, because the second exercise here is also within the concurrent access area with atomic variables in this case. We have that count variable that I'm initializing with a value of 0. Then we have two threads, T1, T2, where I have used the increment and set method for both of them. Starting the thread, joining them, and at the end, I'm trying to just display the value of that count variable. Among the options for being selected here, we have a value of 2, 1, 0, or an error. What do you think will happen if we were to run the code right now? And you can submit your answer now. Will this execute correctly? And in this case, what will be the displayed value? Is it 2, 1, 0, or we will get an error? Maybe I added something incorrectly around here. What do you think? And I'm not trying to trick you with these questions. Too late? Less than 3 seconds, so if anyone wants to change the vote, time's up, sorry. Most of you selected option A, but B, C, and D also has some votes. And the right answer is option A. It follows the same principle as the exercise that we have seen previously. Atomic integer allows thread-safe operations, such as the increment and the get method that I have used there. And in this case, those two threads concurrently increment the count, and then the main thread waits for both of them to complete before printing the final result, which is 2. Right. How we are with the time? I think I still have plenty of minutes. Let's do more exercise. The next one is very long, so I will give you more time to read through it. It's about seal classes. I try to make it as nasty as possible to make it difficult to select the proper answer. So, at least I try to demonstrate here the advantage of using seal classes within the nested seal classes. And let's see. I'll try to help read the code. First of all, we have a sealed class called shape, which permits circle and rectangle. Then we have an abstract method called area. We have a class called circle, which extends shape and implements an interface called drawable. This only has a radius variable, default constructor and an override of that area method. Then a similar definition for the rectangle class, which extends shape, no longer implements the drawable interface. We have some properties, constructor, and once again, the override of the area method. On the other side, we have a drawable interface, which permits circle and rectangle. We have the definition of that draw method. And in the main method, we finally get there. First of all, I declared an object called shape, which is a circle initialized with a value of 5. Then I'm checking if shape is an instance of drawable. And here I'm using something a little bit new in Java. That instance of pattern design, I don't know, I forgot how that functionality was called. And I'm simply calling the draw method here. On the else statement, I'm simply displaying shape is not a drawable. Now, if we were to run this code, what will we get? A compilation error, shape is not drawable, a runtime error, or nothing. No output. What do you think? I will give you a few more seconds to have a deeper look at this code, because it's a bit long. And I will shortly enable you the possibility of submitting the answer. Are you ready? Nobody says at least one yes?
Yes.
Okay, thanks. I heard a yes. Let's see what we will get here. Less than 20 seconds. Last few seconds. And time's up. So let's see. Most of you selected a compilation error, no output, shape is not drawable, or a runtime error. All right, and the right answer is option A, a compilation error. So those of you that selected this, you are totally right. And now let's see why. First of all, shape is declared as a sealed class. And I mentioned that it only permits circle and rectangle, as I wrote there right at the first line. Both circle and rectangle, however, are nested sealed classes. And that interface drawable is declared as sealed as well. But it only permits circle and rectangle to implement it. However, in the main method, an instance of circle is created, and it checks if it's an instance of drawable, which leads to the compilation error. So this is the line where we get the error, and that's because the drawable is not permitted to be implemented outside its permitted classes. Hence, we will get that compilation error. And I would like to go now to the next exercise. However, I have a small problem on the phone, so let me 1 second to figure it out why.
Does it matter that any of the classes don't actually implement the right draw method?
That's
Sorry?
right.
That's what I was
There's
thinking.
three compilation errors.
Yeah, you've got your interface.
Yeah, that
You've got your interface saying that you need a draw method, but
Mhm.
none of your classes actually implement draw.
Well,
Yes.
only one of them declares it, even though Permits has got both. So there's
Yeah.
there's three errors there.
Yes,
So
yes,
it's not
there
gonna
are.
work.
And I even try to hide them from IntelliJ, because when I try to take the screenshot, they were displaying there. It was highlighting where the problem is. So I tried to remove those. All right, and because it's only 2 minutes till my time was officially up, I will finish the quiz now. I think we had plenty of exercises, and I hope it was a little bit of break and warming up part after the lunch break. So I would like to thank you all for actively participate and for contributing with suggestions and ideas. Based on them, I also improve this format of the exercise. Hope you like it, and we'll talk sooner. Or if you have some questions now. Okay, then that will be all. Thank you very much, and enjoy the rest of the session.
We haven't got our, oh, here's one here. I think we'll just have a break for a couple of minutes and then we'll be back shortly.
Yep.
Okay, I finished on time.
Yeah, perfect.
You're a very self-organized team.
They can play over the middle man.
Yes.
In a lot of places. In a lot of places, self-organizing teams.
That which was very good because now we're more in time. Thank you very much. Yeah. All right. It was fun. Did you receive feedback from the audience on no, only 8% were correct. And check it was already time. Okay, so
Yeah, 38 hours, I think,
yeah, I would say that
I after 7 hours on a long, after 8 hours.
Yes.
So after the 7th hour, if you go for another, it's like the first 7 hours.
How do we solve this problem? Oh, so you no longer use your
Yes.
Oh, it's just an
You're just not surprised. It's just if you want to so you shouldn't violate the law. There were like rules.
Okay. Is that saying battery's running low? What's that?
Yes, I think so.
I don't need this one, but I didn't know whether. Yeah, sure.
Hey, hey, hey. Lots of people got lazy after lunch. I can see that, but that's what happens when you eat. I know that. I hope that you at least exercised a little bit your mind with Michael's exercises. But now we need to jump a little bit away from Java to Groovy. Thank you very much to Dr. Polking, which actually came a little bit early in Auckland to the AWS meetup, and now he's also having the session here on the place for Martin. But I hope it's even for better, and we're very pleased to have him here from Australia. So
thank you. Thanks for that. Welcome, everyone. You're still all awake from after lunch? Everyone's good? Excellent, excellent. So I'm going to talk, I'll do a little bit of a Groovy 5 update. Now, I already gave a Groovy 5 update. If anyone who knows, I can recognize some of you in the audience were already there. So I don't want to repeat exactly what I did, but I'll do about half of the slides. So bear with me while I get through that, because I think people will be interested in sort of some of the stuff that's been happening recently in Groovy. So we'll do a tiny bit of a Groovy update, and then I'm going to look at some machine learning stuff and AI stuff in Groovy. So a lot of people see Groovy as sort of the Python of the JVM world, and data scientists don't necessarily want to have Java or Scala code. They want something as simple as Python. Groovy gives them a nice option that lets them still make use of all the wonderful features on the JVM world, but gives them very simple code that they can understand as data scientists or whatever it might be. So there's been a lot of folks chatting to us about using Groovy with machine learning and so on. So just a little bit of a very, very quick skim through of that stuff. Now, this will be more of a taster than, we're not doing an in-depth tutorial on anything today, just to give you a bit of flavor for what's been happening and some of the things that people are doing in this space. Most of this stuff, there's blogs, there's a whole repos. All the source code that I'm showing you is in repos. There's often blog posts about those repos, so you can go and, if you like what you saw or want to go and chase it up, you'll be able to actually find the actual code and see it run and do that for yourself later on. So in terms of why use Groovy in 2025, so Groovy sort of started out as a buddy to Java. If you want to do some scripting stuff, it could sit beside Java and it would look like this sort of, have a Java flavor, but let you do a bunch of mostly dynamic things that Java wasn't capable of, because we had the folks were sort of had a bit of Ruby and Python envy at the time, a bit of Smalltalk envy, and said, oh, I really like all the things that's happening in Ruby on Rails and whatever else, but I want to stick to my JDK because that's what I like. How can I get those features? And Groovy came about because of that. And it's actually evolved a lot now so that it actually can do everything from that dynamic roots all the way up to stricter than Java typing if you want. So you can mix and match between those. And in fact, you usually combine those two together is very, very typical these days. So I want to talk about more flexible typing. I'm going to have an example here. Just by background of this example, it's highlighting some things that happened in recent JDKs. Since JDK 11, we could run a Java source file just by going Java and that source file. It was only single initially, but it's improved a bit since then. But only in JDK 25 could we actually have this compact syntax where we can leave out the class definition. So this is sort of something that Groovy even goes further, and other scripting languages go further than that, but this is now in Java. So I'm going to compare the Groovy equivalent to that. And this isn't the best way. I'm going to show you how to print welcome to Java 25. If I was actually going to do this, I'd be using runtime.version, which has been around since JDK 9, or system.getProperty, Java.version, Java language version in older JDKs. So Groovy, this isn't the shortest way. Groovy, we can actually get rid of the main method as well if we want, but we can do this in Groovy 5, and that's pretty much an equivalent. I want to elaborate a point to do with flexible typing on this example. There's lots of things I could talk about. We could use var or def in Groovy. We could use var in Java. That's not what I want to talk about. I actually want to talk about what's over on this side of the slide. Integer.valueOf, it's not a total function. So there's certain values that I can feed it, like arbitrary strings, that'll make that throw an exception. So that's nothing surprising there. So if instead of the ASCII digit 5, I put in the word 5, I didn't get enough sleep last night. Well, maybe the monkeys typed that, I'm not sure. If I run that, that'll actually fully compile in Java. So I've now gone back to not trying to do it as a single file, just to spell out exactly when the error is occurring. That'll happily compile, but when I run it, I'll get the runtime exception and the format exception. That's sort of. But with Groovy, we can decide, oh, do I want to stick with that standard behavior, or do I want to have stricter typing? So Groovy, its type checking is extensible. With most things in Groovy, we try to make it extensible wherever we can. And so you can supply, or the monkeys can supply you with your type checker if you want them to. And once you've got that additional type checker, it actually finds this out at compile time. So it'll complain about this value being wrong. But Groovy actually sort of says, well, we can actually, we've got a language that does dynamic stuff as well. Can we actually do something a bit smarter here? And with just a couple of lines of dynamic programming up here, then in fact it'll actually work, and it'll actually allow us to put in 5. So we sort of have a bit of a map that converts from things and automatically converts them if they're in the map. So it won't work on anything apart from the things that are in that map, and that works. So that's sort of the dynamic side of things. But we can sort of do a bit of extra metaprogramming. So the third line, actually, it just works for longer expressions as well. If I whack in one extra line of metaprogramming, then it can actually support this sort of style of behavior as well. So instead of, it'll work for integer.valueOf, but even if I have anything that looks like an undefined property, undefined local variable of any kind, it'll say, oh yes, that's one of these things. I'll know to call the integer value of that thing, and I happen to know this metaprogram that's going to fix it to turn it into the right thing. Okay, so I also asked ChatGPT how to make this more New Zealand friendly, and it suggested I add these examples and fill in a few more ... So this is where I showed up to the other night. I've got no idea what ChatGPT is talking about, but maybe you guys can explain that to me. I changed the next slide on here. So I said what I was showing the other day was one of many things. One of the things I was showing was phonetic algorithms. So what I'm going to do is add an extra line of code up in my little metaprogram there that does phonetic matching. And so in fact, I'm going to use a metaphone, or double metaphone, happens to be a particular variant of a phonetic library, and it converts any words into their phonetic equivalent, and I'm going to store away the phonetic equivalent of the standard digits. And now if you put in any of these values, that'll magically work. But to tie it back to, sometimes you want stronger typing. if I do these values, apparently Irish, this goes 1, 2, 3, that has a different phonetic representation. So this will fail, and this will fail at compile time because of this phonetic integer checker that I've got here. So it'll handle the Kiwi, the Aussie, it did Welsh and South African and a few other different ones as well, but Irish it bombed out on. And so this is sort of a common pattern if you start utilizing Groovy's full extent of its typing. It lets you go and do weird and wacky dynamic things, but then you lock it down to exactly what you want it to do. And so you actually get stronger than Java typing that can give you this sort of flavor. And this is exactly what we want to do in lots of different scenarios. So sometimes you might have, if you've got 100 lines of code, 2 lines of that are dynamic. You don't want to say, oh, darn, I have to turn off static compilation on that whole method. You say, no, you turn on static compilation, but you have you put in a custom checker that knows about the 2 lines of dynamic stuff and says, yep, let these through the checker, please. And so Groovy's extensible typing sort of allows you to strengthen or weaken compared to Java's typing, and that's exactly what you want in a lot of scenarios. And there are some built-in checkers, some checkers that do regex expressions. So if you've got some regex expressions and you leave off a closing brace, closing round bracket, or you put %D instead of little d, was d date or digit or decimal, what was it? If you get the wrong one at compile time, you'll find that sort of stuff out. Another really powerful thing is extension methods. I haven't really got time to go into them. They just make it classes, whether they be Java classes, third-party library classes, your own classes. It makes them look like they've got additional methods. So I can call collect by values or collect values on a map or an integer array. You'd expect not to find many things. There's a whole swag of things you can call on those things. So Groovy makes it appear as if those things are available on those classes. And especially in Groovy 5, we've done heaps of optimization. This gets back to the people who are using Groovy for data science scenarios. Yes, streams are really nice. We really love them. These are streams, using streams to find maximum and absolute maximum of some arrays. The primitive integer array variants of those max methods are highly optimized. And so they work out much, much faster than firing off a stream and so on. So you can still use streams. You can mix and match between these extension methods depending on what your needs are. AST transforms are another feature. They let the compiler generate boilerplate code for you. And to sort of show you what that looks like, here I've got a book class. It happens to have 3 properties, author's title and publication date. And I'm going to declaratively annotate it with a bunch of interfaces that are linked to AST transforms. There's immutable, sortable, auto-externalizable, and init property. And when I run that through the Groovy compiler, in the background of this slide, which is very faint on this thing, there's 600 lines of Java code, which is the equivalent Java code. Or more importantly these days, it's 2 orders of magnitude less LLM tokens. So if you're firing questions to and from your LLM, it'll cost you 1% of the costs using it if Groovy is the thing that you're sending back and forth compared to Java. So that declarative style is very, very powerful. And if you go and look at frameworks like Grails and so on, which is a web framework that's actually been around for many, many years now, but it's actually most active in its life right now compared to any other time in its history. It's just joined the Apache Software Foundation, and it's just been totally revamped. It makes heavy use of these, as do a whole bunch of other frameworks. I'll show you Micronaut in the way down the set of slides, hopefully, if we don't run out of time. There's a whole bunch of these AST transforms. I won't go into them. You'll see a few more pop up later on, hopefully. Okay, so better OO features. Who's heard the phrase prefer composition or delegation to inheritance? You've heard that? So that's a partial lie, isn't it? It really should say, oh, if you could do inheritance well, you'd prefer it over of a composition, but none of you can. You all suck at it, including me. So don't do it. Do delegation or composition. That's what it really should say. It's very, very subtle. Traits are a way to suck less out a whole range of different scenarios. So if inheritance was your only vehicle for sharing behavior, you'll create deep, monstrous class hierarchies where you break weaker pre, stronger post, so they're not well formed. And that ends up with the mess that we have. If you had multiple inheritance, you'll get the diamond problem, you'll get fragile base class problems. So there's lots of potential issues with using inheritance. But Java supplies us with default methods in interfaces and static methods in interfaces. And that's its sort of hat tip to, oh yeah, inheritance can be useful sometimes. We'll give you a little bit of a path that lets you evolve your APIs. Well, traits say, oh, we'll make a whole swag more cases where inheritance isn't too bad available to you. And that's what traits do. But we follow pretty much what Scala traits do. There's a whole bunch of features. Stackable traits, there's state-based traits, there's all sorts of dynamic traits, things that aren't really available in Java. So I haven't really got time to go into these, but if I've got a standard Java lang string, I can make it as starable, and they'll just add the starify method to the class, and I can call it. This one happens to take Java util array list and adds a timestamp for when it was created, and it adds in some notes to it. So when I'm creating my list, I can go and create some notes on there. And that's just using traits. So it's sort of a more powerful OO notion that we've got that lets you have very lean class hierarchies that are only just bringing in the trait and nothing else. So you tend to have the sort of more fine-grained interface-oriented programming style rather than the huge, horrible mess you can get if you overdo inheritance. So there's some features there. I'll let you look that up yourself. It's fairly well documented, the extra things that Groovy traits can give you. I talked about AST transforms before. I just wanted to show you that same example. So this is records. Go back. This is a Java class and the equivalent record. Groovy's class happens to be a bit shorter, and in fact, Groovy's got other things. I could put canonical and immutable and all sorts of other things, as we saw immutable before, and make this even shorter still. But we also support that record syntax, because that's what Java people would expect. Java's one actually gets converted into AST transforms, and these are all fine-grained AST transforms. And as a user of records, you can go and override any single one of those. And to give you an example of when you might do that, this is a book record, and I'm going to override the toString. I'm going to say, oh, record toString looks a bit different to how a standard Java class string would look. I'll override that. I want this thing to be sortable so that I can have, it's on the next slide. I'll have it compare by author and things like that. I'm going to memorize the display. I want that to be fast. I want that to be cached. I want a builder, so I can call a book constructor for just 3 parameters, and I'll default to today's date as the date. And so when you use it, it sort of looks like this. So you can see things like, oh, yep, here I'm going to use the builder for my record, and I'll supply the title and the author and the genres. And Groovy's also got a thing called Phantom. A Phantom builder for this thing. So in fact, if you didn't supply all 3 of those, all 3 were deemed to be required, it just wouldn't compile. So there's other features that you can sort of tap into with your records, and you're calling some comparator methods there as well, and it's going to show all those. So again, the idea that there's a whole lot more features in Groovy records. You can have them on JDK8 if you want. You can have all of some additional to-map components, copy with, named args, optional args. You can turn these things off if you don't want them. As we saw, you can do all the declarative AST transforms on them as well. So lots of features there. There's better OO features. So I've got some slides here that I normally present that show you Fibonacci and factorial. To cut a long story short, if you do the naive algorithms for Fibonacci and factorial, you'll either get a stack overflow or it'll take a really, really long time. Fibonacci's sort of order to the 2n in terms of its time complexity. If you use memwise or the Taylor recursive features in Groovy, it makes it really trivial to keep your algorithms looking as close to the maths that you'd think in your head of how you define factorial as a mathematician, or how you define Fibonacci as a mathematician, but not hit the performance benefits and not have to recode your thing in an iterative style to get the performance that you want. So I haven't got time to go into the details. Going to quickly show you the REPL, and I hit I long hit the thing and it did a pause or something. This is the new Groovy REPL in Groovy 5. It's got some nice features. Here we're going to grab a Apache Commons collections. I'm going to create a class that extends one of those and give it one of Groovy's operator overloads. I'm going to create a map, print the map out, print out the inverse of the map, which is the tree BD map. That's a bidirectional map. If your keys and your values are both unique, you can flip them around either way. And so we'll flip it around. We can define pipes. We've got some pipes up here that use symbols and pipes up here that use names. So we often get, Groovy's got operator overloading, but it does it in a very limited, controlled way. We often get people saying, oh, can't you define this, give me very generalized operator overloading, or let me use wacky ASCII Unicode symbols for what I want to overload. And we've sort of held back on that because you sort of get ASCII art as your code. But folks who want to do that sort of thing, they can now happily do it inside the Groovy shell. It doesn't, and that all gets expanded out before it hits the Groovy compiler. And so you can do here where, to cut a long story short, here we've got some fruits that we slurped in from a file, and we're going to, what was the hash? Just take the first 3 of those and it prints those out. So you get some very, very nice features there. Gone on to mouse sharing mode again. Hopefully that's gone away. And there's also Java features earlier. So a lot of features that are only in 17, 21, 25. You can go get those on 8 or 11 or whatever when you're using Groovy. So if you want a record, you just declare it exactly as you would in Java. If you're on 8, it'll be an emulated record. So it'll look to the programmer, have all the exact same features as a record, except for it won't do the special record serialization, because that's something that the runtime gives you. And it won't look like a record in the bytecode to someone who's on a 17 or above. So it's otherwise it's sort of an exact emulation. So that's sort of another reason. Okay, so that was just a quick overview, but it's often when you combine these sorts of features together that it's kind of nice. So by combining some of those other features, then we can have code that looks like it's dealing with Roman numbers. It looks like Roman numerals are a native data type, but these are just variable definitions that are undeclared, and my little mini DSL converts them to a class that knows about Roman numerals. If I've got static typing turned on, if I've got values that aren't valid Roman numerals like this, you can't ever have 4 digits in a row, you can only have 3 of the same digit. That'll be detected at compilation time. This looks like matrices are a predefined fundamental type, but it's nothing like that. The output is, of the Groovy console here is extensible, so that's a nice JLaTeX rendered version of the matrix that gets loaded automatically. And this is getting back to Baruch's suggestion, let's do it all in English. We actually have, instead of using Cucumber, we have a lot of people doing business rules and tests, and they use their own natural language. And this can be fully statically typed code that complains if I spell square wrong or whatever, and I don't have that phonetic checker on it, it'll tell me, oh, this shouldn't be this, and whatever it might be. So things that look like very, very close to someone's natural language can actually be code. And a lot of people are using it for that purpose. Okay, so that's all I wanted to in terms of an overview of now I've got 2 other 30-minute talks to do in the next 10 to 15 minutes. So let's see how we go. So again, this is going to be a quick taster. I ran, you won't be able to see the text, the font that's on here. I ran Notebook LLM just on the index page of Groovy's blogs, and it gave me this nice little mind map. And if I expand out the machine learning and data science, it grouped them into categories and had a bunch more. And there was actually a whole bunch more that I weren't on the first page of the index, which is the only one I fed into it. So there are lots of blog posts that talk about a whole range of different machine learning and AI stuff that you can go and have a look at. We're just going to focus on a couple of little pieces of the puzzle. So I'm going to look at classifying iris flowers, and I'm going to look at talking to LLMs. So the same thing that we saw in Philip's talk about chatting with Quarkus, I'm going to show you that with just direct using LangChain for J, and then using Spring AI, and then using Micronaut. And it's just the Hello World chat example. So I'll just show you that, just to show you how easy it is to do that sort of thing. And I want to look at classifying iris flowers because there's a GraalVM version and some other versions of that folks might find interesting. So what is classification? It's just, we've got some data and we just want to group it into classes. And it's, we happen to have a human expert or whatever that knows what correct classes might be, and that'll be part of the training process. We would have tagged stuff that way, and we've trained models or whatever it might be. So what we want is, rather than getting an expert to come along and say, oh yes, I recognize that, and that's a iris setosa variant there. And what we can do is someone who can just measure properties, so that the sepal and the petal. Sepal is actually a leaf, but its nature has made it look nice to bees. So by measuring sepal length, width, and petal lengths and widths, we can go and predict which of these they should be. So this is just a standard data set that's been around for quite some time. So I just thought, oh, everyone's seen that data set, I'll go and use that. I grow these myself. I have about 100 of those pop up in my garden every year. I haven't done the full stats on all of them. In the repos that I said that were around, and in the blog posts, there is this example for many different libraries. So there's many different machine learning libraries. So classification has some standardized algorithms. So you might have heard of Bayes, naive Bayes, or whatever. The logistic regression. That regression is like closest distance sort of measure. So these don't need any machine learning, those algorithms, but there are also a whole range of algorithms that use neural networks of various kinds to do the same sort of classification. And so that's what we'll be focusing on after just one example of the non-machine learning variant. So I normally show Apache Commons Math, or there's some forks of that these days when I'm showing you how to do this classification just on in your one JVM process. But we're only a short drive down the road at the University of Waikato. There is a library and tool called Weka, and it's got a whole bunch of built-in stuff that does classification. And they told me that they're going to do a new version of Weka before the end of the year. We'll see if they manage to get that out. But they've mainly been focusing on a version of that sort of tool called Atoms. So if you're interested in this stuff and you want to look at some local people that are doing work for machine learning algorithms and data science in general, go have a look at Weka and Atoms. This is sort of the code. I don't want to spend any time explaining the code, but we go and create one of these naive Bayes. That's our model. It's a sort of predefined algorithm for calculating these things, and then we can use it and print out. We can define our look at how well it does at mapping our data to expected values. And we see that it gets, the green ones are all right, the yellow ones are all right, the blue ones are all correct. And there's just a few blurry ones in the middle that didn't quite get predicted correctly. So you can go and you don't need any fancy neural networks to do this problem, but the goal is, can I find a neural network layout of some kind that gets me a bit better than what the standard boilerplate algorithm would give you. So let's have a look at some neural network algorithms to solve that exact same problem. So neural networks are just sort of these multi-layered things. If it's got more than one hidden layer, it's deep. So that's what deep learning is all about. And each of these things, it's just got a bunch of inputs that have got different weights, and it does some sort of summation calculation on them. And if it hits some sort of threshold, it triggers that particular side of things. Multiply that by billions, and you get the neural networks that we've got. And the LLMs, that's what's underneath them. So I'm going to use a thing called deep nets, but there's deep Java learning, deep learning for J, and other things have got similar things I could be using for this. I'll use this one because I know it happens to work well with GraalVM, and that's what I'm going to do. All this first slide of code's doing is just loading the data in, so it's not all that interesting to us. And with deep nets, it's got this Fluent API that I can use to build up my neural network. So I build it up and I tell it a little bit about what the different nodes here are going to be. I explain how many, what sort of processing I want to be happening for, what kind of weights do I want, what kind of algorithm is going to be here. And so that's what I'm telling it about these things in here, how all that's fed together. And setting a few parameters, and then I just tell it to go and train the data, and then with the data, I'm going to evaluate my test data. So I split my data into train and test on the previous slide. And when I go and run that, it goes and happily goes away and does its neural network thing, and it pops back 3 seconds later and says, yep, here's what they should be, and only one of them is incorrect. So that's a bit better than what our naive Bayes was doing, right? What I can do next is just recompile that same Groovy code up, but I'll use compile static. Turns out none of the code that was in that script was doing anything dynamic, nothing in there. So I don't need all of Groovy's dynamic capabilities. And if I turn those off, it's much easier to tell GraalVM how to go further with this. And so GraalVM can now do a native image of that. And when I run that, there's a bit of config to go, which I won't go into. 0.1 of a second instead of the 3 seconds, right? So you can, Groovy's, don't go and try to do the dynamic Groovy code. You'll have a lot of work to do to tell every time you're using reflection or any of those things. You've got to go and tell GraalVM, here's what I want you to do. If you see I'm trying to do a random number generator, I don't want you to give me the same random number every time. Don't turn it on for this. I'm going to load a config file. No, I don't want the one that's available at runtime, at compile time. I want the one that's at runtime. So don't go and pre-work out what the config's going to do. If you go and use compile static with Groovy and you're not using any of the dynamic features, then this sort of thing will happily go down to a GraalVM application with a bit of work maybe. Okay, so that was one way you could take that iris classification problem. I want to show you another way, and this is a project that's incubating. It's due to finish yesterday or today. So maybe in the next day or two, it'll actually, well, it won't be till the next board meeting, Apache board meeting, but it's about to leave incubation. This is sort of WAIAX is sort of glue code that sits above other. So I could go and show you this, the iris classification problem in Flink and in Spark and some of and Ignite. They have their own machine learning language libraries built into them. But instead of coding directly to one of those APIs, Weiang tries to offer the promise of write to our APIs. We'll go and do a driver for each of these libraries, and you won't ever need, if you want to switch between Flink and Spark, you just flick 2 dependencies around and it'll do everything else. Now, I'm often skeptical of these sorts of libraries because, well, what if another library that claims to do this comes about. Well, then you've got two, two. Is there going to be a mega one that tries to combine Wayang with whatever the next thing? So I've seen these sorts of libraries before, and I'm always a little bit skeptical. So far, the Wayang stuff looks really nice, so I'm giving it a bit of a go to see what it's like. The other main reason is that it's got, as well as hooks into the standard Java libraries, it's got hooks into some of the Python libraries. So it's to TensorFlow, and there's other libraries that they're working on. So it's got some nice things. So how does it work? Well, it's basically got two levels. It's got a low-level layer that's got map, filter, reduce type things on it. These are sort of operators. There's got some abstractions, but we don't need to go into those. And then it's got another layer, which is an ML for all layer, which comes up with 7 operators. There are actually 7 things that are often parts of many of your classification algorithms, your clustering algorithms, your regression algorithms. Some of the kind of inference things you want to do often feature these things. So they've got lots of research papers over many years. Transform, stage, compute, update, sample, convergent, loop, and they go and define. Oh, you want to do regression? We'll go and define that in terms of all of these things. So just very, very quickly, how does that all work? You go and define a model, and you're doing it in terms of the abstract operators. This is what I want to achieve. And then it goes and maps that down to a combination. So it might pick native Java for some of them, it might pick Spark for other things, and it's got some parameterization information. So it's got operator costs built into it. And so it knows, oh, yes, I've got a cluster available to me, but the cost of moving my megabytes of data to that other node in the cluster is going to cost this much. If I run it locally, it's going to cost me this much. And it goes and makes the estimation of what to do. So this is really powerful and great theory. I'm still a little bit skeptical as to, in a production environment, if I really want this to be the way I'm running everything. I'd like to probably see some of this stuff done pre-compiled rather than at runtime. But the framework's got wonderful ideas. Yep.
Is that hard code?
No, it's not hard code.
So,
did you have a question?
Yeah, does it use CUDA or any other math like you do?
Whatever. I haven't got the late, but there's a driver for any of these things, and yes, if TensorFlow driver is using CUDA, that just automatically happens. You don't see it, and it just happens.
Were you talking money costs though? So like.
Yes, money costs.
All right. So if you've got like a plan or something with AWS or whatever, like.
Yeah, you feed in whatever cost you want. It just minimizes those metrics. So so you can feed in the dollar values. You can feed in some operational metric, latency times, whatever you can measure and know. You feed those in as parameters into its, and it optimizes says right. If I'm going to split this algorithm up onto this big cluster, it's going to cost this much to distribute it versus, I can go and use these different things.
That's fucking excellent.
Yep, so I'm still slightly skeptical, but I think it's something that's worth exploring, so that's why I'm sort of looking at it. Let's have a look at how you'd use it, and we haven't got much time to go into the depths of it, but here we're just defining our different data sets. I'm going to use some built-in operators. So the TensorFlow model has some built-in operators that I can't remember. So DL training operator is a. So I should probably take a step back. So I said it had 7 operators, but then it does sort of other layers. And so there's a deep learning layer, and the deep learning layer has training operators, and this deep learning layer knows nothing about TensorFlow. So I'm defining something here that could go on to any deep learning framework. As it turns out, the only one that they have available that production is the TensorFlow one. Okay, I then go and connect up together my operators, and then I go and say, I create a Wayang context. I give it let me step back. These are all my operators, and I've connected them together. So this whole connection together is my plan. And I'm going to tell it to execute that plan. And in this particular case, I'm going to say pick between TensorFlow or the default Java native implementation, which is non-clustered and not using any CUDA or anything like that. And it's got some predefined operator costs for all the different values there, and it goes and prints those out. And it goes and runs away, and eventually it comes out and it gets all of them correct in this particular case. Okay, so that was TensorFlow, Whirlwind Tour, but that was Wayang, Whirlwind Tour. But the point was things like TensorFlow. This is training models up in TensorFlow and running them, not just inference. That's readily available to you on the JVM. And I did it from Groovy, but you can do it from Java or Scala or Kotlin as well if you want. Let's now talk about chatting to LLMs. So this is pretty much what Peter was showing you with Quarkus, but I'm just going to show you in a few different libraries. And this is all simple code. I'm not trying to give you a tutorial on all these things, not going to give you all the bells and whistles, but I want you to at least walk away knowing, oh, yeah, that would be a really simple thing I want to call AI. That's super simple to do. That's the sort of message I want to cross. So I'm going to use Olama because I know nearly everyone else was using the Open API, but I'm a cheapskate, so I use all the free stuff on my local machine. But security-wise, there's lots of reasons why you'd potentially want to at least have some Olama stuff or some local models on your machine. And when I get to Embabble, there's some really good reasons why you might want to have a mix and match of some. I want some high quality stuff that I'm willing to pay for, and then I've got a bunch of other stuff that I don't really need high quality for. And hey, I'll go with free versions of those. Or I've got data that I'm not going to share with some cloud vendor that I want to run locally. So Olama is a good option for that. So Olama comes with, there's a library dedicated directly to Olama, and that's all it does, Olama for J. And it's just a few lines of code. I'm just going to do a chat request builder. I'm going to tell it what model I want to run. You can feed in whatever model you're happy with. I've got about 4 or 5 of them. This is my travel laptop, and I've downloaded a few models onto it, but not all I haven't got the biggest ones on there. So I'm just going to use that one on this laptop when I run it. And then I just create a message, and it's a user message, and I give it 4 things. This is when I was on vacation a couple of weeks ago in Caloundra, and it came back and suggested 4 things that I should go and see. We can do messages with memory or conversational messages. So if I go and give it the chat history as one of the messages, in addition to the new prompt, which is going to be if I only had half a day and I could only go to 1, which one would you recommend? And then it's going to have that knowledge available to it, and it says, right, okay, all the things that I told you about before, I'm going to recommend you go and see King's Beach. Okay, we can do the same thing with LangChain for J. So Peter was looking at that. In fact, this is what the Micronaut stuff hooks into as well. So all of this is sort of relevant for that. It's pretty much the same idea. There's a Fluent API. Again, I can do all of this as configuration if I want. If I don't want to have it, so this is the entire script when I'm running here. So the imports aren't shown, but everything else you see here for all of these examples is the entire script that I'm running. So there's no stuff that's not shown here. That's the entire script. And so I just give it a prompt and I send it off, and that's all there is to it. Okay, so Spring AI, that's the entire Spring Boot application just there. Plus a couple of things in an application properties file to tell it the model. I could make some of this stuff, I could make explicit in my code if I want, but it's probably not the stuff that I need in my code because I might want to configure that at a different life cycle to when I give new versions of my code out, and so I can have that in the properties file, whichever suits you. Okay, now this is unlike most of the examples that you've seen today. I specifically chose not to put this as a REST service, so this is just straight on the command line. So that's just basically it's using, because I've got the right things in my class path, it's basically just using Spring's dependency injection to get me the right builder, and then I'm just building and chatting. So it's can't get much more straightforward than that. holidays happens to be the name of this script. So if this whole script's called holiday groovy, it'll actually be put into a holiday class. If that bit looks like it's magical. Okay. Spring AI also supports doing sort of structured information. This gets back to the monkeys this morning. When I get to Babel, it's even more relevant. But Spring does a whole bunch of impressive things for you. If you tell it, oh, yep, I want you to do that sort of query, but I want you to feed some sort of domain objects or output objects or whatever you want to call, however you've got it set up. Here I've got two domain objects, an activity, just happens to be strings for me in this example, and then a list of those activities is an itinerary. And now, the only thing that's different here is all this other stuff is the same, but I'm going to tell it, oh, when you get your result back, I want it stashed away in this entity. And it goes, when it's doing the prompt for sending this out, it goes and does reflection on my entity classes and says, yeah, I want you to fill in date and time and location and those sorts of fields. And so when we run that, it comes back and says, yep, here's your activities. And so they're all fleshed into my records now. Okay, the next thing I want to quickly look at, and I haven't got a lot of time, but I've got two more. I want in Babel and Micronaut, so we'll go through them pretty quick. So bear with me. Again, this is the entire Babel script at this point, but yes, because this is just text generation. So it's just a Spring Boot application. The fact that I've got in Babel on my class path, and it's got an operation context bean inside it, means that I'll get that as a bean and I can call its AI method, just use a default LLM, and I showed you an application properties file, and Babel's got one of those as well, and you can tell it what your default LLM is in that application properties file. So it's going to use the default one, but in Babel it lets you do things like, oh, use the cheapest one, use the whatever one, and it's got some conventions about you can define your own, and it'll generate the right methods for you. And then just generate text. So this is just text, so there's nothing exciting there. It'll be the same output as we saw before. But we can do the same thing with structure. So the exact same itinerary record, if I mention that, and instead of doing generate text, generate text, I use create object, and I feed it the record class that I want to feed into. This now comes back in those classes, and itinerary just happens to be the name of the list of itinerary things. So I'm going to print those out, and they pop out. So that's the same thing we saw earlier when I was doing the LangChain Spring AI stuff, and that prints out. But the reason you go and use Babel is not related to just that capability. So getting back to the monkeys this morning, when we're using this stuff, we're trying to gain more confidence that we're using things. And Rod Johnson's take on all of this is, I want to add types everywhere. And so when I go and speak to LLMs, I'm going to give it lots of very specific prompts, but only ask for a small piece of the puzzle to be solved at any time. And that's trying to minimize my hallucinations. Because you all heard of Chinese whispers? You know what that one was? So if I whispered something on this end of the room and it went, and everyone whispered to the person next to them, by the time I got to over here, he'd say, oh, you said this. And I'd say, that's nothing like what I started with. And that's what's happening with these hallucinations. So they get worse and worse and worse if you do multiple layers of this stuff. You just get unrecognizable stuff. So his idea is, well, I want very small defined steps. I'm going to add my typing structure everywhere, and I'm going to want to go and mix and match different LLMs for different parts of the equation. So sometimes I need really high quality, sometimes I need whatever, and I want an engine that goes and works out the right way to call all the right LLMs in this environment. And he calls this sort of autonomous agents. So I'm going to add some extra domain objects, alternatives, rated alternatives, and then I'm going to use autonomous agents. So now I'm declaring some additional agents And agents have got actions which take in one or more of my domain objects and return one or more of my domain objects. So rated alternative. So this one here is taking in some alternatives and then out pop some rated ones, and so forth. And this LLMs here, I'm going to generate 5 sets of the things we saw before. Remember how we had records of itineraries coming out? We're going to have 5 sets of those. Then we're going to rate them, and then we're going to pick the best one. And I'm going to use a different model to do the rating as to do the generation, because if there's an hallucination there, I'm hoping the rating process will get rid of some of those that are absurd ones or whatever. If I'm using a different model, maybe it'll work, maybe not, but that's what we're trying to do. And we've got just a couple of more actions. This one's a specially marked one, achieves goal. And if you've got something marked as it'll when I go and ask it to choose and run agent here, it goes and looks for what you're trying to achieve, and it goes and tries to find the best itinerary, and it goes and picks. It has a gaming model inside there, which sort of gaming engines work out what the next path of one of the monster robots in your game what they might do next. And it's got one of those to go and work out what should it do next in terms of which LLM does it need to get the next set of domain objects. It's sort of like the wiring. Like I need to go wire up these other things. I need to answer the goal question. I need a bunch of data types. What other actions will give me the things that I need to answer those questions? And then again, this is my whole Spring Boot app here. I go and tell it to go and choose and run the agent. So it goes off and it goes and tries to work out the right way to piece together all of the different things here. And in this slide here, I've got hard-coded LLMs, but you can configure all of that as well. You can have with rating LLM, with rating LLM down here, and with generation LLM, and you can configure all that in a properties file and so forth. And it comes out and says, here's the best rating, and it's got a rating of 80%. And the final example is all the same thing again, but using Micronaut. So Micronaut's that ahead of time idea that Rob was speaking about. Micronaut's a framework that does Java, Kotlin, and Groovy, and it does the ahead of time stuff. It does for your dependency injection, for configuration, for validation, for some of your data queries, a whole bunch of stuff. It goes and tries to do as much of that as it can ahead of time. So here we are using it with Groovy. It's got an experimental AI module, so I'll go and use that. I can configure I can hard code this in my assistants that we're going to look on the next slide. I can put it in configuration, but I'm just going to happen to make a model that's implements the chat model interface, and that's what Micronaut is going to be looking for. So I'll go and feed in some values there. Then I go and I can declare a holiday assistant. So this is just the text-based one. I'm also going to want to, so on the same slide, I'm going to do a second assistant, if you like. This one here, I'm going to have strongly typed values as the return type here. So I'm going to use my itinerary. And unlike Spring AI, which is going to go and use a bit of reflection and try to use a smart prompt, we usually have to be a little bit more specific when we're using the LangChain for J stuff. And that's what this is here. Right, then it's often a convention in Micronaut apps to have an app runner. Often it'll be a REST application, but I'm just doing a command line one, so it's a pretty boring app runner, and it's just injecting the holiday assistant here. And that's what this first line here is. So this would, if I blocked out these 4 lines, that's what a normal Micronaut app would look like. But I'm just showing that you can go and just use the normal bean injection stuff and get the holiday bot bean as well as the holiday assistant bean and get the structured return type. And so when you run that, it tells you, first you get the text-based one of things this is now Auckland, what I should go look at. And then we get the structured one as well. And that's it. Okay, just on time. Any questions, or otherwise I think we'll run into the next speaker slot, so I don't want to do that. We can I can take them offline. I'll be around the rest of the day if anyone's got questions. No quick questions? Okay, leave it there. Thank you.
Thank you for the very interesting session, Paul. So we'll have the next session at 4:15. So now there is some more coffee and snacks served here. So get some break.
Yeah, I think
You're not about
Sora, the creator of well, they're doing the
deep nets.
Yeah.
I've don't know him well, but I've certainly chatted to him online. I might have actually met him, but certainly chatted to him quite a bit online about various stuff.
Yeah, he's been working it for a while, talking about it, and now it's this time. So now he can speak at conferences.
Yeah.
Well, so he wasn't that one.
I wish he was. So all the community edition, and they've made all these huge improvements, but not in the community edition.
No. So we talked with him at JCrit this year, and he was very interested in how can I create a business model around an open source project.
Okay.
And Warwick was there as well. And we were because you can compete on features, and you can have a community open source version, and then you can have a commercial version with more features. That's one model. That's probably what it's doing.
Kind of what it's doing, but it's drifting more and more and more that way, which I'm happy for that model, but don't drift too far.
So what he also can do is provide a full features open source and get more contributions maybe, and then compete on support.
Yeah, training support.
Training.
Yeah. It's tricky balance. Yep.
He went to South Africa and then he was in. And then his kids came and grabbed him back, and he had another family. Family, yes. Great grandfather.
I want to interrupt you before you talk. Continue. Just a quick question.
Yeah.
You're going to be around for the yes. I just want to. I'm going to ask you, pick your brains whether you think Atlassian would support a conference like this in Australia in some way.
I would very much hope so, but I'm not.
Oh, yeah, I know.
Let's talk about
That's
it. If it does, I want to be involved.
One more t-shirt. All right, I think we can start in 1 minute. Okay, so I'd like to welcome on stage Tom from Atlassian. He'll give a very interesting talk on how we can sell maintainability. So, Tom, you have the word.
Yeah, thank you very much. Am I audible like this? To the back? No, I'd rather not. Like, if you can hear me, if not, I can take one. Anyway. Sorry?
You just can't understand the Australian accent.
My Australian accent. That's a surprise. It's the first time someone said I have an Australian accent.
You have a Dutch accent.
Well, yeah, I'm from Germany, so that's close. So, yeah. So I've been in Australia for the last 6 years, so that might have slipped into my accent. But
G'day, mate.
yeah, I understand that. I rarely say that. I'm not quite incorporated into. I'm not a citizen yet. I haven't done the citizenship test yet. So anyway, yeah. So this talk is about maintainability, and as a disclaimer. So it's not about AI. So we've talked a lot about AI, but I've used AI-generated images. And also, this is basically like if the vision that Baruch painted this morning, like we don't have to do any code anymore, and every code is throwaway, and we just rewrite it or let the AI rewrite it. This kind of is obsolete, but I don't think we're quite there yet. So maintainable code is, or maintainable software in general, is important as long as we are still involved in writing the code. If AI does that for us, well, yeah, but let's talk about it in a couple of years, that again. All right, what are we talking about? First, I want to give my opinion about what maintainability is and maybe test yours as well. Hopefully we align. Second, why should we care about maintainability? I kind of said already, we shouldn't anymore if AI does the work, but we're not there yet. And third, how do we sell maintainability? And by selling maintainability, I mean, how can we argue for building maintainable code? you've probably all been in discussions somewhere. Why aren't we doing this shortcut? Because it costs less money, it's faster, it brings us results. So sometimes we have to argue for maintainable code. All right, let's start with maintainability, what it is. Would you say this is maintainable? Why not? Highly coupled? So it doesn't really matter what the squares are, like classes or components or whatever. But yeah, like there's a lot of arrows going back and forth, dependencies. Yeah, I said it already. There are even circular dependencies in there. So you might have seen it or might not have seen it because like you don't see the tree in the wood or whatever. I don't know what the English idiom is for that. So no, we don't want to have circular dependencies. I mean, even non-circular dependencies create coupling. Circular dependencies, well, you can just as well put everything into one class. So it gives us tight coupling. Is this maintainable? So compared to this, sorry?
It's a spectrum.
Yeah, it's a spectrum. So the difference is, I hope at least, the first one had circular dependencies, the second one doesn't have circular dependencies anymore. So it's a bit more maintainable. Like you said, it's a spectrum. We don't have any circular dependencies anymore. It's a bit less coupled, but it's probably still, it doesn't feel like it would be great, right? And this,
A little bit more.
yeah, but it's still better. Without more context, we can't say it's perfect, but it's best. It's definitely the best of the three from the perspective of maintainability. So we want to have no circular dependencies, and we want to have few dependencies. We probably can't live with zero dependencies. That would be the best, or not. If you throw everything into one class, you also have zero dependencies, but that's not really maintainable. So we want to have few dependencies, no circular dependencies. We can easier read the code, reason about it, and everything's less coupled. Is this code maintainable? So this is just a code I copied from, I don't know, it's one class. It didn't fit onto one thing, so I split it into three. You don't really need to read the code. Is it like from your subjective view of this, do you think this is maintainable?
Depends on maintaining it.
Let's assume you maintain it.
No, it's not.
Yeah. All right, so probably not. Like it's the thing I mentioned before. We can just shove everything into one class. We don't have any dependencies anymore, but we have lots of responsibilities in this potentially mess of code. So we want not only to have few dependencies, we want to have few responsibilities. Ideally, you've probably heard of the single responsibility principle. Ideally, we want to have a single responsibility or a single reason to change for each unit that we're looking at. Which one is more maintainable, the one on the left or the one on the right?
Right.
I've heard right a couple times. I would agree. The left is the mess we saw earlier with the circular dependencies. The right has more dependencies, which kind of, like I said earlier, we want to have fewer dependencies. This has more dependencies, but they're pointing in the right direction. We have smaller responsibilities for each of the components, so it's still more maintainable than the thing on the left. So to sum it up, few dependencies in the right direction. We don't want circular things. Few responsibilities per unit or component. Like altogether, our system will have probably many, we can't get around that, we'll have many responsibilities and many dependencies. But we want to be able to look at each of the units or components, whatever that is in our case, in isolation, and work on them and change them without having to change all the rest. So maintainability is all about dependencies. It probably doesn't surprise you. Or is anyone surprised that dependencies are, so basically from my perspective, maintainability is managing dependencies. Yes?
Are there any, if you do have high coupling and circular dependencies, what ways are there to break those dependencies?
I have some slides on that later. Like the question was, how do we break up dependencies? I'm not going very deep in that though. Like it's, that's probably a totally separate talk, separate topic to talk about.
Language or deployment model, there are multiple ways.
Yeah. Yeah, there's many ways. Let's talk about after again. Maybe let's see what the slides offer. All right. So, why do we as engineers care about maintainability?
3 a.m.
3 a.m. means you have to wake up at 3 a.m. and make decisions.
Maintainable, we generally don't have to wake up at 3 a.m.
Ah, okay. Yeah. All right. Or if we do, we can make quick decisions because we understand the code. Okay, understood. So yeah, we don't want to wake up at 3 a.m. because someone made a mess because they didn't understand the code. That's very selfish reason. But I totally agree. Any other reasons why we care about maintainability? Yes?
Fast.
The past?
Fast. Productivity. If you think maintainable code is inefficient, try unmaintainable code.
Yeah. All right. So productivity.
Extendability. You can extend functionality.
Extensibility, changeability. Yeah. All that. Okay. So I've been pretty similarly selfish as you. I want to have fun when I'm working on the code, and working on the code is more fun if I know if I can read it, if I can work with it, and if I can change it. So changeability and maintainability are kind of synonyms, but we'll get to that. So selfishly, I want to have fun working on the code, and I don't want to wake up at 3 a.m. because someone made a mess because the code was unmaintainable. But that's our view on this. And not everyone cares about what we want, right? So why should others care about maintainability?
Compliance, security, ISO standards.
Yeah. What was that on purpose? The middle finger on ISO standards? Someone's.
I mean, the turnover of people. So if the developer joins to all, people will go out of the company and find new engineers.
Let's talk about some of the things I found. This is totally an incomplete list, so probably every one of you has something to add. But this is like what my thinking about this was. So I kind of created these diagrams like this. Maintainability influences developer joy. We already established that. And the other, I would say the other way around is true also. Like developer joy, if we have fun, if we can work with the code, it also influences maintainability, because if we are proud of what we're doing, we make sure that the code stays maintainable. And you already mentioned it, the productivity, if the code is maintainable and we have fun working on it, you could also probably draw that line directly from here to there. But definitely we are more productive in a maintainable code base. And that's the reason others should care about it, because they want us to be productive. That's the reason why they tell us to use AI more, so we can be more productive. And then we have this vicious cycle. AI creates not so maintainable code, and yeah, well, anyway, not going into that. I promise this is not talk about AI. Yeah, and the other way around, again, I would say is true as well. If we are productive, we enjoy the work more, right? That's also true, I would say. And then you mentioned it also, changeability, extensibility, maintainable code base, better extensible, we can change things. That's a factor that is very, or should be very important to product managers or business people, product people. They want to change they come every week with a new idea and tell us, hey, why don't you build this? And we say, yeah, if it was maintainable, we could do it in a week, but yeah, it's not working like that usually. Yeah, and then some other things. And you mentioned it, developer retention. I have that on the list as well. So yeah, if we're happy with our work, we stay longer. Although arguably, not every company is interested in us staying longer these days. But yeah, let's hope that it's not true for us at least. I also added decision making because if you can understand the code, it's easily readable. We can make decisions better. Like, do we go left, or do we make this? Do we make the change like this, or do we make the change like that? It's easier if the code is maintainable. And probably a bunch of other things that we can come up with. So maintainability is important. So far, any other ideas? What?
I'm more keen to understand why we need to convince others to write quality code, maintainable code, and stuff. Shouldn't it be no-brainer for the whole of my career? I see people continue convincing others to do the good things.
Yeah, I totally agree. So just to repeat that, if not everybody heard it, why do we need to convince people that maintainable code or that maintainability is important? You can also use these arguments to other developers. Like we let ourselves slip, like because of deadlines and everything. That's probably the most common case, right? There's a deadline looming and we have to make things right. Or it might be more economical to take the shortcut and get the product to market fit quickly in a startup, things like that. So there are valid reasons to take shortcuts. There are also many reasons that I would not consider valid to take shortcuts. That's we put the pressure on ourselves, which we shouldn't. So these are arguments. If you have to argue with someone that is not, or it can be a developer or not a developer, if you need to convince them, you can use some of these arguments. Or you can convince yourself. That's also helpful, right? But yeah, what I learned that helps with, like when you're talking, at least to other people, like when you're trying to convince other people why maintainability is important, it helps to use analogies, especially if you're talking to non-technical people, because the analogies just make it easier for them to understand it. And the first thing that came to my mind when I was thinking about it is team building. Who's been on one of these mandatory team building exercises with the team, and you do some, I don't know, you're being put in a room, 5 people, you barely know them, and you need to solve some trust fall. But I'm thinking about you get a task and you have to solve this task together. What usually happens like in the first 10 minutes or so?
Nobody cares about it.
Yeah, nobody cares. Why does nobody care?
Because it's mandatory.
Okay, let's say it's not mandatory.
Why are they there?
Sorry?
If it's not mandatory.
Why are they there? Yeah, okay. All right. This analogy doesn't work on you guys. So what usually happens is everybody, or what in my experience happened, everybody talks over everyone else. And then nobody knows, like, what am I supposed to do? Like, we're 5 people, why isn't everyone else doing work? Or why? So nobody feels responsible. So responsibilities are unclear. And because of that, we have like dependencies, like everybody depends on everyone else to get started, right? So it's
someone takes the leadership and the other stuff.
Exactly. And then someone takes the leadership and this person then brings order into the chaos and like clarifies responsibilities. And that's exactly you remember the diagrams from the start, the first diagram with the chaotic dependencies. That's us in this exercise in the first 10 minutes. And the one later with the fewer dependencies and clearer responsibilities is the one when someone actually picked up and so that's an interesting analogy that non-technical people can probably relate to because everybody's done these team buildings. Yeah, similar, you probably know that. Who's heard about broken windows? Yeah, many of you. So the broken windows theorem, or theory is if one window in a facade is broken, it doesn't take long until the second window gets broken as well, and then the third and fourth and so on. Because there was like a study in the late 70s or 80s about this in New York and California, I think. They did this with a car. So they parked a car somewhere in a good neighborhood and in a bad neighborhood, and nothing happened for a week. And then they smashed the window of this car, and then within a day the car was completely vandalized. So it seems like the human psychology tells us if something is broken already, we don't have an incentive to fix it, or it's easy for us to make it even more broken. So that's what the broken windows theorem means. And that's something that we can all relate, like as developers, we can relate to that because we're working on code, especially if the code is written by someone else, and we inherited it, and it's like bad code and we don't really want to work with it. We don't fix windows. We probably add more broken windows to the code because we don't feel like, yeah, it's this broken windows psychology. If the broken windows analogy doesn't work, we can do the same with a messy room. Everybody should know that. If a room looks like this and you get up in the morning or you get into bed in the evening, where do you put your dirty socks? On the floor, right? So that's everybody should be across this. Everybody should understand this. And then again, we can say, okay, if we can take this messy room and put it into code, and it's the same thing. People hopefully understand that. And then lastly, the bridge analogy. What happens to a bridge after, I don't know, 50 years or whatever? It crumbles and then eventually it collapses. There's like a news report every, I don't know, 2 times a year or something like that, where some bridge in some part of the world collapses. If we're lucky, no people get harmed. Usually people do get harmed. But yeah, bridges collapse eventually. And the same happens to software. It's just much, much slower. And it's not as spectacular. And hopefully, and usually people don't die during that, hopefully. But still, we can use that as an analogy. If we don't maintain code, if we don't keep it maintainable, eventually it won't work anymore. But this is a bit harder because it will still work. It will just be harder to work on. This is a bit hard to see, but this is a map of Germany, and it shows the status of railroad bridges. And every colored dot here is a railroad bridge that is in need of maintenance. Let's call it that. And first of all, I'm pretty impressed by something like this. They have the data. They know which bridge is in which status. So they know this bridge is very broken, and this bridge is only a bit broken, and this bridge is like almost collapsing. I wish we had that in software, because that would make decisions much easier. So that would be pretty cool. We could even use that as an argument, say, hey, we know nothing about, we have this big monolith. We don't know the bridges in this monolith that are almost collapsing. Why don't we invest some time to investigate this and create a map like that? The colors mean something. So the orange means extensive damage can be repaired. The red means can't be repaired anymore, needs to be rebuilt. And I wish we had this information in software, because sometimes rebuilding is a valid option.
I've used bugs as a proxy for areas which are like really flaky.
Sorry, again?
I said I've used bug volumes as a proxy for areas which are really flaky.
Yeah.
But it's not quite the same as saying, yeah.
Yeah, so if not everybody heard, he used bugs, like the number of bugs in certain, yeah.
Is a good sensor.
Any metric that we can use like this is helpful to make decisions, informed decisions about the software. This part of this, and like a software doesn't have to be rebuilt in one thing. Like we don't need to throw away everything and rebuild it. We can usually, if the dependencies aren't completely messed up, pick one thing and then like apply a strangler pattern or something, like pick one thing at a time. But we need data like this to do that.
And then static analysis gives you a lot in terms of psychological complexity and smells.
Yeah, but that means we need to collect that data somehow, and that's usually we don't have it. So we need to invest some effort to create that data. Oh, I have another analogy, and this is where you can see that these images have been generated by AI, because that's how AI thinks about the human evolution. I just said human evolution. So, well, anyway. Yeah, so this goes back to extensibility, what you mentioned earlier. A software that is maintainable, that is changeable, can evolve into the system that it needs to be. And that is an attractive argument for even product people to understand, okay, maybe we need to invest some time to make it maintainable. Yeah, monkeys. Yeah, and in the end, you probably can't see this. There's a line here. In the end, it all goes back to, we can all argue back to cost of change over time, right? And that's the killer argument for anyone in working in software. If the cost of change goes up, it means eventually, yeah, usually it goes like this already. Yeah, sorry.
But it depends on the team, because software developers used to get the non-maintainable code. They justify it, and they just add more story points and say, okay, yeah, the cost of maintenance get up, but your features are now more complex. You see, now it's 11 story points. And features last year were 7 story points. Yeah. So you just request more.
You can get out of anything. Like if you're, but I'm assuming we are like professionals, and like we want to and we don't just change the story point metric and it like inflates or something like that, right?
But how to fight your other teammates to not do it?
Well, that's like how. Well, hopefully you don't have to fight them, but maybe just I'm trying to just like be an example. I'm not always successful, but like just a couple weeks ago, I reviewed a pull request and approved it, and I shouldn't have. And now I'm rewriting the code, but I'm doing that. Well, not rewriting, but refactoring it a bit. But I'm doing that together with the developer, so not that it doesn't look like, hey, by the way, I just rewrote all your code. Like, but I'm just trying to do that together with them.
But see the trap in this graph. It's like everybody will fall for it because initially the cost is low.
Yeah.
For the unmaintainable.
We're gonna touch that a bit more in a couple slides. That's.
It's usually pretty late when you come to the point.
Yes, exactly.
And this goes back again to the thing, like we need the data, right? Could you even create that graph for the software you're currently working on?
From the beginning.
Yeah, well, maybe even just from today on, but yeah. But you probably weren't involved when this happened in most cases.
You just plan to leave the project before the 5th dot.
Yeah, make an exit. That's what you call it, right?
But it wasn't alive and he hit bugs.
All right, so now let's talk about how do we keep software maintainable. Now that we know what maintainable is, now how to argue for it. Let's say we got the budget, we can make it maintainable. This obviously only works when we're there at the start, and even then it only works in limited ways, because there are always things like we always say we start clean and then things get a bit messy, and especially when you work in a team with more than one person, or from my perspective, if I'm working in a team with more than me, it gets messy. Like if I work by myself, of course the code is perfect every time. But no, but seriously, working in a team, things get messy. And then usually things come in like pressure. We make ourselves pressure. Maybe we shouldn't. Pressure comes from management, from product, whatever. So, but anyway, if we can do it, perfect. Start clean. Something like thinking about an architecture. This is just an example. If you've heard of clean architecture, there are others out there. It doesn't need to be this one, but like it helps to have stereotypes. In this case, we have adapters and use cases and entities and ports. It helps to have these stereotypes so we can talk in these stereotypes, and then if we do this from the start, it probably still gets messy, but less messy, hopefully. Then an important thing that I can't stress enough is recording decisions. You've probably heard of architecture decision records. It doesn't need to be like scientific, but whenever we make a decision, or it has to be a conscious decision, because if it's not conscious, we can't really do anything about it. We can't react to it. But whenever you make a conscious decision that impacts the maintainability of our code, for example, we take the shortcut because we have to hit the deadline, whatever, document it, and then review it after half a year or whenever. I'm talking a bit about reviewing decisions.
I'd say even create the ticket. Like sometimes if it's like within a realistic period, and say create the Jira sheet or fix it later. Like make it prioritize. There's one of the beginning. Yeah.
So create the ticket.
Feature flags always. I'm like
create the ticket, put it in the backlog, and what happens to the ticket then?
It's lost. I
think that comes back to prioritization.
Yeah. So, sorry, what did you say?
Keep it in documentation. Keep your decision record either with the project you can mark down or.
We have our APIs
I mean,
in Confluence, but have the tickets.
We obviously have it in Confluence, but I can't force you to do the same. Actually, I like Confluence for these kinds of documents better because you can comment on it and you can share it, and you can. But I like it's not with the code, so
I'm suggesting that once you record the decision, cover yourself later from explaining why you have a mess. Remind you that
part of this is like saving your ass. Yes, I mean it's not the main. I'm hoping that nobody wants to fire you because you made this decision half a year ago and it turned out wrong. I mean it can also, like, if you're working in an environment like that, I don't think there's anything you can do. But it's part of cover your ass. I'm getting to that. And
life can be complicated, and typically you're going, what did we decide 6 months ago? You go back there and then you go, we made that decision, and that's why.
Which is what I was hoping for.
Right.
Okay, you need to have iterative cycles for reviewing your decisions, because otherwise they're just stuck in purpose decisions.
Yeah, like ADR 001, we are starting to document our decisions. Like that's the first decision you make, and then often it's the last one. But like
it's also a place to have that conversation, because our APIs have the review, the narrative. You can go back and you can say, we actually asked a question about this.
Yeah.
For those deferred ones, there was this was project Revoli, I don't know if it's still maintained, but it was like an annotation processor that you could associate with the ADR with an expiry time. That the only purpose is to fail the build at that time.
Yeah.
We have our
textile and coat rules with that functionally baked into.
Right.
So it's just a comment in that code.
Yeah.
Yeah, I'm of two minds about things that fail the build for reasons that are not like compile errors or test errors.
Well,
Just
if you do a commit and a pull request to say, we've updated this ADR.
yeah, I totally understand the reasoning, and I agree with that. But we had a case where there were certain scans, like a security scan dependency, like there was a CVE that was found in a library, and the security scan failed our build, and it failed our deployment pipeline. So far, so good. We don't want to deploy security risks, security like CVEs into production. But the problem is it was already in production anyway, because it was just identified at this point, and it was already in production in this dependency. So we failed the build for no reason, and we had like to. But this is just a story. Yeah, it's like if your team is good with that, like fail the build when the ADR is or the decision record needs to be reviewed. Yeah, and why review decision? Why is reviewing decisions so important? Because only like with the hindsight you can identify, like after 3 months or 6 months or whatever, was this the right decision, and then document why was this the right decision or not, and then you can also you know the impact of that decision, and that will inform future decisions. If you don't have, and also it shares like knowledge across the team. If you do that in the team, everybody will know why they did that decision, maybe even before people joined, and they will get the context. And then we come back to numbers and metrics. Track the cost of change. So we saw the cost of change curve earlier. I know it's not easy, but like if you're building, I mean, it's easy for some application. If you build a form-based application, you can take something like add a new form, add a new page, something like a standard feature, identify a standard feature, and then every 6 months estimate how long it would take you. And then you can put that on the curve, or maybe even once a month or something like that. This is like hard to do. Like I wouldn't know actually for the software I'm currently working on, I wouldn't know what to use as a standard feature. Like you have to identify something like that in the team. So it's not easy. But if you have something like that, you can say, hey, this is the cost of change over the last year, and it has gone up. This is the best argument you can have to say, okay, we probably need to take some time to fix some things, identify some things to fix, and make that go down.
I measured, just to throw out there, there's the cost of change is the direct cost, but there's also like the other things that happen that slow you down. So I measured waste. And I have people who like it's like a place where people do pitch, but essentially it's a Slack room where people can come in and say, I've lost 2 hours because build pipeline was shit, or because a given test was really hard to change, and then I can add that up and then target areas where I can't directly correlate for a given feature.
Yeah, perfect. Like this isn't directly like a Slack channel for like complaining. Isn't directly.
No, it's a workflow. It's a form. Yeah.
Yeah. Oh, it's a form. Yeah, even better. So you have structured information. But even just collecting it in some way is better than not collecting it at all. Like this chart that you can build doesn't have to be like scientific, right?
But it's now interesting because you say so. We are taking the shortcuts because we're pressured, and I guess everyone's pressured. Product people, the project people, the technical people, everyone's pressured to deliver. And then how do you find time to measure your cost of change, to document your intentional decisions? If we had that time, probably we could never have taken shortcuts.
Yeah. Well, you can. That's a good point. In my experience, it's just like you need to talk with the team, talk with your manager, make that time. Nothing.
Probably make the time for maintaining the code.
Yeah, ideally you don't need. Yeah, but even so, like at some level, at some management level, a couple levels above you, you might even if your direct team is all okay and you get the time, eventually in the bigger context, it might be helpful to have some kind of metric for the skip level management, just to say, hey, this is our cost of change. It went
To justify it.
to justify it, yes. So usually this, like if you, this is how I imagine if you would create this cost of change graph over time, right? So earlier I had this is still a curve and it's probably not steep enough. Like you said, it should probably be steeper. But usually what happens is, like at some points, someone gets fed up with the state of things and cleans it up, right? Some manager, like if you're working on a multi-team thing, identifies, hey, okay, we now invest, I don't know, some time into cleaning things up. So we have these heroic efforts to improve maintainability. What I find interesting is that this coincides with the performance review cycle. I don't know if that's on purpose or not, but that's what I see. So people have their performance review looming, so that's another pressure, right? But you can use that pressure positively and clean things up, right? And then claim it in your performance review and then get promoted.
I'm a director and I tell people to Jeff DI it while they're working. Like sometimes a story will take longer. Yeah.
This can fire back, obviously, though, because then people take it as an incentive to first build shit code, let it blow up, and then the next performance cycle they say, oh, I've cleaned this up and now I get promoted because of
people are actually taking it as a good, make it unmaintainable for job security reasons, and tell the management, okay, it will take 2 weeks to do something.
You mean to make it unmaintainable for security, yeah, for job security reasons, yeah. Don't do that. I think I'm not doing that. I hope you're not either. So, yeah, you can see this. There is this line here again that says, okay, if we had made a decision at this point, this inflection point, a good decision, the cost of change would have stayed relatively flat. So we could be here today if we had made this decision. But these are the decisions that we have actually made over time. They helped a bit, but only for a short while. When this decision would have made everything better. And this is why I'm saying document and then review your decisions, because at this point, you could review the decision and hopefully identify the impact. This is also not straightforward, right? You can't just go back and identify, hey, say this decision has made this impact, but hopefully there is something that you can say and identify. Because you've made this decision, this has stayed low, and imagine what this would give in your performance review, right? It's the harder way though. This is the easy way to getting promoted. This is the harder way to getting promoted.
The easy way to get fired.
I'd communicate it as interest, right? Lord Cunningham's whole thing was technical debt, you pay interest on it, right? If you say that and suddenly the people who are non-technical are like, interest on money.
Mm. Yeah, interest is a good analogy as well. I should include that.
So just on the last one, the thought I've got is that, or my theory, is that actually the cost does go up. And that's because of, as you add features, there's feature interaction. So when you add the 100th feature, it's actually more expensive than the 50th.
Yeah.
So it does naturally go up. And I think I've missed is that the business generally doesn't understand it. They think the cost is linear.
Yeah.
And so probably the thing that I'm thinking of is you've got to push back harder and harder on feature 100, feature 101, etc.
Yeah, I totally agree with you. So this is actually, you can see it, this is moving upward very slowly. So it's not completely flat, and I totally agree. It will never be completely flat. That's unavoidable complexity that you're adding.
My theory is that at some point maybe also goes down because when you have a fully functional platform, a very fast platform, you easily add some of the features because they have internal frameworks and stuff that you can easily add in the beginning. Or in the middle of the project, you make something like that exactly. That's my theory. You have fully functional product with all the abstractions, even not maintainable some of them. internal frameworks and stuff, and you can add some features that wouldn't be easily added 2 years back.
Kind of think of the first part as plumbing cost.
Yeah.
The cost of plumbing and then the cost of features.
Yeah, something like that.
And there's platforming capability, right? There's a point at which you need to factor out new capabilities into their own single responsibility set, microservices or whatever. And then you start building platform capabilities, but then that reaches its own maximum as well.
Yeah. Was it?
There's a similar point to pushing back on features, it's also pushing back onto decision makers about what are the values of the features that they do have as well. So quite often, everything's a punt, right?
Yeah.
Everything's a punt.
And I'm hoping that in the discussion like this, like some of these analogies might help, like adding new features is like adding something to the bridge, and then eventually, I don't know, this analogy only goes so far, but like hopefully something like this.
How do you deal with this Atlassian? Because I'm going off on one, but fighting for we should kill this feature because it's used by one customer, and products like, but they're worth a lot of money.
Yeah, well, I mean, we just discontinued the server products and moved it, like tell everyone, hey, the server product is discontinued, you have to move to cloud. So there are decisions like that being made on a very high level. On a lower level, it's between you and your direct or skip level manager that you need to have that understanding. In my current role, it works quite well, but it's like, depends on the team you're in, the team you're working with, the whole team taking ownership of the maintainability and the manager understanding that it's important. And then even the skip level manager and skip level manager giving the time we need to go slower to be faster in the end.
It's a culture thing, I guess.
It's a culture thing, but yeah, that's like, culture is, it's like different in each part of the org. You need to fight for it a bit.
But you have high-paying customers that exited from your service when you discontinued the server.
I'm pretty sure that I don't know the details, but I'm pretty sure there are some customers that left because of those decisions. Yeah. That's
that goes back to the discussion of architecture, like, you know, when Atlassian in the API, like the REST API for Jira, stopping me from, because I was complaining that it didn't want to spread HTML. That opened up architecture that we could have a stable API for all of that. Then they brought in plugins, like Confluence plugins installed. Once you've got that architecture of having things extensible, they're not necessarily called the core products, so as you say, like when they move to the cloud, this one customer might have their own plugin set specifically for them.
Yeah, and those plugins might not work on cloud anymore.
Yeah, so that would need to be adapted.
Yeah.
But, yeah.
It's back to dependencies, right?
Yeah.
So everything goes back to dependencies.
One of the things to discover about the question around pushing back on features, I found actually those biggest. To push back to the stakeholder and ask them, how much money will you make with this feature? In comparison to other features and complexity of those features. I mean, explain to someone it's going to cost me X.
Yeah.
And how much money are you going to make?
That's a good point actually. Like, let's push back and say how much money does this feature bring us when we build it? I can tell you, estimate you how much money it will cost to build it. You tell me how much money it brings in. And if that numbers don't add up, then let's not do it. Yeah, that's very good.
But if you're in the R&D where you are actually making things that you don't know how much money they will make, you're exploring, you're making research, or you're making demos for new clients.
But I think the build phase is different to the maintaining phase. Once you build something and you already have a product, adding features to that, you have to come with an argument, why should I add this feature over that feature, especially when you have a small team and a lot of features that need to add.
Yeah.
But even if they don't know how much money it would bring, they can make projections. Yes. They're asking us the same thing, right? They're asking us how much money does it cost to build this?
You've seen their projections. Your product team has some projections that are way above our projections.
Yeah, it's
comparison. So, what was the estimates? What was my estimate in terms of cost and building it? What is your estimate in terms of revenue now that I've provided it?
if you see, they make a prediction for $1 million. They make maybe no more than 10,000, but then you have to blame that you make it for 2 weeks more than that than the time. Huh?
Yeah, any estimation is false in the end, but
by definition.
people need numbers. I'm going to skip this. Budget for maintainability, probably self-explaining. The problem with that is if some high-level manager says spend 20% on maintainability, it has to happen within the team. So the team has to own it. There needs to be someone to drive it, and be just like take 3 tickets of this type into each sprint. That's a good start. But someone needs to drive it because otherwise it won't happen. Yeah, takeaways from this talk. Maintainability creates a virtuous or vicious cycle. It's influenced by developer joy, it's influencing developer joy, and so on. So there is this cyclic dependency between maintainability and developer joy and retention and stuff like that. And that's something that people overlook often. Maintainability by default should be our main go-to. When we have a choice to build a thing in a maintainable way or in a less maintainable way, we should obviously choose the more maintainable way, unless there are factors that speak against it, like this needs to be out next week because we have a customer waiting, I don't know. But then create the ticket in the backlog and hopefully don't forget to pick it up in the future. And the most important thing I would say is record and review decisions. Have some kind of mechanism that forces you to review decisions, and be it a broken build, review decisions regularly, ideally in the team, to share the context, share the history, cover your own behind, and maybe find some gold nuggets for your next performance review, like from the decision from a year back or something like that. Might help. And that's it. Thank you very much for your active participation.
You lot bought Abby Loader's DX, getdx.com.
Sorry, what?
Atlassian recently bought DX.
DX.com?
Yeah, the Abby Loader's platform. Oh, okay. I was wondering if you actually
Oh,
use
yes.
that,
Oh,
'cause
oh,
that would be really.
I don't think we're using it yet.
Oh, so you bought it, but you haven't used it?
Yeah, we're also not using the new DR browser from Arc.
Okay.
Which we
Just bought it.
Yeah, just like it's pocket change.
DX looks really cool. I was trying to get.
I've not looked at it.
So every estimate is false. That was my takeaway from the.
Yeah, sorry, I forgot to put that on the last slide.
yeah. Very nice. And I would say that the estimate is false, even the estimate of the conference timing, but we're still on kind of time, which is quite surprising to me. So thank you for the timing. You're a very good audience. So many questions I haven't seen so far, in a conference during the session. So that was very nice. We'll have now 10 minutes, 10 minutes pause, break, and then we start with the last session. And then if the venue doesn't make us leave, we can have a bit of networking. Otherwise, it will just push us away, but I hope we will have some time to network after the conference. So feel free to continue with the questions and then start after 10 minutes.
Well, I think it's so it can get worse, but it can be better. No, it's just an approach to see if it's worse. So hopefully it's a reset.
Perfect. All right, sounds great.
I mean, it's working at like 80%. So it's deep, but it's working. So it's like non-fading
The other reason so to some extent we're missing those that's probably the other way. But there's restrictions like
Okay, I think we can start with the last session of the day. Okay, I would like to welcome on stage Michael. Michael, I can easily say he's an expert in fast, low latency Java applications. So he's a pioneer in the field. So Michael, it's a pleasure. Have the word.
All right, thank you. All right, thank you for coming to my talk. I know I'm the last person in the queue. I know I'm a little bit between you and your families and your drinks for this evening and all that sort of thing. So I hope that I can make this a little bit entertaining. So thank you to my talk, crazy fast and bulletproof applications. First off, any questions? But feel free to ask me questions as we go, rather than saving it to the end. I quite like questions because they make me shape the talk a bit to what you're interested in. So what am I going to talk to you about today? I've got this fairly bold statement about making these things incredibly fast and incredibly robust. How are we going to do that? Sorry about text. It's a lot lighter than I thought it was going to be. So what I'm going to do is I want to challenge your thinking about how you design and architect systems. But in order to do that, I need to start off with a bit of a definition of what I would call a traditional application. Admittedly, this is kind of my definition, but I've shot this talk a few times and talking to people, it sort of genuinely fits. It's history according to me. Then I'm going to start introducing some new concepts, or something that might be new to some of you. This is the idea of replicated state machines, which is an alternative approach to designing your application. I'll talk about some practicalities about running replicated state machines on Aeron Cluster, which is a framework that I work on. And then I'm going to finish it up with sort of a slightly more advanced topic in the space called virtual synchrony. Don't worry about what that is right now, we'll get to it. So let's start off with a little bit of history. So this is kind of dates back to when I first started working in the industry. very first sort of distributed applications that sort of were deployed. Very basic, you build an executable, you deploy it on a machine, and there's a database in the back end, and they talk some sort of database style protocol. And most of the logic was kind of in the client or in the front end itself. These applications were fine, there's lots of frameworks for these sorts of things, like Oracle Forms is a good example. But as things started to grow, people didn't really like doing this. They wanted to centralize logic, and doing all of that with stored procedures becomes a bit awkward. So people started to introduce ability. Wow, that's come out really bad. Sorry about that. There's little boxes in there to indicate, computers in the way. Sorry about that. So people started introducing sort of end-tier style architectures, putting a layer in the middle. We could put some application logic in there, store the data in the database, and then our clients became a little bit lighter weight. Obviously, the sort of using things like DCOM and Core and EJBs didn't last for very long. People tended to trend towards web-based protocols, as things like JavaScript became far more viable for building applications on the client. So that led to much more dynamic deployability. Then obviously, as we progressed, having an API type interface to our server meant that we could deploy other things like mobile applications as well. So this is kind of what I'm talking about a traditional application. And I'm sort of talking about a class of applications which people used to refer to as like OLTP, online transaction processing. It's kind of where you have a system, you have some users, they send requests and get responses back. There's some state associated, which we need to store. But this sort of thing has got a little bit of a problem. One, it doesn't scale until it's not robust, because we've got single points of failure. So as we start to build our system out, we start to need to introduce things like redundancy. This allows us to scale the application logic across multiple machines, and you can't see the boxes, which is really frustrating. But the idea being that we also want to have the database replicated. And most people will typically do this via some sort of database replication protocol. Oracle has a thing called RAC. You might be looking at things more modern like a spanner that exists in the cloud space as well. However, while we've kind of solved the scalability and some degree the robustness, we're still left with one problem. These sorts of systems aren't very fast. And I'm talking about wanting to build crazy fast applications. My pedigree comes from working in capital markets for about the last 16 years. So building financial exchanges, algo trading systems, brokers, that sort of thing. And this sort of architecture doesn't work. And the fundamental reason why it doesn't work is there's a very high degree of latency between application code and the data. And that is one of the key things. If you want to design for performance, you need to minimize the latency between those two things. In an ideal world, the data and the logic that works on that data exist in the same memory space in the same thread. You won't get much faster than that. And the thing is, no amount of optimization is going to get you around a poor architecture decision, certainly from a performance perspective. And obviously some more modern sort of microservice-y type things don't really kind of solve this either. So what we want is an alternative to this sort of approach, traditional, that gives us those things. We want this robustness, so we want a degree of redundancy, but we also want this ability to bring code and data close together. One of the reasons why I know this is the parent company of the exchange I used to work on, they used to do a betting exchange. And they were one of the typical sort of early 2000s .com successes. They built their application with WebLogic and an Oracle database. And over time, they were constantly doubling the number of customers every year. And as they tried to scale up, they were buying bigger and bigger hardware, bringing in all the various millions of different sort of caching products that could kind of exist in the market. But their final trajectory was pushing more and more of the logic into the database, access their stored procedures, because that's where the fundamental performance comes from. So this lets me introduce replicated state machines. This is the alternative that I want to present. So the first question is probably to explain what replicated state machines are. Well, replicated state machines, this is a paper regarding them written in the proceedings of the ACM in 1990. This is not a new concept. This is 35 years old, this paper. And it's a survey paper of the work that had gone on in the previous 2 decades. But what a state machine is, in terms of this, it has a very good definition, is a state machine has 3 main properties. First of all, you have what's called a set of state variables. This represents your data. If you took the very simplest state machine and said it's a counter, it's just a simple integer. But if we wanted something more expansive, let's say we wanted to build something like trade me this way, your state variables would be the aggregation of all your live options currently running in the system. Those are your state variables. It's your state. It's your data. The second thing we need to have is an ordered log of commands that's persistent. So the idea is we represent what we want to do to the system as a command, and when we send it into the system, we store it in this ordered log and we persist it. Then the final thing we need is a suite of deterministic logic that applies the command to the state variables. The idea here is if we have a known initial state and we apply these set of commands deterministically, we'll get the same final state. And the really key word here is the concept of deterministic, because it does limit what you can do. So in our logic, there's certain things we can't do. For example, we can't get the current time. That's not deterministic. If I run that again, I'll get a different time. Can't generate a random number. Can't do I/O. Can't go to a remote system and do a blocking call and fetch something from a REST service. So you're kind of limited in the logic that you can apply. That's quite good, because all you want to do is update those state variables. Any other information you want to bring into your system has to be represented by a command that ends up in the log, so it can be done deterministically. The other final thing that's more of an optimization, it's not necessarily, not absolutely necessary, is we have a concept called snapshots. And the idea of a snapshot is we grab all the state variables that we have at a particular point in time, or more specifically, a particular point in the log, and we capture them and store them. This is an optimization for recovery. We talk about, if I get to my initial state and I replay the log and get back to the state I want to have, I can optimize that by grabbing a more recent snapshot and only having to play forward from that point. So this can have a significant impact on things like mean time to recovery. Now, we've got the two things that we're after. We've got a degree of robustness. If this system crashes, I simply start it again, load my latest snapshot, replay the log, and I'm back to the same point that I was in before I crashed. So that gives us a degree of fault tolerance. This is the bulletproof side. The second thing I've done is I've managed to co-locate my data and my logic, because that's fundamental to the design of replicated state machines. So now we've got this log of all of our requests, we've got this deterministic application. The key question is, well, what about multiple machines? Because ideally, we don't want to have a machine crash and that be the end of our system. We really like it if that could be copied to multiple machines, because we get the same thing. If we have an initial state and the log of another machine, we get the same memory state. Anyone know a good way to do that? Raft, Paxos, use that replication. They already exist. Algorithms that have been around for building up, Raft has been around now for 12 years. Paxos has used that replication since the late 80s. We already have really good, robust algorithms for taking a log and copying it to another machine. Because if you're reading any of the papers and research on stuff, that's exactly what they do. They're basically, a consensus algorithm is there to ensure that a log is replicated. So by using this approach, not only have you got some data or some configuration management replicated, your whole application is now robust to the same degree that you can make a Raft application robust, which is pretty powerful sort of a thing. Worth talking a little bit about some of these consensus algorithms. So the first three I mentioned up there are what called fail stop. So they're fault tolerant, and what they can do is they can tolerate an individual node failing such that it simply stops. So that this is kind of the, if anybody's talking about network partitions and CAT and that sort of thing, basically that node stops responding and stops receiving. There is another type of failure you get in your systems. If one of your nodes start misbehaving, it sounds extra data or not enough data or the wrong data. That's what's called a Byzantine failure. There is actually an algorithm called practical Byzantine fault tolerance, which can actually get over this, but it's quite a lot more complex. So Paxos and Raft and Vue replication are based on the idea that you need to have at least 3 nodes in order to survive one failing. Byzantine fault tolerance increases that to 4, so you have to have at least 3 live nodes to prevent failures. Interesting to know, anybody see the name Liskov there? Anybody recognise that name? It is the same Barbara Liskov substitution principle. Quite a genius. Lots of work, because distributed consensus is probably one of the hardest things that we can do in software. She also a bit of a master of language and that sort of things as well. The interesting thing about practical Byzantine fault tolerance is it's not actually all that practical. There's a really good bit at the end of the paper when you get all the way through it. It's a really good paper and it's very interesting. And then it says, well, there's a problem. This is designed to help security. So one of the ways you get the Byzantine failure is somebody's broken into a system and they're making the nodes misbehave in order to try and cause a denial of service or get it to leak secrets or something like that. There's a bit that says, oh, and by the way, to avoid security bugs in compilers and operating systems, you should write 4 different implementations on 4 different operating systems for your 4 nodes. So I work on a Raft implementation. We've done 1 implementation in Java. I would hate to try and write 4. So, and it is more complex. So I just want to talk very briefly about the Raft algorithm, mainly because this is the one I know the best, and this is the one that we actually use. It works on the basis of a suite of remote procedure calls. I won't go over all of them, but I'm just going to go over this key one called append entries. This is the idea where you have a leader node. What it does is it sends all of the data that it's received over the followers for replication. And what it sends is the current term. You'll see what a term is. The previous index is where it was up to and term that it's sent previously. The list of entries, so these are the new bits of data it wants to replicate. And then this final thing, which is leader commit. That's the value that the downstream followers can now pass on to the application as a result of the leader deciding that's what the cluster has agreed has reached consensus. So it's got new data plus a marker of where everything should be up to its older data. And it just responds with the term ID and 66, that's what the followers come back with. I thought I'd bring this up because I'm going to come back to it in a little while. And then within Raft, it has a leader election process. So the idea of standard Raft is you have a bunch of nodes, they all start as followers. Then after a period of time, called a leader election timeout, they go, right, oh, nobody sent us any data or any heartbeats, let's start a new election, agree a leader, and then some of the one candidate will become a leader, the other candidate become followers, and you get essentially what's called a series of terms. So the sort of blue when the election occurs, then there's normal processing of messages where it's replicated amongst the nodes. If there is some sort of problem with the leader, there will be a new election. There can also be cases where you don't actually get a leader. That's because of the way the Raft algorithm works. So I mentioned a couple of other algorithms there as well, view state replication and Paxos. I thought it might be interesting to talk a little bit about what's the difference between them at a very high level. If anybody's really interested in this sort of thing, you should have a look for work done by Heidi Howard. She's done a lot of research into various different consensus algorithms, how they interact with each other. And part of her research is she took Paxos and represented it like Raft to try and compare the two of them. And what she found is the only fundamental difference between them is the way that they determine which node becomes the next leader. Raft has a very simple approach. It says the next leader is the one with the most data already. Because if you imagine you're replicating amongst nodes, and there's a point where you've agreed what's committed, but then there's an extra data there as well. So they're going to have potentially variable amounts of data on each node. So it takes the highest one. You can get a collision, so you can get 2 nodes with the same amount of data. In that case, it basically fails the election and does kind of a random back-off. And then it's kind of a first one wins style approach. By contrast, Paxos, what it does is it knows which one will be the next one. It's got basically an ordered list. So it will jump onto the next node. But because of that, Paxos has an extra step. It's got to then go copy the data from the node that has the most data onto it. This tends to mean that Raft has a faster mean time to recovery. So if you get a failure in a new election and you elect a particularly bad node, Paxos could potentially take a long time to recover because it's got to go copy a whole bunch of data first. Whereas the slightly more efficient way of Raft is going, oh, we've clashed, let's back off for a random time and try again, and somebody will eventually win. It tends to resolve itself much more quickly. So that's kind of a little bit of a whistle stop tour through distributed consensus and the concept of replicated state machines. Now I'd like to talk a little bit about Aeron Cluster. So this is a project I work on. I work for a company called Adaptive, and I'm custodians of the Aeron project. And Aeron Cluster is actually a layer on top of two other products. One is called Aeron Transport, which is a very famous messaging bus. It's oriented around UDP and IPC, so it doesn't use TCP. It supports multicast and a kind of a fudge, we call it multi-destination cast, to do multi-distribution in cloud environments. On top of Aeron Cluster, we have a thing called Aeron Archive, which where we take streams of messages from Aeron Transport and we just write them to disk. And then Aeron Cluster on top of that is an implementation of the Rust algorithm that also behaves a little bit like, well, say a little bit like, it is an application container. So if you're building an application to work inside of Aeron Cluster, you've got an interface that has the sorts of lifecycle methods you might expect. You'll get a start method with an initial snapshot for you to load up. You'll have a callback every time a message comes in off the log. You'll get additional callbacks for things like timers. And then you'll get additional calls for when you need to take a copy of your state and write it as a snapshot. So if anybody's sort of worked in sort of container type environments, that's what it ends up looking like. The interesting thing about practically implementing Raft is that we had to depart a little bit from the Raft protocol. So first off, when you represent something as a remote procedure call, there is a slight issue with it. Having worked with high-performance distributed systems for a long time now, one of the things that's, in my personal opinion, if you're using remote procedure calls, like things like synchronous, like gRPC and things like that, it's fundamentally a poor decision. Because if you're on a node and you're requesting something from another node, what happens if that doesn't respond?
I'm on.
Yeah. How long can that take under TCP?
60 seconds.
60 seconds, 2 minutes. So if you do a naive implementation of Raft, which says you use these remote procedure calls to send data to a node, let's say you've got a leader with 2 followers. You send the follower A, it has crashed. 2 minutes later, eventually you find you get an error back from your request, you get that timeout. In those 2 minutes, follower B says, oh, we haven't got a cluster anymore because the leader has been blocked waiting for this decision from follower 1. And you can actually have the cluster fail because it's detected a leader timeout. So if you are sending data to followers from a leader, you have to be concurrent. You have to essentially send messages out. I think in the paper it says you need to do it in parallel. We tend to not think about it that way. We tend to use it more like a multicast type bus. We distribute the messages out to all the followers concurrently. So we represent an append entries RPC as a stream, as an archived stream of messages called the log that gets received by the follower nodes. Because it's not a, sorry, yeah?
So how different is this from etcd, the etc?
Significantly more robust and significantly faster. Yeah. So etcd probably doesn't do the same level of asynchronous mechanisms. They might do it in parallel to avoid some of these issues, but we think our implementation is significantly more robust because we've designed it from asynchronous from the bottom up, and it also, when we do responses, so we don't do a return value on an RPC, we're just sending append position messages back, and we're also batching that too. So what it will do is it'll go, how many messages have I got? All right, send the append entries, the append position message. The next time it goes back, we're not going to do a append position for every single message that's there. We just do it for the highest one because we're assuming that there's no gaps. The transport layer fills the gaps in for us. It does redelivery gap filling for us.
Is it the same as what Kafka uses for the new K, the new Raft implementation, K-Raft?
I don't know how theirs works. Okay. I would put money down. I'll bet every dollar I have in my pocket that ours will crush it by a factor of 10. So people have built financial exchanges on top of this. Okay. One of our biggest customers is Coinbase. So this is live in production systems, numerous exchanges working on top of this. So
because it's UDP, right?
Yeah.
So how do you know that every single node in a cluster is the same?
That's provided by Aeron Transport. So Aeron Transport, our messaging bus, does loss detection, negative acknowledgements, redelivery. So it's a reliable messaging bus. Yeah. So if we drop anything, so that provides guarantees of ordering. Like for example, if there's a gap it won't surface the messages after that gap until those gaps are being filled. So it's got flow control, and it's got a lot of properties of TCP, so a lot of reliability guarantees, but it doesn't have things like slow start. It is also message oriented versus stream oriented, like TCP works on bytes, it doesn't work on messages, UDP works on messages. So it's kind of a blend of the two of them, and that's what gives us the robustness. So we're kind of relying on that thing below us. So we're getting these append entry messages back, and then we're sending back commit position messages from the leader out to the followers. And when they get those commit position messages, they know how much data they can then surface up to the applications. I mentioned previously that you can't grab timestamps because that's not deterministic. So one extension that we have over Raft is that the leader will take a timestamp as the message comes in and puts it on the message in the log. So now you've got a deterministic timestamp. Building on top of that, we have timer services built in as well. So if you want to create a timer to fire in 10 seconds time, there's your service built into cluster for it. We also have an additional state called Canvas. This is not in the Raft paper, but it is in Diego Aguro's PhD thesis. He calls it pre-vote. So if we remember the Raft algorithm at the beginning, what that would do is all the nodes would start up, and then they would wait for a timeout. So what this does is it sends a message between all of those nodes to say, can we do an election right now? And if that comes back true, there's still an election straight away. So it speeds up that initial time to start. Because quite often, your leader timeout has to be quite long. Your leader timeout needs to be longer than the expected pauses in your system. So these are things like garbage collection. So if your GC pauses could be as far as 2 or 3 seconds, which they can be, your leadership timeout must be higher than that. Otherwise, any of the GC pause you're going to have is going to cause leader election, which is probably not a useful thing to do. So it takes some tuning. But that speeds up timeout, and we also have asynchronous capture. Yeah.
Is this commercial or open source?
Here Cluster is open source. We've got extensions and stuff on top, which is proprietary. So, and it's all Java based. So I'll talk about some of these extensions. Okay.
So just one more question.
Yeah.
You think you should be able to use this in a Kubernetes cluster or
Yep. Yep, we've got customers to do that. Yeah. A lot of pain goes into making sure it works in Kubernetes, much to our chagrin, but yes, it does work in Kubernetes. So we're doing a lot of engineering. There's really cool optimizations that we've done in some Kubernetes cases as well. Yeah, one of the things we can do is because we have this transport as a separate process, one thing people have done is they run the driver on the native hardware, and they run all of these things with different clients talking to this transport driver. So basically, it's in-memory IPC between the Kubernetes node and the Metal node, and then at that point, we're getting all the hardware optimization. It is significantly faster than Docker networking and Kubernetes. So quite a neat optimization that one of our customers actually did. So I want to talk a little bit at a higher level about how you would build an application using something like this. You're not going to stick a replicated state machine in every single part of your system. Certainly for the systems I've worked on, there's kind of a core, an important part of your system that needs to be powerful and fast. It's kind of your moneymaker, really. I like to use the auction, like trade type system, as a good example for this. This particular one uses a financial exchange. But the idea is that your core services, the bit is built around this high-performance replicated state machine, would be the live auctions. Because these are the things you want to be hot. You want them to be fast. You don't want that, if somebody's bidding in that last 2 seconds before an auction, you want to make sure you get those responses back quickly. So that's the bit that we stick in the middle here, inside of this service, inside of the replicated state machine. Around the edges, you're probably going to have some form of gateway. You might have web gateways. I've put Fix up here. If you've never used Fix, great, don't even think about it. But it's pretty common in the financial services space. So the idea of gateways is they're stateless, but they're doing things like border security, protocol translation, there might be a degree of session management for users, that type of thing. And they're sending you messages into the cluster via whatever format you happen to use. We often recommend binary protocol for performance, but whatever happens. And then you could have other gateways which are receiving events out of the cluster as things change and forwarding back over to clients as well. The other really important thing I wanted to point out is this concept of a history service. So the one area where these types of applications aren't great is when you're dealing with very large volumes of data. Lots of historic data you want to query and aggregate, all sorts of things. You don't want that in the high performance part of your system. Going back to the trading example, you don't want all of your old auctions that have already completed sitting in the hot space. So you basically forward, essentially messages as they go, so that you can build up this aggregate history. And then when the auction closes, you could just evict it from, remove it from the various collections and evict it from memory in the hot space, and then anybody who's querying for the history of their auctions just gets forwarded over to the history service. So that's an important distinction to make about what is the best solution given the type of operations that you're trying to achieve.
Should we wait for the acknowledgement of all messages to be sure that it's already there in the historic service, or we don't care?
Don't care.
Okay.
Okay, there's ways that you can basically, because you're on cluster, everything that reaches there, we've got that recorded in the log. There are ways to implement this such that if one of the nodes fails, you can recover and catch up and rebuild it. Certainly that's what I've done in the past. So there's various tricks that you can do there. I can't go into all of the implementation details because we haven't got that much time, but yeah. So you could wait for acknowledgements from here, potentially. So you just have an event coming back out to your gateway, and we know that it'll eventually reach the database at some point in the future. But I talked a bit about performance. I talked about how fast the system is. So the idea is that with Aeron, we have a goal. There's a number of principles. We have a goal to ideally be running at the speed of the hardware. We try not to be much in the way of overhead. So I've got some benchmarks to sort of indicate the levels of performance that we aim for. So this is running on AWS. What we're doing is we're sending a couple of different message sizes. We've got a client, we're sending this into a cluster. This has a little application that's just echoing the response back. So we're measuring the latency backwards and forwards. We're ramping up the volume and trying to not blow past this target of 99th percentile latency less than 1 millisecond. So this is running on AWS. You'll notice that I've got a couple of others. This is our Java. I've got Java here. For our driver, just for the core networking bit, we have two implementations, one in Java and one in C. So that's the results of the Java one. The C one's actually oddly slightly slower. But the benefits of the C one is it's much more efficient to plug in other functionality. This CATS is Aeron Transport Security. It's one of our commercial plugins that does on-the-wire encryption. DPDK, which is lots of fun, is a mechanism for doing kernel bypass. So this is a way that when we get a message, rather than using the operating system to deliver the message, we talk directly to the network interface. The reason I've presented DPDK up here is it's supported both by AWS and by GCP. And you can see the performance difference versus, we're getting 5 times the throughput. We're hitting 1 million messages per second with a 288 byte payload. Even with encryption turned on, we're getting 800K. That's faster than without ATS and without encryption. So there's kind of a big win there as well. But yeah, these ATS and DPDK extensions are some proprietary things that people obviously pay extra money for. This is kind of similar information. This is to give you an idea. This is flipping it the other way. This is running on a C5N 9x large and it's using a custom placement group. And we're running at 100,000 messages per second, and it's showing the various latencies. Again, with encryption and kernel bypass enabled, the 99th percentile is around about 150 microseconds. So this is kind of entry grade for financial services applications, trying this to be as fast as we possibly can. And to remember that your application is just code updating the memory structures. That's all your application is. So you can get this sort of really particularly strong performance out of your application as long as you're not doing anything. So it comes back to when you actually write and replicate state machines. You're often thinking a little bit about computer science 101 and 201, what algorithms you were using, what data structures you were using, type of thing. So that covers off kind of what I wanted to talk about on the practical side. I want to introduce one last concept called virtual synchrony. I have to complain to the people that created the template for the company. So virtual synchrony is a concept pioneered by Kenneth Berman in the late 80s. And the idea of virtual synchrony, if you ever go look this up, is it will talk a lot about atomic broadcast. And atomic broadcast is a mechanism that's quite similar to what we're doing with this distributed log. It's a way of copying messages to multiple machines reliably and with a known order. And most of the definition of virtual synchrony is around this atomic broadcast, which we're able to substitute for a distributed log. We can basically get that sort of thing there. So the other part of virtual synchrony talks a little bit more about replicated state machines. And it talks about state machine composition. The idea of this atomic broadcast is a way of getting to the point where we can have multiple state machines in multiple places, but because we can assume an order and we can assume reliability, we can actually compose things in really interesting ways. And it probably serves us to have a little bit of an example. Let's imagine a system, you can kind of ignore distributed log for the moment, but I'll just kind of put it in there. The idea, let's say we have a client and it's going first to our account service to update our risk profile. So the idea is we've got a matching engine here, which needs account information, and there's some sort of risk limit, some sort of maximum sort of order size that our customer is allowed to place into the system. But the information for that is managed separately by the account service. With a system like that, if the client sends a message into the account service, at some point in the future, we're going to send a message over to the matching engine. But we've got like this eventual consistency problem here. So if I send a message in, the client needs to know whether the matching engine knows about that account change before it sends a message to the matching engine, because it might fail, it might use the wrong risk profile. But we've asserted that actually our distributed log is really fast. We can do things in a pretty optimal way. What if we change this around a little bit? Share the distributed log. So the idea here being that we've got a single log, a single ordered set of messages. We push the message into our account service. Now I've put a deliberate separation between those two things. So the account state machine is all of the state. The service around the outside is doing all of the stateless stuff. It's doing all the transformation of data, taking the events coming out of the state machine and sending them back to the client. So you can think about this account service as kind of being stateless, and sort of doing proxying and sort of adapting and translation for us. But because we know these things are ordered, we could take this account state machine, just the state machine but itself, and actually put it inside of our matching engine service. So we've grabbed the state and integrated it into our system. So now we don't have this eventual consistency problem, because our message going to the account service, it doesn't matter if that sees that message ahead of the matching engine. It might. It responds back, but the client knows that if I send an order in, it's going in behind that change to the account state machine. Because this is executing the exact same logic and will have the exact same state. Even down to the point, let's say this thing did a validation on the incoming request and rejected it. This would also have to reject it. Because our logic is deterministic, it must be deterministic to fit into that state machine space. So this becomes a really interesting way to start composing systems together and making them more efficient. And we're in the process, the current project we're working on now is actually building, it is commercial, but systems allowing this sorts of composition of systems. So that brings me to the end. I'll just sort of do a quick summary. I'm hoping that you've got a little bit out of this. What I really wanted to do was try and challenge thinking, like get people sort of thinking a little bit out of the box with regards to how they design their software. I think there's a lot of rich approaches to building software that come through, certainly in my experience in the financial services space, that don't really come out of it. And a lot of it's based on really solid academic reasoning and lots of powerful foundations for those. So it's kind of surfacing that out to see how many more applications can be built this way. Because I think a lot of the properties you get, being very, very fast and very robust, are desirable for lots of different applications. Replication being a powerful application abstraction, and then state composition is kind of the next level beyond that, thinking about if you understand replicated state machines and start to understand how you can get interesting designs by composing these state machines together to give you much richer and robust applications. Thank you very much. Is there any more questions before I close up? Nope.
So Michael, thank you very much for the very interesting talk. And with that, we've finished all the sessions for today and for the conference. Just before we wrap up, a few words from us. So if you liked the event today, the sessions and everything, next year, again in November, we plan to do the same.
I'm not sure if it's November. You suggest which is the right time for such a conference?
Yeah. Okay. So let's say November, December, something like that. So if you really enjoy the content, the format, spread the word towards your colleagues, your companies. For us to be able to run an event like this, we also need to have like some sponsors. So next year, if some of your companies are willing to support us in the local Java community, just let them contact us. So yeah.
Yeah, this year we did all on our backs, and it wasn't quite heavy, but we would use a little bit of help. So if any company wants to support it, we will have some decent sponsor packages, and this will also include more guests from the said company, so probably more people in the hallway. So if you can spread the word to your company, that would be very appreciated. Also talk to your friends and suggest us a date or a month at least. I understood on lunch that November or December maybe not the greatest time because it's already summer, so probably early the year. It will take a little bit of time to prepare it for such a shorter notice since it's like 50,000 or more kilometers to travel. But still, we can do it. We managed this year, so we will do it next year as well. I think we don't have any feedback form prepared, but please, if you have any feedback, find Martin or myself in LinkedIn. You know, our names are on the website ChurConf.com, so you can easily find us and tell us any suggestions, feedback, or whatever you think we should change or we should have changed. Not possible in the past, but truly in the future, it should be. Yep.
And most importantly, I guess you're already there, but if you haven't joined the Auckland JVM group, Rob is here leading the group. So if you have an interesting idea about the talk, just suggest it to Rob and do it either on-site or in person or online. So yeah.
Yeah, special thanks to the JVM group. They also gave us a little bit of lift to do it. So next time probably it would be better. And if you know a speaker that would also you want us to invite or you to invite, please also tell us. I think today we had great speakers. Some of you told us. Sorry?
I second that.
Yeah. Some of you said more local speakers needed to be here, so suggest which are the local speakers. For us, it was and not only for us but for the speakers as well. It was quite a challenge to bring anyone all over the world. So if you have someone that needs to be invited, tell us. We will do our best as well.
So again, attending today, and yeah, we are happy for any ideas eventually for next year. I think now we might have some more, let's say, maybe 20 minutes to...
Yeah, half an hour networking. If someone from the staff come and say, okay, you need to leave, but otherwise you can continue networking here.
This area,
yeah. No more stuff left. I think even the coffee is already running out. Martin just did a coffee that was almost like water.
But it was still nice. So.
Because you put that much milk. Okay, so that much from the official part. Thank you very much.